Wait, bro, A4 is just.
Yeah.
What? Wait. What's going on? I'm confused.
Did you use heads of A4?
I don't know. It sounds pretty dumb. Wait. What? I'm confused. Wait. Oh. Okay. This is a very artificial form.
Yes.
Uh,
So Dave and Liam came at the same time.
oh,
Interesting.
this is dumb. What's this? Yeah. Oh. I don't know what A2 is. Oh shit. Wait, this is so stupid. This is so stupid. Bro, it's literally school math.
Yeah.
Like, actually school. Because like they probably wouldn't teach you like HM. Okay.
Oh yeah, but you don't need HM. You could swap it with CSI.
What? Because like the H too, you get one of them.
Yeah. But you could still use. Couldn't you still use?
Oh, because like you still get it. Yeah, you still get HMG.
Did you already purchase the pizza?
Yeah, because they're not open for lunch.
Oh.
So like,
It feels like it'll be
I
cool.
got it last night.
Are you gonna heat it up?
Yeah.
Ah.
It's in
It
the
feels like
fridge.
it'll be a good idea to exercise before we eat the pizza. To improve our pizza eating.
I don't
It's
know.
like, look at the size of the pizza.
I can barely walk, man. I have to figure out how I'm gonna participate in this exercise. But
You can sit on the sidelines and clap. Yeah, cheerlead.
I'll call fouls on Liam.
Oh yeah, you can do that.
Oh, should do Liam versus everyone else.
Oh yeah, let me move the huge box. It's just for show right here. Let me pass it over.
We should do Liam
There's
versus
nothing in the
everyone
box.
else. Then Liam can
Oh,
get
wait,
another
oh,
there's
Kid
nothing
thing is
inside.
Yeah, well, I couldn't just leave it outside.
Well, you just hit the shop.
I wanted to though, because I bought it at like 10 p.m. Like when they closed.
Oh.
And I wanted to kind of just leave it there and not even have to heat it up, but we ended up putting it in the fridge.
You should do Liam versus
Do
everyone
they sell
else.
any other supersized food?
Huh?
They seem to sell pizza, pasta, ribs, salads, and desserts.
No
Do they sell
way.
like supersized desserts?
I feel like if they just specialized in pizza, it would be fine. Unless they're passionate about salads or desserts or something. You know what I mean?
No, it's really like just Italian food.
Huh?
It's really like Italian food.
Yeah. Join the live stream, people.
Bro, what is A3?
A3 is actually hard. What the hell? Juniors are gonna die in 8th grade.
Oh man, I can't do inequality.
Bro, it's an inequality.
Why
Like-
can't it just say positive
Wait, have
integers?
you unlocked Evan Chen's inequality unit?
Why do I have to say real numbers?
But go to
Preferable.
Now we actually have to struggle.
unlock an inequality unit, do the inequality unit, become good at inequality, and then you can unlock more than because you can unlock more than 3 units. Somehow this
As inequality basically.
you could go to manage units. Manage units. Click units. And go inequality basic. It's basically just automatic.
Oh.
Maybe not.
Bro. Yeah, you can unlock. It's used harmonic,
I mean,
symmetric polygon.
this is just the first thing. I haven't done it. Oh yeah, I sold G5.
Ooh, nice. What did you use to solve it?
Stone. It was very interesting.
Yeah, probably would be a good idea to go do the exercise break before eating the pizza.
Okay, Liam.
Oh yeah, wait.
Nah.
No, bro. Billy had it.
You can literally
Starving himself.
you could do mental exercise and work.
Actually, I suppose you do burn a lot of calories while thinking.
Yeah.
Yeah.
Use brain.
Inequality.
Because a lot of people don't think about the mental aspect when they're like, oh, I need to burn calories.
Yeah. Oh yeah.
Just for like 10 hours.
They're like,
Maths-
oh yeah, I'm
maths
just
for
going
weight
to the
loss.
gym and I'll like run and stuff.
Run and play chess at the same time.
Burning calories for the
Don't think
sake
about
of
day
getting
off
dinner
like
is
chess.
boring.
I'll do some math.
If you want to like exercise, you need to like achieve some goal. Like learn to do something that's cool. like
Yeah,
a muscle up.
muscle.
Oh, that's what
Yeah.
If I learn
index is
muscle
really.
up, bro, then I can flex muscle ups on Michael. You can't even do a pull up.
Wow,
Oh,
yeah.
pull up.
That wasn't very
And I have to also
nice.
try and learn like the plant.
Hmm.
Do you know what a
Learn
plant
to
is?
do
Liam is
flag
growing
things.
both mentally and physically.
Wait, really?
Autism is a free, bro. It's like impossible.
Ridiculous.
Bro, it's probably some AMGM. Because they wouldn't use any other inequality.
I mean, yeah, but I don't know how to use it. Maybe it's not. Surely it's not rearranged. There's no, it's rearranged.
Wait, what else is not good? As soon as you mess it up before looking at the next one, I think.
A? No,
These are the cheaper things.
yeah, that's not that. Well, A3 is so strange. I don't know what to do with it. What do you do with this?
It's so. It's like a standard inequality presented in a non-standard way.
It's okay.
Because it has the added element of translating it into a logical inequality.
Okay. Just step one is instead of finding minimum value, find maximum. Wait, how? Wait. That's not necessarily.
Oh yeah. You know that inequality that Daniel presented in class
How long ago was this?
a while ago?
Okay.
That one from his school trial test.
Oh yeah.
Somehow, my school teacher found that inequality and like presented it to my class as a problem.
Oh, and you solve it
Okay,
instantly?
but did anyone solve it?
Just the
I
I think
problem.
the teacher solved it.
How, wait, we're using what?
I don't remember.
Did they
I think
use
it was
like
similar to what Daniel did.
Is he
like the
still in?
multi-term Hershey thing? Like,
I think it was similar to what Daniel did.
Holders?
Is it still in?
No, it's not Mr. Lin, Mr. Berry.
Oh,
Yeah, he somehow found that inequality from the James. Supposedly only like 3 or 4 students solved it.
Yeah, I mean it's not a great question to put in a trial.
It's just like stone because the try only lets you use A and B.
You know.
2-term A and B.
I mean like it's kind of like a random. It's like a very small topic, but it decides who like comes first in the trial and stuff. It's kind of.
Stone.
And that's why you got to do Olympiad.
Exactly.
The only 3 who solved it were Olympiad people.
CJ, Daniel, and who?
I think it was Jason Fan. Or something.
There's some other Olympian people. I mean, the thing is, like, the trials are 3 hours. It's like,
3 hours. So
okay, well, that makes more sense, like, they were able to solve it at least.
yeah.
Because our prelims were, like, 80 minutes.
Oh what?
Yep.
That's highly not indicative. But then like it's extension 1 I think might be 2 hours in the HSC as well.
Because, like, I was at 80 minutes, so it was extremely speed. And that's why I failed extension. A, B plus C. What the hell do I do with that?
David had a very good idea. Square the a squared plus b squared plus c squared plus d squared. Because then you get an a and g evidence.
Yeah.
Are you sure about that?
There was a AIMO question similar to this one in like 2009, 2000. I forgot which year. But
Really?
yeah.
I'll use AMG on this thing, cause like. Actually, bro, this is too confusing. You relate the squares to like this. There's something about yeah.
Which one?
What did you get? I don't know what I'm doing.
You have a squared plus b squared plus c squared plus d squared. Shouldn't a and g basically just get it into the form of things we know the value of?
Okay, so you want to minimize the a plus b plus c plus d, right?
Yeah.
Okay, but when you square it, you either want to minimize it or maximize it. Because it might be negative. Okay, so if there was a positive value, then there is a negative value because if we make everything negative, it still satisfies those conditions. So a plus b plus c plus d gets made negative, right?
But no, a plus c plus.
Which means that
You minimize the value on squared and automatically minimizes a plus b plus c plus d.
no, it says
You're not
ABCD
listening to
real
what he's saying.
numbers. It says they're real numbers.
Oh yeah.
Yeah, so like basically what I'm saying is that if a plus b plus c plus d was positive, then you could make it the negative of that.
I see.
Because it's only so therefore we want to maximize a squared plus b squared plus c squared plus d squared. How would we do this?
Pretty interesting.
Yeah, that's the problem, because a squared plus b squared plus c squared plus d squared, that's like the AM
Yeah.
side. So it's supposed to be larger than something. We need to make it smaller. Pretty weird. Because like if you were just given like one of these conditions, then it wouldn't be valid. But like you get given all four of them. So. Is it time to pull out the Lagrange? Wait, I don't even know how to do Lagrange on multiples. Okay. First thing, how is this bounded? I need to figure out how this is bounded. Okay, let's see how this is bounded. So if it went really large, one of them would need to be really large. Say A is really large. Then A appears in these guys. Tell me that B, C, and D have to be really small. So that this isn't really large. But then these guys, they don't really do anything. So if A was really large, then they would all equal roughly the same thing. Nah, not really. That's not even true.
Wait.
Huh?
You know how you get a squared plus b squared plus c squared plus d squared is greater than plus 26 is equal to the thing squared, right?
True. Yeah.
Then you can just use AMGM to get a squared plus b squared plus c squared plus d squared is greater than or equal to ab plus bc plus cd plus da. That's just A.
AB plus yeah.
And then we know what the value of AB plus BC plus CD plus DA is. And then you just minimize it to be that.
No. But the problem is you don't find the minimum possible value of A plus B plus C plus D.
True.
Not the square. You have to be careful.
So we need to know if it can be negative, right?
It can be negative. If it can be positive, it can be negative.
Oh, so that's the maximum.
Yeah,
Oh.
that's what I'm saying. I don't even know if it can be positive. I don't even know if there's a solution.
I think there is a solution.
It can definitely all be negative.
And you just have to find like where there isn't a solution.
If you set one of them equals 0,
One of them is zero. Okay, that's a good idea. Then CD, BD, and BC 4.5. Then you get solution. What do you get as the solution? I don't know.
How do we find the maximal value of A squared plus B squared?
Then you times them, you get 4 times 4 times 5, that's like what? I mean, that definitely. Okay, there's a solution if you set one of the zero. I think so.
This is a non-trivial inequality. It's not just some basic simplification in A and G.
Yeah, this is like
Juniors are going to
kinda
suffer on
crazy.
this.
This is
Yeah,
kinda
we are.
crazy.
No, like people get into junior camp.
Oh, okay. Oh, that's not us then.
It's like when you get AMC perfect score in year 6, and you go to junior camp and you have to do this.
Right.
it's the punishment for guessing.
A3.
Yeah, like people do. It's like the punishment is not we retract your score. The punishment is we invite you to senior camp.
Yeah.
Punishment is you get tortured.
What?
Lovable.
It's really hard. A squared plus B squared plus C squared plus D squared is majorized. There's nothing that majorizes. Oh wait. Could you?
This is so amazing. Let me think.
It's the absolute value.
What?
But it's the absolute value of A plus B plus C plus D.
Oh.
People all overthinking.
I thought those were square brackets because I couldn't see.
No, it's absolute value.
Oh my. Okay,
It's
now
not a
okay,
stone
okay,
problem.
We are doing A plus B plus C plus D squared. Okay, it's all good.
Now it's no longer a stone problem.
Now none of us realize. What the hell?
Right. Going from stoned to trivial.
Okay, it's not true.
Not trivial,
Because
but
the
like,
thing is, like, you could try to use AMGM, but like,
no, AMGM literally just gives you a.
really.
Because we already know it's plus 26, and we know A squared plus B squared is greater than or equal to this, and we know there's an equality case.
This? Yeah. Okay.
Wait, are you
So-
claiming to have solved it again? Are you claiming to have solved it?
Wait, what do you mean it's greater than? Wait, hold on. Where did you get this shit?
Yeah.
A plus A, B plus B, C plus C.
Because you can sum up individual pairs of this, right? And you get 2A squared.
Okay.
Yeah.
It does make a good point.
What the? Okay, but how do you involve all three of them?
You don't. Because you don't
Do
need
you
to.
need to all three of them,
I
or do
think-
you only need two?
You only need 2 because you can do AB
Okay.
plus CD equals 4, and AD plus BC equals 5.
Five,
So it's
okay.
greater than or equal to 9.
Okay, now you need to find a solution. That's the question. Can you find a solution? This is the question. Okay, if you find a solution, then it has to be the equality case, right? So it
Yeah.
has to be AB equals CD and then AB equals C.
3.
Yeah, it's the equality case.
Wait,
Or
is
something
it
like that.
26
Yeah.
and 3.
Also, wait, no, not that. No. It's like a squared equals b squared. Hold on. No. I don't know if that's That's a good enough bound.
Yeah.
Because like you're adding up the a squared b squared over twos, right?
Yeah.
So if you want the equality case, then you need all of them to be equal. But clearly they're not all equal. Right. So you might not have a good enough bound.
Oh no, you
That's the issue. What do you do in this situation?
I think like we know it's like the equality.
Transform.
It can't be the equality case because AD plus BC equals 5, whilst AC.
Yeah,
Yeah.
which means that your bound is not good enough.
Yeah.
Oh, what?
Wait, it's great. We know it's greater than or equal to 9. We just need to find a case where it is equal to.
Yeah, but if it's equal to 9, then your equality case has to happen.
Oh wait, no.
Not the
An equality case it just can't be. They're all equal.
Yeah.
Yeah.
Can you get the maximum bound from AM? The minimum bound from AM to PM?
What do I do?
You think that's a possible value?
What do I do, bro?
There are going to be so many juniors who will reach a squared plus b squared plus c squared plus d squared is greater than or equal to 9 and go, the problem is solved.
Don't know how to do that.
Yeah.
It's time to pull out the Lagrange. But actually, I need to learn Lagrange to like multiple steps. I don't know how it exactly works. How does it work? I didn't. I thought there was a square bracket there. Actually, absolute value.
Wait, can't A, B, C, D be irrationals all? So you can't do this in the line.
A, B, C, D can be irrational.
Yeah, so isn't it 26 and 2?
Why?
Really?
Because it's like 3 times all that.
Huh?
26 on 3 is less than.
What?
Isn't this thing equal to
It's definitely
17?
greater than. Yeah.
Then the 2 times that is 26. Right?
Yeah, so you get plus 26. Yeah, but now I'm just looking at this part.
Yeah, isn't that greater than 26 and 3? Right?
You did like.
How did you sum it up using AMG?
2 at a time, or anything?
That's what I did.
Oh.
Isn't it?
He added
It's
all
like
of them.
26 and 2.
Yeah, but he only did 2 of them, and this is the 2 biggest ones. So then he gets the gaming.
26 on 3.
Yeah, but can't you just take the top one and then you get an even better map? You just take the top one. Wait, what were you saying is greater? This sucks.
These both can't be true. I think you must have made a mistake.
No, that's both true.
Because if this is always greater than 9, oh wait,
It's
Also
also
weaker
true
bound.
that it's greater than 6 on
true, but this is stronger bound.
You need logic.
My
You need
logic,
some basic logic being taught here.
logic is sadly not something. Now I just
Okay,
need to look
now
for
I do AD plus BC is less than or equal to A plus B on 2 plus B plus C on 2. So A plus B plus C plus D.
Right.
A squared plus D. Well, I forgot to write the squares. Is greater than or equal to 10. So it's actually 10, bro.
But how'd you get 10?
You just do one of them. You just do A, D plus B, C. Fine, just take that.
Bro.
Okay, but that's clearly. Actually, yeah, but what?
No, wait, what?
Yeah, okay, so that's still not good enough because. Wait, is it good enough?
Wait, what the hell?
Jesus. Let me check if this is good enough. It might be good enough. Like, I don't know. Not sure. Yeah, you can't really tell from the information. Because, like, those two can be equal. Wait, is that good enough? If it's good enough, then that would be pretty surprising, but I don't think it is. You know what? I'm just gonna try. I'm just gonna try A equals Z, B equals C. A equals B, B equals C. So then, 2AB equals 4. And then A squared plus B squared equals 5. Wait, why is this so nice? What? Okay. Is this a possible scenario? Plus B squared equals 9. So, A plus B equals 3, assuming they're positive. A minus B equals 1. So A equals 1, B equals 2. What? What's that? Wait, what? Doesn't that work? No, it doesn't. No, I'm retarded. No, I'm retarded. That's false. Let me check what happens. What happens? So A, D plus B, C. Yeah, okay. So 1 plus. Wait, I swear this works. Hold on. Liam, try something in A equals D equals 1 and B equals C equals 2.
A equals D equals 1.
It satisfies the original. So then
B. What? Oh. That works. Wait.
yeah, like I mean, it's the equality case.
That works. Oh, nice.
Alright, so you guys solved it.
I don't know. Maybe
But it seems like it's been
it
solved.
seems like
Your thing does prove it's greater than or equal to 10.
okay. Now I just need to check the logic of the A and B part because
The
it's still a
logic
little
should be
It's a
correct.
little bit. Oh no, but A. Okay, A D. If it's negative, it's still less. Okay. It's fine.
Yeah. Because we know.
Yeah. Yeah. Okay. So A squared plus D squared. That's positive. So those two are positive. And then A D. If it's positive, it's just. Yeah, if it's positive, it's fine because it's just A and D. But if it's negative, it's gonna be less anyway, so it's still less. So this inequality is definitely true.
Yeah, the inequality has to be true.
Yeah.
The individual parts are greater than, so when you sum them, it also has to remain bigger.
Yeah, I was just worried because AMGM only applies to like positive stuff, and AD might not be equal to square root of A squared D squared. It might be like the negative, but if it's the negative, it's even less. Yeah, so it's fine.
This will be a sizable pizza. Alan, do you think you can eat one
Hey,
slice
Liam on
of
his
pizza
way to
this
eat
size?
Dude, it'll take him like a year to eat the whole thing. He'll take a
Liam
bite,
on
take
his
all
way
that,
to
like,
eat
those-
50% of this pizza.
Alright, have you guys tried this question?
No. I'm trying it.
Ready for presentation or not?
You can't
That's
Why?
actually.
the
Why
minimum
are
You
these-
balance
only
is
need
like
to use
5.9.
one. It's pretty fun.
Yeah. It was never going to be anything more than AMGM, though.
I mean, yeah. I think with this kind of question, it's definitely it.
No, but like, it's junior. They can't be asking like Muirhead or power mean or any.
But there's nothing
complex
complicated.
inequalities or Jensen's.
I think there were some observations that were missed.
What is some observations?
Can't A plus B plus C plus D be like 5.9 on the MGM? It's like,
5.9.
Ooh.
It's like
What was your minimum
that
value?
it's like 2 times root 78.
Wait, what did you do?
I just used 26 and 3. Right.
But like, we
You add that
proved stronger
26.
bound.
26 and 3 out of 26, right? You get this thing over here.
2 root 78 on 3.
Yeah, but you have to find values.
Wait, what is your A, B, and C, and D?
No, it's like
Wait, what are your A, B, and C, and D?
I'm trying to prove that this thing works. Like right now,
Oh.
the solution.
Because like, yeah, basically
It's
like,
like the
He fell for the trap.
oh no, the logic. You need to be careful about the logic.
He fell for the trap.
I don't know. I have to
The
be more
stronger
careful about
bound.
this.
It can't be 26 because I proved 9 and Alex proved 10.
10.
Yeah, Alex proved that A squared plus B squared
Yes.
plus C squared plus D squared is greater than 10.
Wait, so who claims it's been solved now?
Alex is
I don't know.
Um,
I'm just checking some stuff.
because your AMG.
Oh yeah, okay, it's
correct.
works. 10 plus 26 is 36 into 6.
Yeah.
Alright.
So is it too early to present?
what is
Probably.
absolute value again?
It's just like, if it's negative, you just remove the negative sign.
Okay.
Yeah.
Disappointing.
Oh, what are you guys doing?
On the phone.
What are you doing on the phone?
They're doing sacrificial altar. Some game, something.
Wait,
It's
guys,
just-
we're putting up these easier questions for you guys, you understand? Otherwise, we could just do like other stuff.
Hmm.
Let's set a time to present. How about in 3 minutes? Consolidate your thoughts. Who's presenting? Is it Liam Redemption?
Alex
Yeah.
solved it though. You don't want to claim Alex's solution.
You don't have to. You could just be like, this is Alex's solution.
Yeah, true.
Yes.
Would most juniors know what AMGM is?
Probably.
As long as they, without AMGM or knowing about inequalities, you're absolutely stuffed for this question.
I don't know.
No, it's not true. You just
Like-
missed. There's some observations you missed.
If you think like squares are positive and then you just do it. Then
I have an exercise for us during the presentation, so.
wait, squares are non-negative.
Hey, would this question make sense for complex numbers?
I feel like this question would not have a bound for complex. Like every polynomial has root. So it's like wait, actually I'm not sure.
But yeah.
I'm not sure actually. Wait, it might still
Wait, does absolute value make sense in complex numbers?
Yeah. That's like the whole reason I asked.
So you can just triangle inequality.
The absolute value is just
But then
it's like the distance of the thing from the origin.
I don't know. But like when you use triangle inequality, like if you add them, so that's
Oh yeah.
I don't know. Yeah, because it's asking for the minimum, so I guess it's.
Wait, did we do A4 already?
We haven't. Well, I have a claim.
Kinda.
Yeah, we
A4.
yeah. I claim to head solve A4, but
I claim to head solve, but I don't know.
like
I'm
yeah.
not sure. I might have.
But A4 I feel like is easier than A3. Just
It's
because
easier if you have the knowledge.
Yeah, like it's kind of lazy. You don't have to really do much
Yeah.
if you know what's going on. Like
A3 you actually have to do the
with
math.
A3, it's like unfamiliar. You know, like you have to figure out what's going on. Whereas A4, it's like a textbook kind of game.
You literally like a math extension 1 question.
Yeah, it could be in your like HSC exam. Like it wouldn't be a stretch.
Yeah. And I think people would solve it. Wait, okay, except for the HF. Hmm.
Bro.
Circles. These are roots. Other roots. Whoa. They didn't expect you to make the observation that there are 20 of them, so they have to be ordered.
Do you have water?
Yes. Wait, where was that water from?
It's in the car.
Oh, there's some in the fridge.
Bro. I'm gonna grab one of those.
Two people. Whoa. Oh, damn.
Alright, who wants to present? A3, let's go.
Liam, you can do it.
If you can't do it, Alex can. Liam, he's our man. If he can't do it, David can.
I don't know the solution.
Alex will present.
What?
Bro.
Liam.
Yeah?
What about redemption?
Liam, you must try again.
Giving up on communication.
Nah, bro. You have to practice to get better.
He has to learn. Practice can only come after you have learned.
Yeah. You have to learn how to explain.
What happens if I'm not capable of explaining?
I don't know, just like, what would you do in a write-up?
My write-ups are no better.
What? How are you getting
Alright, who's gonna do this? The
I
time
don't
has
know.
come.
Michael, you've seen my write-ups, right? They're very bad.
They've gotten better.
Are
Really?
they better or
I mean, your
worse?
phone sounds right off, but I don't know. I feel like just like, how would you explain the problem in a write-up? That's like the most basic level of explaining. But obviously, like more advanced would be like not pulling out of ass solutions. Like that's kind of just extra.
Fine, I'll explain.
Are you ready?
Yes, sir.
Recording in progress.
There you go. Liam is gonna explain what the question is for A3 and something of their solution.
Alright. A3.
What was the question?
The question was you have four variables A, B, C and D such that check what the actual variables were equal.
AB plus CD equals AC plus BD equals
Not
4.
having memorized the question. Sign of lack of understanding of the question.
Is equal to what?
AC plus BD.
Ah.
And is equal to 4.
Yeah. Then you have AD equals 5. You need to find the absolute value.
Oh no, minus 5. What?
No, not minus 5. A plus C plus D plus. Yeah, you need to find the absolute value.
We got the absolute value.
The minimum of the absolute value of A plus C plus D.
Okay, and what else?
Improve handwriting.
My handwriting is the best.
Classic unquantified variables. So these A, B, and C need to
What are
be real.
they? What are
A, B, C, and D are real. Yes. We can start by squaring A plus B plus C plus D. So we get
What's your claim?
we claim it's equal to 6, right? Wait. Yeah, 6.
boys? Yeah.
Yeah, because 10 plus 26.
Yeah.
We claim A plus B plus C plus D is equal to 6. So first we
Add
can
them
square
in.
this expression to get
Uh-oh.
um
Maybe write something
I'll
in
put
the
the
line.
2 in.
yeah. Damn it.
It's too big for the laptop.
Alright.
Should be 6 of those, right?
Yeah. 1, 2, 3, 4, 5, 6. So now let's zoom out. Yeah. Much better. So now we need, using the first two expressions, we can find the value of 2AB plus 2AC plus 2AD plus
stop
2BC plus 2BD plus 2CD. We get that it is
You don't want to be annoyed. Don't annoy other people. Awkward pause. Oh. I thought he was gonna wait that long and then write 26, but then it's like
I'll just
he's
write
like, Then
26.
he just writes the working.
Like, no, you either put 2 times 4 plus 2 times 4 plus 2 times 5, or you put 26. Don't put 8.
I feel like it's either you keep like you don't stop and you just write the working and work, okay, or you pause and then just write the answer like you pause.
Yeah,
Oh,
8 doesn't really make sense.
the stream is black, so
Is it?
yeah.
Alright, I'm gonna get the. Give me a sec.
Yay! Everyone missed my terrible job at explaining stuff.
Oh, sorry.
Very pleased.
Oh, no, the screen
What's
is
going
actually
on?
black.
When you did
Oh,
back
yeah.
to the Sony TV. I see.
Alright, so we have this. Now we can apply the AM-GM inequality to get first, we need to find the value of a squared plus b squared plus c squared plus d squared. To do that, we can apply the AM-GM inequality to get. So we have
But Liam, the AMGM inequality, how is this the AMGM inequality? I've only seen AMGM inequalities with square roots in them.
Yes, and square roots.
What do you
Alright.
Be applied to positive numbers.
No, no.
Yeah, you get to the point where you start just saying positive to mean non-negative.
Yeah.
Oh,
Wow.
oh, so this is a little bit. That is not equal AD.
It equals what? What does it equal? Absolute value.
That's good.
What do you do?
Come on. You got this.
That's so weird.
You got this.
One more step.
One step at a time.
what's the name?
PC. You just do like,
No,
this is greater than or equal to AD.
greater than equal to what?
AD.
Oh,
True.
clutch.
Oh. I should not explain things. It makes me look stupid. I should not do these explanations. Everyone online will think I'm stupid. And then we can repeat the same process we did up there to get. And we can combine these two expressions. Stop vibrating the table with your erasing.
Yeah.
Vigorously erase this paper.
Now we know the value of AD plus BC, so we can obtain.
Oh, what? So you only use 2 of them?
Yeah.
You don't use the 5.
So we're only using the 5.
Oh, you're only using the 5.
Yeah.
Interesting. So you have a few choices here, right? Do you?
Now,
But only one of them gives you the good knockdown. So it's like,
Yeah. 8 is too small.
now if we can find values for this expression such that a squared plus b squared plus c squared plus d squared is equal to 10, and the first two conditions, which I shall now underline so you can be aware of what they are, hold true. I'm explaining for the people in the stream, sir.
That's very considerate of you, then.
Everyone else, And them, they probably aren't aware of what they are either.
He's truly one for the people.
I'm just stating a fact.
Liam for president.
Interesting.
Alright, Liam for prime minister. How about that?
What?
Liam for prime minister.
Now-
He's a US citizen. He can
Substitute in the...
What are you switching this?
Oh, can you be
Yeah,
wait, you have to be born in the US or not?
I don't know.
Are you born in the US?
Liam, like,
Oh, he is
takes
born in the
notes
US, it's okay.
Wait, he is fine.
Yeah.
Okay, let's do it. Give me both.
Liam can just bribe everyone to vote for him.
Now we can substitute in the values.
It's funny because he'd run for like Democrat, but then like when he starts talking, everyone's like, "Aren't you in the wrong party?" Anyway, just keep going. Just keep going. Let's keep this atheist.
We can clearly see that 1 squared plus 1 squared plus 2 squared plus 2 squared equals 10. So this condition holds. Now we look at the earlier conditions that I underlined earlier. If you aren't able to tell what I mean by underlined, you're dumb.
You're dumb. Be quiet.
And we can clearly see that that the first condition holds because 2 plus 2 equals 4 for both of these. And for here we have 1 plus 4 equals 5. Therefore, the minimum value for a squared plus d squared plus b squared plus c squared is 10.
Ooh.
So, using what we got earlier for the expression a plus b plus c plus d squared, we know the minimum value is 10 plus 36.
Wait, tell us.
10 plus 26, sorry, which is equal to 36.
36.
Yes. So we know
Well,
that
Oh, the minimum value is. You claim it was 6.
yes. Therefore, because it's the absolute value of a plus b plus c plus d, we only need to look at the positive root of this quadratic. Or no, the positive value such that this holds. Which is,
yeah, I guess if you're writing a proof, you do ignore a lot of stuff.
and now I no longer have to suffer.
Absolutely.
Shit, he no longer has to suffer. Oh crap, you could
Stay there, stay there.
No more suffering.
You'll be in the hot seat, okay?
Liam, you're supposed to bow.
pretty fun.
Okay, so you claim that this can only be solved this way and it's very difficult, do you?
No, it's not that difficult. If you know AMGM, it's pretty trivial.
So this solution is like, it's not a junior solution, okay? Let's be very clear.
He called everything.
This solution is like inter or senior solution. Okay?
Why would that be?
Because you do like an inspired transformation of the problem, okay? So you change it to the squares, yeah? And then you apply AMGM, which most juniors don't really know, okay?
AMGM's like the most trivial inequality.
Yeah, but you
Everyone
have to,
knows AMGM.
But David reminded us this might have been like an AIMO or AINE problem once. Right?
AIME, they'd assume you know AMGM.
Yeah, but
the
still,
AI
but that's probably not how you'd solve it though. I don't know, like, I feel like there was one thing that was missed, like, you know the ones where they're both equal to 4, right?
Yeah.
If you just subtract them, what do you get?
Ooh, that's a good question. You get the
We can
A
do
minus the B. Wait, do you get the A minus? No, you don't get the A minus.
Ooh, interesting.
You get the A minus B, B minus.
And I swear this has come up
B
in
minus.
class as well.
That's a pretty interesting.
Right.
Yeah, I think I thought about that, but then I didn't know how to use it. So I was like,
What do we do now?
Well, what would you normally do?
what's the
Factorize.
Yeah.
Just think of them as complex numbers.
Just think of complex facts.
Really shitty.
A, B, and C, and D are on the units.
You don't have to think about that. That's only going to confuse you, Liam.
Just factors.
Someone actually intelligent should be here in the hot seat, not
You
me.
are intelligent.
Like you.
Really, you're
I
quite
dis-
You are
intelligent.
more intelligent than 99.2% of the population.
But there's a percent of the population that's more intelligent than me. Thus, I'm not intelligent.
What?
Intelligent,
no
by
one
his
is-
definition, is the absolute most intelligent
Yeah, it's
in the
just
population.
most intelligent.
His
person
definition
in the
of
world.
intelligence, Evan Chen.
Tony, intelligence means like knowledgeable, right? Like intelligent. Because it's like the central intelligence agency. It's like intelligence is some
Oh.
sort of like
Like you just have a lot of info.
being
A
being
minus.
updated and aware of stuff.
Yeah.
A
Like you have like a petabytes of computer storage, and you just have like information.
Ooh.
B minus A.
Plus C.
Hear me out.
Or if you do minus C, you do A
Are you
minus
sure you got it right?
C. You do minus C.
Minus
A minus
C
D.
D, bro. You got like.
Wait,
plus-
I
plus-
threw a
plus
bit
C,
there.
and
Don't
then
worry,
you got
but
minus C, something.
so now it's
Oh, very good.
Oh, yes.
so we can get so therefore one of these is 0.
Damn.
So therefore either
So it was sus that B was equal to C before, huh? And A was both A equals D and B equals C.
so either A equals D or B equals C. So let's move to some open space to explore this new route.
Alright, see if you guys can do this problem here. I don't really know what's going on here, but I think this is definitely
This is definitely a way.
yeah, and it's definitely worth points to get that.
Oh yeah.
Nah, I think this will definitely
This will do.
simplify the problem enough so that a junior may be able to do it.
A junior such as
Okay,
you
well,
guys.
junior, what kind of junior? I guess if you just say junior camp, like that's quite a wide range of skill.
Yeah.
Because like you have year 6 people who got AMC public school, and you have the year 10s who just got abandoned.
And then you have dumb people like me.
You're probably smarter.
Really? Believe in yourself.
I want to chuck you off the balcony every time you open your mouth.
Yeah, I think you should stop trolling him. Please.
Well, log A equals D. Wow.
Is it Willog? Is it Silver?
You can log
Can you
one of them.
log? That's just the question.
Oh, true. They're not good.
Can you log?
It could be. I
You
mean,
can.
You can
But you
log,
have to
yeah.
Look at the.
You can log
yeah,
it.
they have to be
yeah.
like yeah. You could if you swap them, it can give you the same relation.
Yeah, exactly.
Well, that's good.
Oh.
Now what can we do?
Ooh. Pretty cool. Very nice.
Very nice.
Wow.
We can continue subtracting stuff because it'll be funny. Let's see what happens.
Just keep subtracting. I mean, I guess it will.
Or
Are you sure it's funny?
Okay, but we're. Okay. Just keep subtracting. Let's see. Let's think about this. What do we do?
We got two equations. AB plus AC equals 4.
yeah, and
A squared plus BC equals 5.
Oh. That's pretty cool.
What the?
So why did he do that?
That's not true.
Yeah, it is.
Well, why did he do
I
that?
don't know though.
Wait, how is that true? Wait, you got 4 terms, turn into 3 terms.
He said divisible something.
No, that wasn't what I was saying.
Like this.
Hmm.
Did we say A equals D? Is that
Yeah.
Yeah, so this does this do stuff?
We know B minus A is a
What does
reciprocal.
this do?
I have an idea. We're trying to minimize. We're trying to minimize A plus B plus C plus D, right? And D is just A, you know?
Yeah.
Then B plus C is just like 4 on A.
Yeah.
Oh,
Yeah.
oh, he's got it. Wait a minute. Damn. Now it becomes a 2-unit question.
One variable.
2-unit question, yeah.
So there's no constraints on that. So the first equation died now, right? It's just A squared plus BC.
Yes. But we don't know what BC.
Huh?
Wait.
But you're still not writing down the expression.
Which expression? Which one?
Like, why did you do B plus C equals 4 on A?
Because that's what you said.
Why did I say that? That's not all I said.
Look up at the top.
No, not the top. Just like the expression you're trying to minimize. Oh.
Interesting.
Is the 2 screaming at anyone else to take out?
Wow.
Still inside. No. What? Brackets and absolute.
Confusion. What he do?
So what's the minimum value of this?
Well, you do still have to consider like one more. Still one more equation, yeah. Because like This is after subbing in the
True.
second. Maybe you could try subbing it in like that. So now you have.
So you understand? It's basically minimize this subject to a squared plus b equals 5.
Yeah.
Write that down. A squared.
Ooh, Hmm.
Yeah, this is
What do you
literally
do
just
with
like
BC?
simplify.
Does BC look the fuzzy?
Hmm?
Click on the whiteboard.
Wow.
That's kind of a funny condition. But if you get your head around it, it's not too bad, right?
Hmm.
I feel like difference of two squares.
Difference of two squares.
Like bring the a into the fraction. Yeah. Two squares. It's like a squared plus 2 the a.
Oh, a common denominator.
Oh.
That.
Ooh.
You can direct this with two squares.
Are you? How do you difference the two?
It's like a squared minus root 2 a squared plus root 2.
What?
So you can
What?
Oh. Complex numbers is funny.
A squared plus root 2i.
This is the sum, it's a sum.
Oh yeah, I forgot.
This is,
Hmm.
I don't know, like one step I might consider doing, just because it feels good, is to remove the absolute values.
Hmm.
Can you remove the absolute values now?
Hmm.
Probably not.
No.
Why not?
Well, can you?
I think so. I mean, if that's the only condition, can't you just make a the positive one?
I am. That's true. Again, that's true. Just make a positive.
Gradually, this expression looks more and more familiar, right? Like your buddy. It's your friend. Liam just deletes the A. That'll simplify by deleting the A.
So I was fixing it up, making it more
Now
neat.
we shall make the fraction line disappear. Eventually,
Someone else sit here.
There's nothing on the screen.
Can we put someone else here?
No, Liam, this is good for you.
No, it's
Me
not.
and you, Liam.
I'm going to pick you up and throw you off the balcony.
Why? I just said words of encouragement.
You see, now if you do it, it seems premeditated. Not a spontaneous act of violence.
I have many reasons to want to throw him off of the balcony.
Wow, there was planning. Analysis.
Yeah.
This is premeditation.
Liam just loves
You know what would be even
violence.
funnier? To put him in the garbage chute,
Oh
because
my
he would
God,
fit.
stop.
He would fit in the garbage.
This is self-incrimination.
This isn't very nice, Liam. And you're saying it to all the viewers on stream.
You have like
6 viewers.
we do not accept criminals here. Don't worry, we're not criminal individuals.
Actually, I guess. What would be my first thought to try to minimize this? Unfortunately, because of my high school maths, it's like, just too
differentiate. Or like graph it and see where the minimum is. Would you guys know how to do that? Find the derivative. So basically, like in high school, they just teach you to find the derivative and set it to 0. And it's either so the derivative is like the slope,
That
right?
point
So if
all
the
the
slope is 0, it means it's horizontal, so it's kind of got to stop and come back down. Stop and go back up, right? Alright, we might as well learn that if we're waiting.
Sure.
So how do you differentiate 2 over... And usually when you differentiate, you leave it as 2 over a plus a. So how would you differentiate a? How would you differentiate 2 over a?
2 would just go to 0 because it's constant, right?
What?
Wait, no. I don't know how to differentiate.
But this stuff you could literally teach to like primary school people. So like the rule is you bring the power down and you subtract the power by 1.
Yeah.
So it's a to the 1, right? You bring the power down, so it's just 1 times a to the 0. Yeah. What's 1 times a to the 0?
1.
Okay. So then 2 over a, you think of that as 2 times a to the minus 1. Yeah? Then you bring the power down, and then you subtract 1 from the power. What do you get?
2
Also,
times.
juniors should have thought to sub a equals 1 at some point as well, by the way.
That's 3.
Oh.
Yeah. That's the answer you want.
Yeah.
You divided by 2 before.
Anyway, write the derivative down.
Wait, what do I write?
Write the derivative. Write the derivative of 2 on a plus a. The derivative is linear additive, so you could just differentiate each term separately and add them up. Yeah. Yeah.
Isn't that...
I just saved you like lots of random high school.
Maths is
Wait,
fun.
the derivative of a to the minus 1?
Maths is fun never told me this.
Yeah.
Math is fun.
The derivative of a to the minus 1 is...
Yeah, I feel like people have different definitions of fun.
minus a to the minus 2, right?
Math is fun definition of fun is memorizing shit.
Minus 2 times a to the minus 2. There's a 2 there. And it's also a scaling, so if it's 2 times something, you just differentiate that and times it by 2.
Oh.
And then a's just goes to 1.
Yeah.
When that equals 0.
Okay, but you have additional constraints on the right side, so it's like...
Yeah, how do we do with the strength?
0 is when a equals root 2. Well, that's just...
What do you do with the constraints on the right side?
The 0 is plus minus root 2. So,
Plus minus root 2.
yeah. That's the equivalent of minus 2 on a squared.
Let me check the
What?
Wait, let me see. 2 over a. 22 minus
That seems pretty weird.
Yeah, I don't think it's the same because you have the constraint. You have to remember that.
Yeah, I know.
So how can we show if how does it fail the constraint? Maybe that'll explain what the constraints are.
Well, if you try a squared,
Oh, okay, yeah. So
You
if
get
you put
two.
the constraint,
then
Yeah,
you need
B-
plus bc, that somehow needs to equal 1.
the BC equals 3. Wait,
But
what?
b
Yeah,
plus
BC.
c equals what?
4 on a.
4 on a. If
So-
a is root 2, 4 on a is like 2 root 2.
Wait, no.
Okay, so then b plus c on 2 is like root 2. Wait, b plus c on 2.
Hmm.
What?
BC equals 3. B plus C is 4 on 2. That's a quadratic, yeah.
What
what
just happened?
If you know the sum and the
product of two things, then it's the quadratic. And the quadratic is like literally the sum is the minus
How do you know
x
BC?
product of the constant term.
Because we know, because we're saying if it is root 2.
Oh. If it's root 2, then 4 and root 2 equals this. What's BC? Wait, where did you get BC from? I'm so confused.
The other thing, because we have a squared plus BC equals 5. Yeah.
Okay. So clearly, somehow there's no solution to this. We're going to use the AMTF.
Wait, that's weird. It feels like they're really.
We're on root 2. Okay, so B plus C on 2 is 2, but BC equals 3.
A minus 12 is negative. Yeah.
B.
There are no solutions.
Okay, now I'm confused.
Yeah. Yeah, but this tells you exactly how to solve the problem.
Yeah.
But then the derivative thing is a little bit unsatisfying.
I feel like the intended solution is just thinking about it, because even getting to that point is probably less
I feel like you can
trivial
still use
than
AMTF.
AMJ.
No, but like I would guess the intended solution had A.
Yeah, A equals B, then it's probably easier with AMGM.
A equals B.
Yeah.
Yeah, so you can tell if the quadratic is a solution or not, because you know it's like b squared minus 4ac,
Hmm.
right? The b squared is 16 over 2, which is 8. 4ac is 4 times 3, which is 12. Yeah? Because the coefficient of the b, right? That's the sum. It's the square of the sum. So the sum was 4 over 2, right? 4ac, a is 1, c is the constant. We said the constant, the product is 3, right? So that's 4 times 3 is 12. So 8 minus 12 is negative. So it's not going to have a solution, right?
Oops.
So then that's really what the constraint is then. It's the
Constraint is just a normal inequality.
it's just
on
the
A.
it's just 4 on a squared is greater than or equal to like 3 minus 5 minus a squared. Oh, it's literally an inequality with only a squared. Yeah, it's 4 on a all squared. Yeah? Greater than or equal to 4 times 3 minus a squared. Yeah? Does that make sense?
Yeah.
So then the problem becomes minimize 2 on a plus a subject to that condition. What was that condition? 16 on a squared is greater than or equal to 20
Can you take your hot stick back?
Fine.
Yay.
And then they have to deal with showing the world how stupid I am. What's
This
the
man has
dividend?
hubris.
I don't have hubris.
I don't even know what that word really means, so don't worry.
That means arrogance.
Oh, okay, then you do have hubris. Sorry.
What's the least applicable word to the situation, though?
I
Yeah,
think
probably.
hubris means pride.
Yeah,
I
right.
don't know
I feel
what
like
hubris means.
I remember it was something like being embarrassed.
I just only
Liam
hear
is a proud
like
boy.
English teachers using it to try to sound smart or something.
Yeah.
Hubris.
I am teaching English right now.
You need to use the word
So
hubris.
minimize this such that 4 on a squared is greater than or equal to 5 minus a squared times 4. Yeah? You know how I got that? Because b plus c equals 4 on a, right? And bc equals 5 minus a squared. So that was the right way to write those relations. And so then, so now you basically have 16 on a squared is greater than or equal to
20 minus 4. What the hell? That's 40. It is
Yeah.
in terms of a squared.
Yeah, so I don't know, in school you're also taught like curve sketching.
Oh my god.
Are you still taught that, Alex? Like how would you sketch like 2 on a plus a?
2 on a plus a.
You taught that?
So like
2 on a is like that. Alright. Like, we assume a is positive, so we can forget about that. And a is like that, right? I don't know. One of the first lessons you just kind of add the points, you know. It's kind of dumb. So like this is gonna add nothing. It's gonna add a little bit more. This is gonna start adding nothing to that. So it's probably gonna be something like this, I guess.
wow.
Wait, that doesn't sound right. Oh yeah, no, because the minimum on this side is it's odd, right?
Let's see.
That sound right?
What? Yeah, legit.
Hmm.
Seems legit. Just need something quality. So it's 16 is greater than.
Oh, let's divide by 4.
Yeah.
I don't know why I times it out. I'm sorry. 4 is greater than or equal to 5a squared. No, I'll leave the a squared outside. Minus a squared. A squared. No.
So E is wait no. We don't have anything there. You need the bruh.
4 is a quadratic. So it's a for minus 5a squared plus 4 is greater than or equal to 0, right? That's a squared minus 1, a squared minus 4 is greater than or equal to 0. And then, so you have like this kind of line, and you have like minus 1, minus 2, oh, 1, minus 2, 0, 1, 2, and it's kind of like doing this kind of thing, right? Yeah. So, because you know it's going up when a is big, it's going up when a is small. And then it has to hit 0, 2, minus 2, 1, and 1. Yeah. Okay, so it's greater than 0, like here. Yeah. Right. So then this inequality is equivalent to, if we assume a is positive, yeah, non-negative, then this inequality is equivalent to a is less than or equal to 1, or a is greater than or equal to 2, right?
And root 2 is between them. So
Yeah, root 2 is out of the range, yeah, see? Yeah, so this is school math. So basically, you know that like the maximums occur at the derivative equals 0, or the endpoints. That's the only possibilities.
Yeah,
okay?
but why is that? Why is there a maximum?
Yes.
Is there a maximum?
Yeah, so why is there a maximum? So it has to do with... Oh, we were talking about that before. Like, if you have a closed interval, it gets sent to a closed interval. Okay.
It's the extreme value theorem, which requires the completeness of the real numbers.
Yeah, so then to find the maximum, it suffices to sub in either a equals 0, a equals 1. To find the minimum, sorry, it's a equals 0, a equals 1, A equals 2 or A equals infinity. Okay, but if you sub in A equals infinity, it gets really big.
Clearly, that is not it.
So it's A between 0 and 1. Where is our expression? That's 2 on A plus A, right? So if you sub in 0, you can't. So you can't sub in 0.
So therefore, it must be at the end point. It has to be 1 or 2.
Well, actually,
Because
so
we
so
already
that
did the derivative.
hold on. What was the 0? Okay, so you have
Yeah,
B
that
plus
was when
C.
it's root 2, so it doesn't work.
B plus C. You want to minimize B plus C, and then BC equals 5. Is that a thing?
What?
No, because I guess implicitly A can't be 0 here, so. Okay, and then A equals 1 gives you 3, which we times by 2 to get 6. That was the other solution, right? And then A equals 2 gives you also 3. Oh, it's another way to get you the minimum.
Yeah.
So you
I
could
didn't
have.
really tell Liam that. I admit it.
Oh, of course, because they could both equal 2 or they both equal to 1.
symmetry.
Yeah.
So it's either A and D are 2 or B and C are 2.
Okay. Maybe we can use another argument to say the minimum. Because if A goes above 2, can we prove that this expression goes above 3 directly without calculus? So if A goes above 2, right? So I guess if A goes above 3, it's just above 3, you know? But like, what if it's just like a little bit above 2?
How do you prove that? You would use the AM here.
Yeah.
But I don't
So it's like so A plus epsilon here, this plus epsilon, is, or like with 2 here, right? It's supposed to be greater than or equal
how
to
do you use and?
3. Yeah.
I don't know. I don't know, bro.
Weighted AMGM. Is it?
Like, it doesn't really.
Doesn't work? Right, let's
Not, well, not immediately. Oh.
and then on the other side it's 2 on 1 minus epsilon plus 1 minus epsilon is greater than or equal to 3. No.
The probably do this.
No. Wait, it's kind of.
Weighted.
Well,
My brain's dead.
0 is greater than or equal to epsilon.
No more algebra. When I was in year 7, we were like 5 or 6 people, and we were just sharing these.
During recess?
Like, we just put all our food in the middle, and we just like.
Oh, really?
Oh,
That reminds me of like the Korean group in our high school. Well, they had like a lot of better food
That
than
was
us.
peak communism.
They always had like sushi and stuff,
Kimchi.
and like these lunchbox containers with like, so many different compartments.
You know what the
And all I got
reputation-
was like some shrapnel to buy canteen food.
You know what the reputation of the Korean group in my year at high school is?
Hmm.
It's basically just that they're dumb.
What? You can't say stuff like that.
And that they spend their entire time playing
Yeah, we didn't
basketball.
really bother with like
I agree, Liam. I agree.
No, I admire the Korean community.
Oh, the Korean community, all they seem to care about, 99% of them, is basketball.
No, when we were in school, so we were playing basketball at lunch, but like for some reason we started this trend of playing volleyball at lunch because we were like in a volleyball team.
I don't know about Korean people are like obsessed with basketball, but they certainly are obsessed with school now.
Oh, are they?
I don't know.
Hmm.
But then again, everyone's kind of obsessed with school now.
So, like, do you play with the Koreans?
Not really.
Wait, does this work?
There's a few who are like smart who are sort of-
I don't even know how I got this, but it looks like I got this. Alright, so for this,
Whoa.
so you take the 2 to the other side, right? It becomes a 1, yeah. And then you plus epsilon minus epsilon, yeah. And then that becomes a 1. Yeah.
Yep.
And then
It's like
it becomes this, right?
Wait, what? Wait, hold on, let me check this. 2 plus epsilon, okay, that's 1. Plus 2, that's 3. Wait, well, that just cancels. What? Hold on.
Something sus happen.
That's
Someone gets angry at family.
just a little bit confused, I guess.
Wait, David, do you get what I did?
Wait, where did the plus epsilon come from?
Oh, I'm trying to say that like if I add something to, if it's a equals 2 plus something, so if a is bigger than 2, then the value should be bigger than 3,
Oh, okay.
or at least 3.
Yeah, I get it.
Okay, so that gets to this box, right? And then from this box, you can get rid of the epsilons because you assume epsilon's positive now.
Yeah.
So then you have this expression, right?
Is this true?
It's weird because it looks like it's
It's true, isn't it? Yeah.
yeah. So I think this is like the emphasis of this is like, so for inequalities, I think there's like too much sort of theorem bashing. I don't know.
Oh,
Like,
yeah.
because a lot of the time, like you get out of trouble by going to the basic details, you know, just rearranging stuff. Yeah. You know, like, you know, there's just perfect examples like Yasuru in the IMO, right? Just like it was an inequality question 2 of all things, right? And if you're not good with inequalities and it comes up as question 2 or 5 in the IMO, you're gonna feel pretty bad, right?
Yeah.
But then he just kind of reverted to just expanding it, subtracting it, and showing it's like,
Solve it.
yeah.
Work?
He
Yeah, I
just
think
like
it was.
used the basic thing.
I feel like Australia probably does not prepare people for inequalities well.
Yeah, like the senior problems, there are no inequality.
You don't get inequalities.
Okay, so actually, if
3 out of 4 of the senior problems were polynomial, and then one of them is function. Like, bro, what's
Like,
very balanced.
Until the last 2 years, there's like never been an inequality in the Australian Olympiad.
wait, can you guess? Can you apply similar things to solve this? Test your understanding.
Okay, let me do it. Here you get the 2 minus. Nah, I can't do it in my head.
Oh.
Too hard. That becomes 3. Get minus 2. Yeah, I'm just gonna times both sides. Oh crap, I don't like that. That's yeah, don't do that. Okay, so I get minus.
Like, also, it looked like I did some fancy stuff up there, but literally you could do whatever you wanted. You're going to end up with the
So
same.
you're given that it's greater than 2.
Liam, are you doing this?
1 minus x. Oh, you get some weird square stuff which I don't.
We're trying to find the value of epsilon, right?
No, epsilon is positive.
Wait, is
Um,
epsilon smaller than 1?
I don't like this. Again, weird crap.
Actually, you can even just do like a is between 0 and 1 directly, I guess, as well.
Wait.
Like, you just get a is between 0 and 1.
Is it 2 on 1 minus epsilon?
Yeah.
And it's 1 minus epsilon.
Do you need new glasses?
I don't know. As a control, we should also probably do just 2 on a plus a is greater than or equal to 3 if a is less than or 1, 0. You can do that as a control as well. Because in the end, you have to assume epsilon's between 1 and 0. So it's kind of unnecessary. But like, if you do that, you can kind of mimic the other solution, right? Like you have 2 is less than or equal to 2 on 1 minus epsilon. And then you can minus 2 epsilon plus 2 epsilon. And you get 0 is less than or equal to 2 epsilon on 1 minus epsilon. 0. So 2 on 1 minus epsilon minus 1. And then this is equal to 2 minus 1 plus epsilon.
What? How
Oh.
did you do that?
It's like voodoo. It's like even I feel like I can prove stuff that aren't even true.
What did he do?
Which one?
Oh,
Like literally the same as the first.
my god.
Yeah, whereas here it's not as obvious. Like if it's this one, maybe it's like you don't know to get rid of the 3. But you can still just like do like 2 plus a squared is greater than or equal to 3a, right? And you get a squared minus 3a plus 2 is greater than or equal to 0, and that happens for, so it's a minus 2, a minus 1, right? So it happens when a is greater than or equal to 2 or a is less than 1. Actually, this is probably better. Because then you get the answer straight away. It's always greater than or equal to 3. Yeah. Alright, that was probably too long. So we don't actually need derivatives, just help sometimes.
Yeah, it's amazing how much stuff people just get taught at school and accept.
Yeah.
Like the teacher's like, oh yeah, the minimum it has to be at the derivative equals 0 or the end points. And then they're like, yeah,
there's no
that makes
option
sense.
to not accept
And I'm
it,
like,
though.
wait, why does it?
You can't
And then
exactly not accept it though, because like you need to answer the questions in that head.
yeah.
So you're kind of forced to accept it. So even
There was a short proof of like, if it's a maximum, the derivative is like 0 or something. There's a pretty short proof of like,
No, like it's pretty obvious because you just do the contrapositive. Like you just say like if the derivative is not 0, then like you do epsilon delta stuff.
it goes up a little bit.
Yeah.
Alright, any questions about that? No, sir.
Recording stopped.
Should I present A4? Have you tried A4?
Have you tried A4?
Alright.
A4 is very fun.
Have you tried A4? Okay, it's a little bit unfortunate you haven't tried A4. You want more time to try A4 or?
Maybe you should try A4. It's pretty fun. Very humorous question.
Do you make any observations about A4?
Maybe I should write it down just to make sure.
How about I'll present A4 in 10 minutes, okay? I'll give you at least 10 minutes to familiar yourself with A4. Some of it, it's like, yeah, it's equivalent to a theory lesson.
Literally just theory. Okay, A4, let me do the thing. That thing is... Yeah, that's the one thing I need to check. I didn't check that. I didn't check it. Okay, so there should be like... That's negative.
Oh yeah, wait. Are ATT invites out? Yeah.
Oh, who got invited?
I don't know, they'll go through your schools.
Oh, is that what
I
they
got
told you?
invited.
Yeah.
Yeah, I think our school got invited.
Did you get your invite?
Already.
Yeah.
In the holidays.
Yeah, Ramsey bust.
We have not got our invites.
What?
Eric Lin does not strike me as the type of guy to be doing stuff in the holidays.
Oh.
Well, he has his baby to take care of.
He has a baby? Oh, what?
Wasn't he on like paternity leave?
What is...
I don't know, paternity leave's like foreign to me.
Wait, didn't Mr.
I've
Lin make
never heard
senior
of-
camp?
It's like,
But yeah, I think
What's
Lucas
a
once said
paternity
Mr.
leave,
Lin
bro?
made senior camp when he was in high
Do
school.
you have Mr. Lin as your teacher?
No, Mr. Berry.
Very maths.
Senior
very
camp back then.
That would be yeah.
There you go. So this quest is such a scam. What the... Actually, such a scam. Wolfram Alpha, why?
I don't know.
What do you Wolfram Alpha in?
I'm gonna expand it.
No.
Because I don't know what
But
else
what
to
are you
do.
expanding?
X minus R10. X minus R9.
oh yeah,
Maybe you
that
should
could
do it
help.
by hand.
It's 20 thing. It's.
Yeah.
I
Well-
could do it by hand.
Oh, yeah, it's a lot of things, but they only want you to do it.
It's not really worth it to expand.
Dude, do it by hand.
Do it if you want to torture yourself.
Torture you. I can turn it into 10 things. Because you can.
Ooh,
If I like the squares, you can turn it into 10 things.
that is worth points.
I know expanding it should probably like the game.
Bro, why are the juniors getting 2 inequality problems, and then the seniors are getting 0 inequality problems?
put my paper on landscape mode.
Oh,
Oh, we went complex smashing.
A3 paper.
Yeah.
I'm very good at chess. I play the 2 times. Oh, it's a variation.
He's making a joke about 9/11.
It's
Now, Liam, there's no way you don't know this. Like,
it's a variation.
you do Otis, right?
I probably don't know it.
And we did the polynomials.
Liam, it's not a
Wait,
joke.
We did
It's an actual
that
opening.
chapter. Did we not like you do Otis. You have to know this.
Dude, my current progress in Otis is ignore units that aren't combi and just do combi. What?
What?
Why? Because combi is interesting.
I swear you did some algebra.
Yeah, but I chose them, and I realized I'm bad at algebra, and
It's
chose
very
to not do
emotional.
them.
Why didn't we
Prejudice
do
to
them? You're bad at it. That's what Otis is supposed to fix.
Wait, so do you hate geometry the most?
Yeah.
Oh, I like it. Pen. Paper. Good stuff.
Oh.
Contemplating the question. 4 more minutes.
Are you sure you can complete that question? Oh,
April Bloom.
Why is he going?
Science 5 handwriting.
Registration. I should show the people on stream this massive pizza.
Oh yes, the massive pizza. Is little Ryan coming?
Massive pizza box.
Compare it to your head.
That's so ridiculous.
It's like I feel like Johnny should pay me
seems like an ad for a pizza.
for advertising.
Blur out the name,
Why?
so then you're not advertising it for free. You should get sponsored by them.
I don't know if that's how business works.
Or just go to them and say, I advertise you, and give me money.
The amount of money in question is
Ridiculous. It's sensitive.
I think you normally just not blur it, have people succeed in advertising, and then they realize it's coming from you, and then you can charge for advertising. But like if you just blur it and they're like, "Oh, how many viewers do you have?" And you're like, 4. They're like, "Okay."
I'm gonna pay you 50 cents per view. $3.
and the viewers are just old.
Yeah, my ability to focus on something I'm bad at is very bad. I kind of just look at it. If I start not doing problems in like 5 minutes, like I completed the graph theory
I
unit.
swear Liam should know this.
Yeah.
Like, we did it.
Probably forgot it.
What? Oh, wait, he wasn't paying attention. He
Yeah,
was on that count.
yeah.
Bruh.
Now I suffer.
Oh my.
Oh, if Ryan's listening, we're starting to heat the pizza up, so you better start leaving, getting here.
How many slices do you
They're not normal slices.
Yeah.
You have to adjust for the
You're
scaling.
Gonna, like, you're gonna take one bite and say, I've had my fill today.
Yeah.
So
Look at the
there's 16 slices instead of the usual 8.
Oh,
16.
But each of the 16 slices is too big to fit on a plate.
What? So you have to divide.
Well, more like it's too long to fit on a plate.
Just cut it in half.
Just bend it.
Oh, just bend it.
Just go.
Just make it a sandwich. It's like boom.
And add sauce in the
Alright, can I try and show you A4?
Wait, sir, I think I'm supposed to solving it.
Oh.
What the
This, put everything together.
least edible pizza?
Everyone's like, how are you eating that?
Your pizzas were made like bugs.
It's literally like, it's not like it's not like you're just
Yeah.
like every single resource.
Oh.
Just everything. Looks like when you go to this pantry, just put it on space. Like 5 different types of pans.
This is like, what happens if you eat all foods at once?
Alright, how about I'll start typing it while I'm waiting for Liam.
Breakfast the one time.
No, I'm rushing for that. This is painful, but I think it seems like that it will lead to a solution.
For a long, it's gonna be like a month.
A month to eat a slice.
This problem is very artificial. It is kind of a scam. This could literally be like in our trial or something.
Yeah.
Oh. This will give you.
Bend it. Well,
How you attempt to be not annoying.
Good.
Yeah, I don't think it's gonna work very well. I like 2 words you've been saying, you're gonna be instantly annoying to me.
I feel like you need to concentrate more on the maths, you people. You people.
哎，圆圆，
啊？
你是非得要装到这个大盒子里面是吧？是吧？热好以后要装到大盒子。
好吧。
那我就不能先给孩子吃了是吧？
对。
你得所有的都热好。
嗯。
哎，好吧。那你要等一下，爸爸说要先放进盒子，你再拿出去。那个叫仪式感，懂吗？那个不是东西。要放进 box 看嘛。
Is it greater than or equal to 100 or greater than 100? But what happens if all your roots are equal to 1?
Are you guys ready? Are you ready for this? Let's see.
Because you can get A2 is equal to 1 on... Oh, they're distinct.
He realized.
Oh, yeah.
Polynomials. Algebra 4.
I have died.
Oh. You must be rejuvenated with pizza. Pizza only.
Oh,
107.
I'm pretty sure it's I do not want to expand 100 times.
You don't want to expand 100 terms.
Because I found an expression for A18 and A2. You can get that they're equal to A18 times A18 is that and A2 is that. How do we know it's bigger than 100? And they multiply to 1.
I don't know. You told me.
I've taken a vow
Right.
to not know you. I cannot say it.
Good boy.
Alright, you guys ready?
Have you tried?
Alright.
Have I tried what?
Using the facts. Using the facts.
Alright, here we go.
Recording in progress.
So a polynomial of it's a monic polynomial of degree 20, yeah, has roots plus or minus R1, R2, all the way up to R10, which are distinct and positive real numbers. Alright, yeah?
Yeah.
Show that basically the coefficient of x to the, oh, that's right. Show the coefficient of x to the 18 and coefficient of x squared is times together is greater than 100. Yeah? Okay. I claim to have head solved this in 5 minutes, but forgive me if I pull a Liam.
Yo, pulling a Liam. Oh no.
But it's not that like I was really smart or anything, it's just like I think this is like a textbook problem, okay?
It's a little bit too school math.
Okay, so Liam did the following step. Go write solution here. Okay, so Liam did the following step, right? He did P of X. Yeah, so this is like a completely school math question you can treat. Okay, so P of X equals, so X minus R1, right? Liam did this, yeah?
Yeah.
X minus X plus R1, right?
Yeah.
Okay, since this part's obvious, I'll give you some notation to think about. It's the product of I equals 1 to 10. You've seen this notation before?
Yeah.
Minus R. Got into the subscript somehow. Does that make sense? So if they tell you the roots, then you can write it as a factorization. Like this, yeah?
Yeah. It is money.
Okay. And okay, I'll do some good practices. Like I'm trying to teach you good practices. Try to line up try not to write them all in the same line. And then line up the equal signs. So this is literally what begin a line does.
Bro, I just write them all on a line.
Yeah. I do too, but I'm trying to give people good habits. And then obviously it's I squared, right?
People who learn native too early can't do geometry.
It's too many like wide sweeping statements like this. I made some.
Ross Atkins said it was true, so it must be true.
Oh, I forgot to do end aligned. Okay. I used to think no errors could do that, but some errors are very grave.
Some errors are unrecoverable.
Oh, what the?
What the hell?
Okay, you know what I'm trying to do here, right? I guess me struggling with this is giving you extra time to compute that this is x squared.
Yeah. Okay, and the point is, now it's obvious that it's even. It's even, right? And
Whoa.
press key, press key. And what even means? Thanks, Michelle. That's enough. And what even means for a polynomial is that all the odd terms are gone, right? Stop. So one way we can write this, which may be pretty annoying to the reader, is it's equal to q of x squared. For some polynomial q.
Whoa.
It's kind of annoying.
Oh. Okay, yeah, I think I know how to solve it. Using.
Yeah, maybe I won't even use this notation. How about I'll just keep it simple? Okay, so we see that it is a polynomial in x squared, right? In particular, A19 equals 0, for example, right? And A1 equals 0, for example. Yeah? Okay, we're not really going to use those two facts, but the point I'm trying to make is all the odd coefficients are 0, right? Yes? Because the polynomial x squared, it's going to not have any x cubes or x's, okay? Welcome, Ryan. Yes. See, with the live audience, we invite them in to have pizza. Oh. Okay. Yeah, so is a polynomial q in root in q? Okay, so the roots of q are ri squared, right? Or I is between 10 and 1, yeah? Does that make sense? So q is this polynomial where it's essentially degree 10, and when you sub x squared into the q, you get this polynomial here. Yeah. So basically, the point I'm trying to make is the A18 you're looking for is the sum of the squares, okay, and the A2 is the sum of the squares, like 9 at a time. Yeah.
Yeah.
Does that make sense? Do you know like the Vieta's formulas?
No.
Okay, so with the Vieta's formulas like this, like if you have a polynomial like this, right? Like this, the first number here is the sum of the roots.
Yeah.
Yeah. Or the negative of the sum of the roots.
Yeah.
Because each root is x minus a root.
Yeah.
The next number is the positive sum of the roots 2 at a time.
Yeah.
Yeah. So far it should be the same for the quadratic. Remember the quadratic got b plus c and bc. Yeah, it's the same.
Yeah.
And then the next one is the negative sum of the roots 3 at a time. And then it's the positive sum of the roots 4 at a time. And then it's negative 5 at a time, positive 6
Is
at
that
a
what
time.
Vieta is?
Yeah.
Oh. Wait, isn't
I
that just
swear you
intuitive?
like Vietas, bro. You like looking at the symmetric polynomials versus
Yeah, but I wasn't. But like, I basically just used Vietas anyway without knowing what Vietas was to
Yeah, that's
do
fine.
this.
Yeah, so one way is that we said that that is p of x equals q
怎么
of
放那个披萨？
x
我要
squared
帮忙吗？
啊？
你要帮忙吗？
我要先做完这个。
因为热了你还在，
Bro, holy.
一会儿就放凉了。
Look at how big the pizza slice is.
In particular, it's like that, okay?
Yep.
And yeah. So by Vietta's formulas, we get that
不要让孩子来啊，就没有东西看。
so A18 equals the minus
Oh,
the
A squared plus B squared.
the sum of the roots squared, right?
Yeah.
Wow.
But I literally came up with that without using Vietta's.
Because Vietta's just obvious.
Yeah, I used Vietta's without knowing what Vietta's was.
And
Turns out I can solve a polynomial question. That's a miracle.
Is this a polynomial question?
Not really.
okay, so this is the thing where like if you do the roots like 19 at a time, okay, that's kind of, or 18 at a time, it might become it might be a bit harder to do. But if you do the squares, you're doing the squares 9 at a time, right? Yeah.
Yeah.
But then you know that the product
Is one.
is 1. Yeah, I should have wrote that.
Oh, sir, I got that stuff here, right here, sir.
Yeah.
See, I solved the problem, sir. I'm very proud of myself. I solved the polynomial question.
Okay.
Turns out I'm not
So because
what I was.
我要用这个桌子让他们听到。
alright, clear that table.
This is peak pencil.
And since the product is 1, you know that
It's one on the
it's 1 on the roots, right? So it's negative, and it should have the same sign as the other one because it's I'll write it like this.
Oh my. It's bigger than
你放好了，我要拍个照。
Oh, big piece of.
It's gonna take a long
Damn, they some large slices. Look at this! I could probably.
Alright, I need to take a photo of the
4 or
pizza.
5 slices though.
I mean, unless it's super thick.
How many slices do you think you
Oh,
could
walk
make?
on.
One.
It's the size of the one's arm, like this.
Yeah.
Alright, I might have to pause this recording for a second.
I can eat
Probably not 2 slices.
I
2 slices too much.
Maybe two, maybe two.
I could eat like
Big maybe.
I ate breakfast, so I can't do it.
And I had dinner on at 7.
yeah. Oh yeah, how did it go with your
And I had
children last time?
Alright.
What?
Hold on, and then to show the product of like this is greater than 100 is basically just Cauchy Schwarz,
Is it Cauchy? Wait, what?
and
He used Cauchy Schwarz.
and
That's
also
crazy.
you gotta also exclude the equality case or something. Okay.
Yeah.
Wait,
Alright.
you used
But-
Cauchy Schwarz. That's
Oh.
crazy. I just used AMG.
Okay, so I might have to temporarily pause this while we attend to the pizza. Okay.
Plus B on A is greater than or equal to 2.
Wait, no, I just used AMG. Not that bad.
But literally, Cauchy Schwarz is the product is greater than 100.
Yeah.
How was that like?
I don't know, but like AMG was easier for me because like then I know what the equality case is and I
This
can
is
just
a lot
not
easier
have
than I
equality.
thought it would be. I might be overestimating the difficulty of polynomial questions.
All right, let me just pause for a second.
Hey Liam, you know how you're supposed
Recording
to
stopped.
What?
It's so large.
Yeah,
That's
what's
the
that?
problem. Yeah, continue the rest.
现在还是热的，待会儿可能就等那个的话就会有点凉。
I just cannot.
Yeah.
这个是什么？
was too busy playing the free Roblox.
This kid was playing Roblox with Michael.
I don't know if it's good to just raise a baby with a iPad.
Yeah, I don't know.
Like, it's definitely not good.
Instead of an iPad, sir, you should put an IMO paper.
Maximum engagement. I don't
Exactly.
know, but when I was little, like, I guess my grandma just like showed me books.
Yeah. I did not use technology until like a lot older.
Wait, what happened?
Alright, let me finish this while we're waiting for the pizza, okay? Alright, resume.
I swear.
Do you guys know what Koshi Schwartz is?
You don't need Kosher Schwartz.
Recording in progress.
See, this guy don't need. This is the problem.
Oh, when Koshi Schwartz is like.
You will need to learn it in school.
When the quality case is like when.
The Koshi Schwartz is like this, okay? You know vectors, right? It's like you have two vectors.
Yeah.
So like a vector u and a vector v, right? Like, if you take the dot product, have you heard of the dot product?
Yeah.
Yeah, this is in the junior book, okay? So if you have the dot product of u and v, yeah?
Yeah.
It's equal to the lengths times cos theta, right?
Yeah.
Yeah? Okay. So that means, this side is bigger than that side, right? So the maximum cosine theta is, so the maximum is 1, right? Yeah. So that means u times v. I'm overdoing the absolute value signs. Let's just do
This is a math way. You just
let's do u v is greater than or equal to u dot v.
Yeah.
You see, and it's equal when they're 90 degrees to each other. Yeah. When they're equal when they're equal. They're equal when they're in line.
Equal when.
When theta is 0.
Yeah. They are multiples.
Yeah. Yeah, exactly. So equality if and only if u equals a multiple of v. Yeah.
Yeah.
Okay.
Yeah, I saw a pretty crazy proof of it on Wikipedia with like quadratics.
Yeah.
It was like
So the way you get the dot product, right, is like if you take two vectors and it's like ui and vi.
Yeah.
So it's like u1 up to u10, v1 up to v10.
Yeah.
Then the dot product is defined by u1 v1 plus u2 v2, u10 v10, and the theorem is that this is equal to this geometrically. Yeah. So what does it mean in 10 dimensions? Well, it's the same as in 3 dimensions, because anytime you have two vectors, it's really only in 2 dimensions, right?
Yeah.
Okay. And so what you do is you let u equal r1, r2, r10, right?
Yeah.
And then you let v equal 1 on r1, 1 on r10,
Yeah.
right? So then the dot product is just 1 plus 1 plus 1 plus 1, right?
Yeah.
Which is 10, yeah? Okay. And the length, okay, the length is the sum of the squares. Okay. So, well, the square of the length is the sum of the squares. It's like Pythagoras, yeah? So then this thing squared equals sum of ri squared. And this thing squared equals sum of r in reciprocal squared.
Yeah.
So you literally get this times this is greater than 100. Okay. How do you exclude that they're multiples of each other?
If they are multiple or not multiples, well, I guess I don't know, bro. You just do it.
Just do it. So if R1
If you just consider the ratio.
equals lambda on R1. Oh, okay, yeah. So then, as long as it's more than 2, it's distinct or something.
It's like R1 squared is lambda.
Yeah.
So if the squares are distinct, then
It's
it's
only the most 2 of them, yeah. You get that? You can ask questions. I'll be writing this up. So we now use the Cauchy-Schwarz inequality. So it's u squared v squared greater than or equal to u c dot v squared with equality if and only if u equals lambda v.
The whole thing? Yeah. By myself? We have Alex, me, you, Ryan, and
这边有点凉了，快吃吧。
We take
I mean, I'll be starting myself, so I should.
u equals
this is looking questionable.
r1 squared r2 squared. Wait, let me take a photo. Hold on. 10 squared.
凉的好快。
I have to pause this again.
There's more meat than there was.
Oh yeah,
Recording
Alon,
stopped.
there's more meat on the pizza than on you.
Oh, okay. I already know that.
The malnourished for a while.
Malnourished children.
Alright, how do we do this? Take a photo. Take a photo. No.
Before and
Or
after.
a video.
And then upload it to your YouTube show. And get like 5
2
views.
times left.
Alright, you guys get some plates.
Yes.
Plates. Get a plate and I'll video you guys grabbing the pizza onto your plate.
Oh.
Wait, that
I
one.
thought you said other people.
Questionable.
This is
And I think
Where
that's
are the plates?
Michelle, 你也来，拿好你的盘子，拿你要的吃了，然后他肯定会掉，你要帮
Hold the picture.
Congratulations.
Some plates. We got
You give one.
We have how many?
Yeah, if you wanna make a pizza that big, the pizza better be good.
It's fish or what?
I don't know if pizza scales as well.
Yes.
Because the dough kind of like, it loses integrity, I think.
凉了，
It just like gets
它本
floppy.
来就
Alright,
凉
let's go,
了。
guys.
I'm just here for the
If
photo.
it's cold, you can heat it up more, okay?
I'm just here for the photo.
Alright,
Man's a poser.
Wow.
Yeah, it's just a
alright,
poser.
grab a slice. There's half meat lovers, quarter supreme, and a quarter pepperoni.
I want pepperoni. Where is
Oh no, good luck.
It's a slight issue. I don't know what to
Very young one.
How do I eat this?
You know, it's a
Which one do you want?
With your mouth. You want scissors?
Alright, grab a slice. Yeah.
That's pretty good. Okay, acceptable quality
can eat too.
for such a big pizza.
Who's not gonna eat?
Yeah, you have
I don't finish this.
She's gonna take a bite like last time and say I had my fill.
I've had my dinner.
Wait,
What?
actually, you have a lot in common with him.
Me.
No, long.
Him? Yeah.
Yeah, both the
They
size
both
of
play table tennis.
both the size of a
Both don't eat that much.
This pizza
So they're not okay.
They both have the same maturity level.
They're both the same weight. Nearly the same height.
Same weight and height class.
Wait, how much do you weigh?
Like 35 feet.
What?
35.
He weighs 35.
I always 30.
30. Oh.
Or 28 or.
Nick, you're
Holy
the same
moly.
weight class. And I'm your yes now.
I don't play.
Yeah, but he's not nourished by choice.
Wait, is it hot enough? Probably not for me.
Yeah, that's fine enough for me. It's a good
Yeah, so the thing is that they're not open for lunch. So I got it last night. And this pizza holds together better than like Domino's.
Imagine having this pizza thrown on town.
It got me in the eye.
I didn't need so much.
Can I get another slice, sir? Sir, may I get another slice?
Have you already finished?
Yeah.
How's he finished it?
Just use the monster.
This guy was stuffing his face. Like, boom.
我吃完这个要半个小时，他2分钟就
Alon
haven't
doesn't.
even ate half the pizza yet.
Wait, Alon, did you give up?
He just didn't eat. He got a slice and said it's for me.
What? Alon, you gotta eat something.
He's already had his
You gotta
fill.
eat half of it. You already had a what?
He's already had his fill.
Yes, I've already finished.
He smelled it and he got full.
Yeah, exactly.
What the hell?
I think that's
Alon
something.
just.
没有啊，
He's like strategically timing his growth spurt.
For what?
Huh? I don't know.
More like randomly.
Randomly. Consistently not eating is not very random.
Yeah, he's timing it for never.
person is
Alright, show me.
weight loss diet.
I'm gonna finish off this thing while you guys eat.
你就这也行。
That A4 is actually kind of.
Not the defensive expert.
It's easier than A3, isn't it? Yeah.
Not the
Like,
defensive expert.
It's very. It's annoying and it looks hard. It's intimidating. It's got a bigger intimidation factor.
I guess I didn't find it as intimidating because school math.
But once you get over the intimidation factor, you realize it's not that hard.
Or the beginning of bear.
Also, can you actually get into CAD with an AMC perfect score? Why is everyone so slow?
Yeah, maybe I'm not gonna finish my slice by the time everyone else will.
Everyone is not. Like, are you gonna eat that or not?
No, we shouldn't have a big mouth.
If you're not gonna eat it, should I just eat it for you?
That was his plan all along.
Wait, you can eat it and like pretend it wasn't paper.
I'm really full from smelling the pizza. I'm hungry. Let me just. I'm full now. I've had it. No. I'll have pasta. I'll have pasta.
You're gonna eat a second slice?
Yeah. You told me you're gonna go on to the second soon.
Onto my what?
The second one, I'm not gonna have a supreme. I don't like it.
This is my third. This is Alan's slice. Alan is eating it.
As you can clearly see.
Oh wait, I shouldn't square them. Sorry, this is bad.
I guess no one likes the supreme.
I don't know if this was enough pizza.
I don't know.
Dwindling in amount.
Well, this would be the first time we've ever finished it.
There's like 3 slices left.
Liam, do you think you can finish that? Like,
Oh no, I'll finish another slice or two.
or two?
That's level 5.
Okay.
Liam hard carry. Well, I'm just finishing my slice now. I'm getting there.
How long till you finish this one?
Yeah. I could be both. Let's go.
It's not terrible pizza.
Huh?
Pretty decent pizza.
Yeah. Surprisingly good.
Yeah.
Well, like the
Did you
size.
expect it to be bad?
No.
These kind of novelty things, you expect it to be like not that great.
Well, how much do you think that pizza cost?
50.
No, we're 100.
Yeah, close to 80.
It's just too big.
Wait, 80, that's kind of cheap.
I would have got extra cheese, but they couldn't figure out how to do the register, extra cheese on the register, so I was like, screw that.
That's actually decent. That's actually good value for the amount.
Yeah.
Like compared to Domino's or anything else.
But I had to order it at 10 p.m. yesterday and carry it back. Extra cost.
Oh.
Mm.
At least it's not cardboard.
Why just be cook pizza at home? Honestly.
Would you rather this at Tournament of Towns, or would you rather, actually we can't, it's lunchtime.
Liam, you're gonna get your first slice now.
I need to be respectful if I was going to eat more pizza.
Just ask them. It's
Right.
my pizza.
Alex, are you going to have another slice?
Probably.
I'm not very long. I feel like a 5 How? I love like being able to play it today.
What?
Hacks.
Half
I'm
an
not
hour
hacking. I just got a
Slav, do you think
Recording in progress.
Okay, so to finish off this resolution, yeah?
Probably need a knife.
So we set U equals the 10 tuple with R's, V equals the 10 tuple with the reciprocals,
But get a knife.
and U dot V is just 10, okay? U dot U is R squared, the sum of the squares, and U dot V is the sum of the... Yeah. And so, yeah, and they can't be multiples of each other because you get UI equals lambda VI, which is RI equals lambda on RI, which is RI squared equals lambda, yeah? And that only has 2 solutions, but we have like we have at least 10 different things, so...
How do we cut it? Like, in half. For you.
Alright, that's it.
Recording stopped.
Yeah, so Alex, are you interested in like presenting G5, or do you want us to move on from G5?
Alright, I'll take this one.
Because we can kind of...
This is like a slice of a
Like, do you want to?
No, it's a bit bigger than
Yeah.
that.
Because you don't want to, we just skip it. But
I think we're going to defeat the Johnny's Pizza.
right,
What?
never happened before.
is Johnny？给爸爸，
你要
给爸爸。
他说这里
No one asked how is Johnny.
他手。What is Johnny?
That is what we are.
How big is the machinery in the room?
Do you think Johnny invented an inversion point? This Johnny?
Oh my god.
How is Johnny? How's it going?
如果凉了，可以去热一下。
Oh, you're cooking with Yubi.
我给，我给。
Yeah.
12:10，我给。
Alright.
I'll help you.
Who's gonna have that last slice?
Oh wait, did you
Mm.
follow the show or something? No, she doesn't. Oh.
要不给他们吃吧？
Mm.
还有 last
Michael, say my name.
Liam wants it. How many slices have you had?
No, I've had a lot of slices, so
How many slices have you had?
3.5.
3.5. Oh, Alan.
Because Alan just didn't want to eat his slice.
Wait, so you almost had a quarter of it.
Yeah.
Wow, Liam.
I like Liam's eating ethic.
Oh, what do you mean so fast? I still haven't finished my first.
What? I'm gonna finish my second. 怪不得他长得那么高呢，
It's my pole.
又高又壮。而且你要向他学习，吃很多很好，这样长得很高。
You have to learn from Liam. You can grow big and strong.
Yeah.
Alan's just making eating faces.
You have to learn from Liam so you can build big and strong.
你自己这么小，就别去说别人好吗？
Wow, trolling from a young age. He was born at a young age. Classic.
Boy, they're very young.
Child murder. Please stop.
But who is gonna have this slice?
Does anyone want the slice?
I don't like being olive beans.
How about Alarm have the slice?
Alana, are you gonna eat it?
No, he hasn't made it.
Oh, or maybe I'll split it with you. I don't know. Depends. Thank you.
Alan kind of he doesn't want to eat it.
I know who can eat that. Michael.
No, take a slice. I was gonna take a bite and say, I've had much food.
I could probably take one bite.
You must.
Yeah, cool.
How?
Are you eating your medicine again?
Yeah.
Why do you need the medicine?
小麦头，你不要拿那
Alan,
个
do you
喝的
want，a bit?
让他们喝，他们6个人，你喝别的，然后帮他们 open 可以，要从上面 open 的。
Who is the killer?
Oh, I think it's you.
Why are you feeling a
Alex, you want more pizza?
Nah,
Oh, I can
Tasty.
Yes.
Yes, sure.
That
Who
would be my
is the
lunch.
killer of the pizza?
It's the Johnny because he's the one that cut it.
Oh, thank you.
I know who it is.
Oh yes, my lunch is
Who throws the lunch is the orange juice.
Alan,
Let's see which
Hydration is
the
important, guys.
Eating is also
knife is
important.
going to
But you know you can live 90 days without eating, but you can only live 2 days without drinking.
What? Really? 90?
I think it's like 3 of them.
3, yeah, 3.
Wait, so drinking?
Wait, you can live 90 days without eating?
I don't know.
no, that's not.
Well, I mean, if you're Liam,
If you sleep like literally 24 hours a day, then yeah.
hibernation.
I can survive 1 day without eating. but then I'll go to the toilet and I'll explode because I have nothing. Because how am I supposed to go to the toilet if I have nothing?
吃饭就吃饭，睡
What
觉
the fuck? All your intestines. Throughout your organs.
I'm so
Better that you do not know.
Does anyone else want the pizza? Last chance.
Aside from me.
Alright, let's split it.
Alright.
You split it and you gotta heat it up as well.
How do
觉
you
得大家吃饱了吗？那个还没有冰，我放在冰箱了。
Are you taking the bigger
刚
piece?
放的。
So, which piece would you like?
The bigger one and smaller one.
Like the
You use the knife.
You sure you want me to choose? Are you sure?
I can't say it's like respectful to let you choose.
Okay, I'll give you the setback. You can choose. I know which one I want. Though.
Just get the one you want.
Alright, give me the base.
This one?
Yeah.
The bigger one.
Oh, so that's why
Thanks.
it says water.
Which I really
And also food, acids, and vitamin C.
No tissue. Go, you can
It's gonna take less space to transport.
Hey. 你不要啦。But then you trade off like time for that.
Wait, should we play basketball now or later?
Now.
No.
You're obligated to play basketball with us. Oh, he's like, it's such hard work. Pizza and basketball.
We should have Liam
If I run around, I'll feel something.
Bro, you didn't even eat anything.
After you drink.
Yeah, after I drink.
Wait, can I suck gum?
Yeah.
Not bad. I need to improve my vertical jump.
So you're not really then. For like 10 centimeters.
Isaac's not even really that much taller than you.
My vertical's just not good.
Like, definitely not taller than you more than you're taller than me. And I never complain about how good Liam is.
Is that because Liam's like not good, or is it because you don't complain?
Both. 这个不是什么 unhappy Liam.
Yeah.
Yeah.
Didn't Liam beat us? Like.
Both of you
Don't choke on pepperoni, that's not
no way.
This orange juice is very healthy. It will provide me with my daily vitamin C.
They say that like orange juice is like got the same sugar as like Coke and it's not very healthy or something. I saw it on video.
Oh yeah.
But then it's like
Why do you trust the internet?
but then like it does have vitamin C.
This has 440 kilojoules. That's like literally Alan's daily intake.
Maybe
So,
Alan.
if you get scurvy or like I don't know, a goiter or some assorted lack of eating medical condition,
he's
I'll
not gonna
not be
be-
surprised.
He's not gonna get scared.
But doesn't orange juice cure scurvy?
Yeah, but he might get
Why
a
you getting
goiter
scurvy?
due to lack of iodine.
Anyone he's just gonna be exploding. Lack of carbohydrates.
Yeah, I'm a little bit concerned for the baby.
Yeah.
对你有意见。What on earth does she want?
他觉得那个他看的 iPad 太多了。
It's like we're telling you why I'm cooking
It's
them.
like, don't judge.
He's like,
But
I'll take it, you know.
It's like it might just be an offhand comment to you, but this is my entire life. This iPad. Are you trying to take away my entire
The
life?
suggestion of replacing it with IMO paper.
yeah, exactly.
Babies can't do IMO.
Here's the
Because they kind of just scribble.
It'll be a good way to learn.
And maybe it's like it's not a writing contest for them.
Make the
We're
baby
log.
edit
We're
essays.
log. F is
2,500
linear.
words.
We're log. Yeah, it's too hard to speak. Can you just translate?
你知道他听懂了，他已经不玩了，他去玩玩
but
具
the
了。
optimal way to raise
You're like
children
a
is to like start training them at maths as soon as possible. Like from the moment they start speaking, just train them at maths.
Well, that's what Freddie's mom told me.
Is that what Freddie did?
So okay, so this is what Freddie's mom told me. Freddie's mom told me that like basically whenever Freddie asked her a question, okay, she would explain it in the most ridiculous detail, like completely answer it as much as possible, to the point that she looked like a lunatic walking to school, explaining like these advanced concepts to this like seemingly 2-year-old.
Yeah.
And it's not like, and the way she said it was not like, it's not like the person necessarily understands what you're saying. You know what I mean? Like if I was talking to you and you understood what I was saying, I would just naturally be motivated to finish the explanation, right?
Yeah.
But for her, like, he didn't necessarily show signs of understanding of what she was saying, but she completed like the explanation anyway.
Yeah.
So like maybe like it was received subconsciously, or like, you know, or he did understand it but couldn't represent that understanding or something. But that's like dedication, you know what I mean?
Yeah.
It's kind of dedication, like as a parent.
Yeah, that's how I would.
Because like it's hard to be bothered to explain something like at that length to someone who you perceive to not be able to like really understand what you're saying, or you're not sure. You know what I mean?
Yeah, but if they can communicate, then you can like ask them. Like,
Yeah. So I'm pretty sure like he must have.
Once they start speaking, like yeah, basically just start speaking.
Yeah, exactly. Once they start speaking, start training them at maths.
Yeah. And I got the impression that he never really like did iPad and all this stuff. He did more like books and, you know, like standard good stuff. So Freddie, you're like an iPad fest.
Yeah.
Yeah, mine was like books and such. Like I remember in year 1, my dad would just leave.
Yeah, iPad isn't good for smarts.
Pages of equations to solve in like year 1.
Like stealing candy from the
Your dad left to go get milk.
You've definitely raised iPad kids.
Yeah. My kids are just memes on YouTube.
No.
Emotional damage.
Yeah, see?
No.
How can you say no now? Yeah, that was pretty good.
Well, I didn't get past that eating. I'm not
Okay, I think instead of turning off the stream, maybe I'll just leave these problems up.
On the probably get your like finger and like solve if you're here.
Maybe I need to like.
You can just give it to me.
I got that easy.
Stealing anything from alarm is like
You want a pizza?
4点来.
I ate a whole slice. I can't finish.
I can't finish.
I ate a whole slice
Alright.
this time.
What pizza?
哦，这个帮我拿出来。
You get my pizza.
是，
You want to take this?
Put it on my plate.
they basically say the same with
You want a pizza?
Oh, thank you.
yeah.
Wait, how did you get here, Ryan? Did you bus it?
How about we split it?
Walk it?
Oh, my dad said we will.
Oh, when are you going?
I don't know.
Go for basketball?
How are we gonna split
I
it?
mean, if I told him off, then he'll probably go to
How are we gonna measure this exactly 100?
Yeah, go with a fork, though. So, Michael, give me a fork, please.
I'll take less then. I'll take less.
What about
Did you eat your pizza already?
Yeah.
Oh, you didn't heat it up.
So I ate 4 slices of cheese.
Yeah, good. You're definitely someone we need to take to these. But it needs to, we need to take you to a buffet. Have you ever had
You take the dollar and I get this.
I think there's a Korean barbecue. Wait,
I've been there with you to the Korean barbecue buffet.
there's another one that's like not quite a Korean barbecue, but it's like a Japanese place or something. But it's a buffet.
So my ability at the Korean barbecue is suboptimal. So I've thrown up that day. So unwell.
You already had one.
Have I?
Yeah.
I got one pizzas.
Very nice.
I only have one.
You didn't have a single one.
Yeah.
Yeah, same thing. One is basically
Somehow. Oh yeah, I don't understand how I can be good at like Olympiad, but how I failed AMC and got only high distinction. Because my dad made me practice so much for AMC.
Wait, you got your results back? Oh
No,
yeah.
I'm talking about like when I was a lot younger. In like year 3 or 4 or 5, he was like making me do whole books of AMC past papers.
in year 6 you got distinction, I remember.
Yeah.
Yeah.
I was still throwing.
This is a pizza
Since my
party.
strengths do not lie in speed
Yeah.
contest.
You know what I mean?
Yeah.
Tower Heroes. There's a
Yeah.
pizza party in Tower Heroes.
What's the best you've ever gotten for AMC? Oh, nice.
Because I was like practicing like
How many slices do you eat?
Even with on the AMC practice, I still do.
Yeah.
like in year 5 I was doing the year 7 AMC class. So
Damn.
so
Yeah, 2 slices is actually like 1 slice because it's like 8 slices per
think I've
pizza,
ever
right?
been
That's 16.
Let's see. Yeah.
I'm fast at solving things that should take you a while. Fast at like the
Just
fast.
pizza.
So we can jump on.
Like I think there's been time I've solved like the IMO problem in like 5 minutes. Multiple times. But like yeah.
I remember when we were young, we like took pride in how much we could eat. And the thing that I really remember was like there was this like, have you heard of Sizzler? It used to be a thing.
This is the only way of getting
Sizzler was like this franchise where they kind of sold like steak and potatoes, those kind of meals, like mixed grill, that kind of stuff.
Yeah.
And also vitamin C, of course.
Yeah. People were amazed I could finish a mixed grill when I was in high school.
So you have the amazing skill of being able to finish the mixed grill.
Yeah.
I can like her.
Michael's special skill. I can finish a mixed grill. What's a mixed grill?
This is the real story.
Yeah, this is your real stuff.
This one is. This one doesn't
I'm
have
just getting
the
off basically.
Wait, there isn't that much height between Mini Michael and the Lance. It's only like that much. Still not that much.
Mini Michael's like way older than that.
Yeah,
I like this one.
Oh, Michael.
Okay. That's a Korean.
No.
Oh yeah. Rock is not a game of luck. You can be good at things.
怎么了？你要讲话啊？
No, not yet.
oh, why did it really long?
I could never do speed contest.
Here's your doll.
Party. 你不要说，你给我。
你哭就是为了拿这个呀？啊？
Careful, man.
like we need to scout out like the next place to eat at. I feel like the pizza. We conquered the pizza.
Have content.
It's a bit small. I probably could have eaten it twice.
Yeah, the pizza was conquered.
Yeah, you guys conquered the pizza.
I'll like another
You
5
conquered the entire pizza.
Isn't this something called Pizza Pod Intelligence?
Yeah, pizza. Order.
Come on, go to some all you can eat and make them go bankrupt.
No, they won't go back.
Oh, Liam will make them go bankrupt. Liam will eat
You
like
give
half.
us a buffet and bankrupt the buffet.
That's a scrap. So you need to go to a buffet that has really, that has like actually expensive stuff.
Bro, he's gonna buy it.
Oh, you know what's a good
buffet?
So like the Las Vegas win, or like the Las Vegas buffet.
Oh, what type of stuff do they have in the Las Vegas one?
They have like, pretty sure they have like, I don't know, pretty much anything you can imagine. So I'm not sure if they have lobster.
I'm full.
And they have like chefs that like make stuff for you if you want.
Whoa.
Also, how do you feel about stealing food from malnutrition?
Pizza party.
It's like stealing candy from a baby.
You're right, it is.
There's kids starving in Africa.
No. Meow, your pizza.
Why don't you like
Oh, yeah.
eating a lot?
Bro, when you're
Meow,
baby,
the pizza.
bro, when you don't finish your food, your mom's like, what about the starving children?
I'm actually pretty sure there's like kids starving in like, not just Africa. Like there's parents who like try to save money by like not feeding their kids hospital.
There's probably kids starving in Australia right now.
This kid starves himself. He wants to be starved. Like,
I'm starving.
Oh,
His
yeah.
name is Starving Child on the road.
You should give that a
Your
count.
pet name is Starving
That should
Child.
be a last name. That should be a last name.
Wait, is your avatar free?
Oh.
How much is it?
I don't know. I mean, I could sell my room.
You got limited to no wear.
I am wearing them!
Oh. Headphones. Oh, those.
Yeah, but they're see you see them.
How much are they?
Like 200.
Those are nothing.
Yeah, exactly.
Are they limited to the 200? Limited are like up to like 4,000. Like, at least like 1,000.
Yeah, G5 is actually a cool problem,
You can make anything limited now.
but it's kind of too hard for G5.
Yeah, okay.
Aren't they limited from the county?
Wait, so you spend your option.
Thank you. If only it was that easy.
Well, what else do you spend?
The game passes.
Bro's gonna get Excel.
Like old games. Like I used to play.
Alright, we're going to exercise break. I'll leave the stream on. You can think about these questions.
Oh my god, you should like write in like the pen. Exercise for chat. Solve all these problems and send the answer in chat.
You don't put tower defense when you get to level 15. That's Slava's.
Oh, one thing and it's predicted and
That's what you said.
no.
what's Alex going? I told you.
But when I'm level 50, I just get turret.
Yeah.
I would have used it.
Yeah, you like use it for a bit, then you could.
I also got 10,000.
Alright guys, get ready, let's start.
You have raised it? Yeah.
Let's
I have
go.
10,000 coins right now. I'm saving for golden.
Alright, 2 groups. The weak group and the strong group.
Weak.
Yeah, us.
Strong group is
Skin cancer, Melvin.
I'm gonna be brutally honest. The strong group is probably me, Alex, David, and Ryan.
You should rename your fucking Michael. So you'll be Michael.
I feel like, in my personal the strong group is me, Alex, David, and Ryan.
Because David doesn't have skin cancer. He's got
Because these two are tiny and malnutrition. Your children are obviously not.
I think Michelle might go there as a run.
Oh.
Maybe. Alright, let's get going, guys. They'll meet at level 1. And the people running just start running.
Wait, who's running?
I think it's David, Liam,
Bruh.
OG. Wait, Michelle's gonna leave. I'll pull out. I'll get you.
我需要你是跟我吧？
I'll go.
不知道，他跟我。你要去见你的朋友在公园，知道吗？
No, not the place one.
跟你的朋友不一定有到，类似于 like。
哦，等我下去。
only goes like the place when it's
下次别人也不约你了，万一人在那。
Well, I wish the guys don't
我为什么跟爸爸说呀？这个男孩子很无聊的。哎，
You gave your slice to me and made eating faces with your face. Try and look like you went around. She's like,
he's eating his daily 5 kilos of air. 0.0001 kilojoules per ton.
can you flex your calves?
儿子，你一下，我手机过来在那。
He doesn't have anything. His bicep, he goes up like 3 minutes.
你走吧，去公园吧。
Oh, I'm actually not
我
going
今天不出去。他要跟你去公园。
Alright, Ryan, you're running. Press the elevator.
I love how everyone just acknowledges that Slava and Alan are weaker than Ryan.
Wait for me.
So you probably should put that. Well, that's suboptimal.
Bro, I just hate running with these sauce.
I feel like, I don't know, remember like when I was in high school, we'd always have lunchtime, right? And we'd have like very limited time, so we'd eat, and then we'd just play basketball or something. Yeah. I don't know. Alright, I mean,
不可以这样子哦，生气就打 iPad 了，不可以打，没有 iPad 了，把它打坏了。
要穿裤子了。Yeah.
Okay. You'll find. Oh. Which one? Wait, I'll just give you.
I'll take the orange one.
I'll take the yellow one. There's like a purple one there. Is there any more? I think it's the last one. Yeah.
There's an orange one.
Oh. That's this one.
Are there any more?
I don't think so. But this is medicine. No, it's not. It's lemonade. No, it's lemonade flavor. Okay, so then what's yellow, dumbass? Yellow's purple.
No, this is a Zuka Duper.
Yeah, it is. Yeah, it's a super duper, but it's like lemonade. Mostly for sick people. No, it's lemonade. Like, we use it for sick people, so.
No,
we are not with the lemonade. We don't use that. We don't use that. That's lemonade flavor.
It contains solvents.
Over here, it's just last one.
Oh, do you want it?
No, I didn't need.
You sure?
Yeah. Bro can't play Roblox when he's using Super Duper. Yeah, I can't play Roblox. Oh wait, let me do that. Oh wait, it's over there. Oh wait, scissors. Wait, do you want me to show you? Do you want me to show you? Like, I'll prove that whole 5 minutes.
Yeah, I know you do. You just got the you just hacked.
I didn't hack! You can't hack on mobile!
You went onto the computer and then you installed hacks, you know.
I have my computer at my grandparents' house and I can only go to my grandparents' house at the weekends.
Oh, you time traveled to the weekend.
What the hell? I didn't have a time travel. I'm pretty sure you can time travel. Look, I'm gonna time travel. 1, 2, 3. I time travel 30 seconds into the future.
Wait, where is the scissors?
It's there.
Where?
Wait, when is it? I'm not hacking!
Hacker alert, hacker alert.
Shut up! So let me show you.
Boy hacks on
enabling hacks in that game.
Boy hacks on Roblox, instantly regrets it.
I'll prove I'm not hacking away. Okay, now. Wait, this guy's got 9.1. What the hell?
Boy hacks on Roblox. What happens next is shocking.
Oh! I try hard. This game for some reason. I killed someone, but then I died. Yeah, I killed someone!
Michael's son hacks on Roblox.
Yeah, I killed someone! I killed someone! I already killed someone, like 10 seconds in. Stay alive. Wait, do you ever use the side buttons? No.
What are they even doing?
They dash. Correct. Oh, wait. How? How?
Is it KDR 6.8?
Who's the hacker among us? We need programmers. Bro, someone stole my kill!
What's your streak?
There's a hacker among
streak?
us. We must roll. My best streak is 11.
What's your best streak on? Wait, do you like get new swords based on your
Oh, by
best?
the way, I kept getting the green potion for some reason. I don't know how. Wait. Bro, someone keeps stealing my kills! I don't know. Wait, have you joined me? Mm-hmm. Do you want me to help you? What do you wait, actually, let's get them legitimate.
Wait, how do you get better?
Bro, I one-shot someone while they were denying someone.
How do you get better weapons?
Get more kill streaks.
Wait, do you like an average or do you just a high?
How? Average of your top 10. Oh. Wait, this guy's cheating. I'm pretty sure. This average of I need like. Was there
It's like swim now.
Yeah.
Exactly. Alright, guys. The whole point of that was to lose Ryan. We lost Ryan.
Oh, wait, you guys lost Ryan?
Ryan disappeared. Oh, what? No, he's getting picked up in the park. Oh.
You're still playing? Oh, you're not. This guy's probably good. This guy's like 8
I'm gonna use that. Oh,
you just drink large amounts of water.
No, you're not. This guy's like e-boarding.
Oh.
The kunai's arm touching me and it's still hitting me. Ow! I killed someone. Oh, no. Oh, ow! Is this guy
Blood's got a 1 kill
Is this
streak.
guy
Bro, I'm gonna have to go get home. I'm gonna get like a 20 kill streak.
You're not.
Yeah.
It's trash.
Yeah, but it's still on a PC.
I don't get the appeal of Roblox. It's like Minecraft, but worse.
No, it's not because there's infinite games.
It's got more games than
I play Supercell.
Guys, I have 2,000 hours of video.
Yeah, I used to be addicted to video games.
I have
I once
2,000
got
hours of video.
2,500 hours of Minecraft in 1 year.
What?
Oh, yeah.
Bro, my friend
How's
has
that
like
possible?
3,000 hours in Rust in a year.
But 2,500.
Lockdown.
So that must be like.
Dude, that's like nothing. That's like my friend has like 3K hours in Rust in like half a year.
What?
Oh, wait, I killed someone. I've got 2. Same. I'm gonna try
And
to
it's
get
4,000
5.
hours. There's 4,000. It's like 4,000 hours is half a year, and he's got 3K in half
Actually,
a
I
year.
need to get 6 to get my 80 kills.
I have 52.
I need to get like a 6 kill streak.
52 hours in
So
what?
it's probably
Game.
I've just stopped gaming.
I have not stopped gaming.
What games do you play?
Let's see.
Bro, I had 3 years in Cookie Clicker.
I mean, I play like Geometry Dash, Geometry Set, Getting
Yeah,
Over
no,
It,
Chess.
yeah, ironically, I
Yeah, I
accidentally
have
played my
fun.
computer and I think I did.
Chess counts as a game. I thought we have like
I just don't want to go 3 minutes. I told you I'm good.
Bring like 50 to get in best weapon.
50. Average 50.
It's gonna be 50 10 times.
Yeah. Not really. But that was only boys.
Oh.
No one. Let's each other. Wait, I'm not going to read this. But let's first other people first. Let's get other people.
Yeah, something's definitely up with my back.
It's lagging for me as well. Are we all using the same Wi-Fi?
You're cool up.
My stomach is so weak. I'm going to go to sleep after supper.
What?
Gaga. Gaga. 小白狗，
I'm
Melissa 要你过来。
But the stream's still on, I think. You try to stream too.
my stomach has officially begun suffering.
Alex, you want to present G5? Or do you want to skip?
I guess I can put
Alright, it's G5 time.
G5 and
Me and David do the same thing.
Alright.
Oh yeah. We have different colored socks.
Yeah.
That always happens to me.
What's happened with the stream? It's still on.
What the hell? Why is my socket trying to hold me?
W Special Raw 50. Hey car, what popping my G? OMG, William Chia, is that you? What?
Wait, what the hell?
What the? What does that mean?
Is it William Chia, the AIMO guy?
Yeah!
what is bro saying?
What the hell? I was like, I need to go on this stream to be right. What the hell is going on?
Wait, but we have to go into like place where there's no.
这是谁啊？
OMG, William Chia, is that you?
We need outside the map.
Alright. Let's go, Alex.
We're not gonna fight outside.
That was the most random thing
Although I killed someone outside the map.
Okay.
I'm outside the map. Which size?
There must be such a Chia call.
It's so stoned.
Wait.
Wait, you guys are playing games?
Recording in progress.
Wait, I think I know.
Okay. Let's see. Let's move this up. Okay, G5. What is G5? So, G5. Let's see. G5, the question is, there's triangle, acute triangle ABC.
You're not even watching the same direction.
Sorry.
You're lying.
AB is greater than AC. Oh, BC. Whoops. Let's see, I think. Is that what it says? Wait, how do I go to Discord?
Oh, yeah. This is alt tab.
Oh. Okay. Yeah, AB is greater than BC. There's in center I. So. Meow. I. Okay. And what does it say next? It says that the midpoint of the side AC is M. M. N is the midpoint of the major arc AC of the circumcircular triangle. So it's going to be this one because it's a Q. It's not going to be this bottom one. It's going to be this top one.
Okay.
And now the question is prove
Angle.
CMI equals INB. CMI equals INB.
Oh.
Okay. Those two, we need to prove they're equal. Yeah. So, yeah. It's actually a very, very simple diagram with very, very simple angle definitions. But I guess that's precisely what made this problem difficult, I guess. Because, you don't have any information. Because they just pulled out randomly two angles out of their ass and they're like, prove they're equal.
Yeah.
It's like, what?
Complex metric right now.
Yeah. But I didn't want a complex batch G5 because then what do I do for the other 3 points? I'll leave that till last. Yeah, okay, so yeah, so basically I was really confused because I don't okay. Firstly, what do I do with M and I? Right, M and I, that's like two completely unrelated things. The midpoint and the incenter, that's not related very much.
Do you draw like N prime or something?
Not
Antiprotic N?
Antiprotic N. I guess you could try that. And also, what do I do with N? Right? Because, like, we all know this point, like, I think a lot of people use this point, right? Because, like, BI go, like, down here.
Yeah,
right? That's very useful. I just call that D or something. I don't know. Like, a lot of people know about this point, and we know a lot of information about it. What the hell is N? Especially considering BN is one of the lines in the angle. Then we have IN. What even is... Okay, BN, we can angle chase the angle. But IN... I don't... Like... Okay, yeah. So my point is that I didn't know what I'm doing. Okay, but what I did know was that whenever I was confused about an in-circle problem, or an in-center problem, there was this lemma that always bailed me out called the in-center x-center lemma. And I was like, okay, so I just kept that in the back of my mind. I didn't actually end up using it, but like, in the previous times where I've been stuck, I think I should show everyone this, because like, I don't think everyone knows it. Okay, so say we have triangle ABC. Yeah, okay, so this is going to be the midpoint of the... Alright. So basically, what is the incenter x-center limit? Yeah, this has basically like saved me several times. So like for last year's ASC Q3 I used this, and ATT I also used this. I don't know, so I guess I just thought of it because it was probably useful. I called this EA, but I probably should have called this IA, okay. But yeah, so the in-center x-center lemma, what is this? So basically, it says that, so this is the in-center. This is the x-center, the AX center, right here, with this circle. And then D is the mid-arc of the minor arc. This is a minor arc, by the way, not the major arc, so we can't really just use it. And the claim of this is that this is cyclic.
And D is the center.
And D is the center of that circle. And also I and EA, they're like D, they're like the diameter of it, right? Okay, so that's... So obviously they're all on these are all on the angle bisector. So this is proof, I guess. I need to put the proof because this will be useful for later. So obviously they're all on the angle bisector. Let's call these two like alpha. And let's call it, so I is on all of the angle bisectors, so we'll call this beta. And gamma. This is a typical angle chase exercise. So how do we prove D is the center of this big circle? We'll do like BD, DI, DC, I guess. We want them all to be this equal length. So to prove that, we're going to try and get like this one's isosceles, and then by symmetry, this is isosceles. So if we bow tie that alpha down here, we get this is alpha plus beta. And then if we use the external angle of this triangle, alpha plus beta, so this is also alpha plus beta. So this is isosceles. And by symmetry, this is also isosceles, so these are all equal. And you could also angle chase this as well, this outside X circle. But what we can do is we can realize this is the external angle bisector, right?
So this is the internal angle bisector, but this is the external one that goes to the x-center, which means that this is perpendicular. And because there's opposite right angles, this is cyclic. So we already have that D is the center of BIC because we got that equal. So therefore this is also cyclic, so it's also equal. And this is the diameter, obviously, because it's a straight line passing through the center. So that's the in-center, x-center lemma. And yeah, it saved me a lot of times when doing in-center questions. But usually I didn't really use the x-center part. I only used the very useful lemma, dB equals di equals dc, right? That's actually very useful, and I think that's the part I used for a lot of the other stuff. So yeah, so unfortunately I couldn't apply it to this very well because I don't know, it's n, it's not d, so I can't do much. So I didn't know anything about n, so that was pretty sad.
Connect n to d. Join it.
Yeah, you can, I think, but I don't think I did that for this. But I will draw it for now, because basically what I was starting to think about is, what is this angle, right? The scary thing about this situation is that, like, you're not familiar with the angles. You don't know what the angle of IM, the line IM is, or like IN. So that's why it's kind of scary. So I was thinking, do we know these angles? Right? Have we seen these angles before at all? Or at least have I seen it before? Like, what relates I and M? And yeah, I thought all the way of this back to this one thing that relates I and M all the way back when I was in year 9. We were reading Euclidean geometry, EGMO, but it has this European Girls Math Olympiad book. Euclidean geometry, Math Olympiad. Euclidean Girls in Math Olympiad book, where we drew the X. It's the in-center, x-center dilation diagram. So, yeah. So it was actually a pretty cool diagram. And the reason it was cool is, so basically there's a dilation from the in circle to the x circle. You can kind of see that there's a dilation from B, from this in circle to this x circle. It's like, scaling. Right. And pretty much what happens is, this x circle has a touch point. So the in circle has a touch point and the x circle has a touch point. And by some length chasing, we actually realized that they're equidistant from the midpoint.
Your midpoint is midpoint.
So I think, how do we get that? Let's have a look. So yeah, I should explain that as well. So let's see, how do we get that? Oh yeah, basically like okay, so to length chase it, you define this thing called S. This is the semi-perimeter of the triangle, I guess. Actually, no, let's just do P. P, perimeter of the triangle, which is just AB plus BC plus CA, right? And what you'll notice is that this and this are equal, and this and this are, okay, basically the tangents from the in circle are equal, right? Like these two tangents are equal and these two tangents are equal. And overall the three pairs of tangents add up to the perimeter. But because this tangent and this tangent add up to this side C, the side opposite C, we'll call that length C. If we subtract twice that, right, because we have this tangent and this tangent, so we're basically subtracting this one, this one, this one, and this one. Those total to 2 times this side because they're equal. So if we do P minus 2C, we get this one plus this one. And then if we divide by 2, we just get one of them because they're the same. So basically, C to this point, that's this. I could use a different color. Whoops. But yeah. So do you get that? It was just like confusing. I don't think I explained it very well.
I think they should know it from class, that that's S minus C.
in circle topics.
Yeah.
Yeah.
Yeah. So similar to that, I guess we'll try and prove that this distance is the same. So, yeah.
You guys know that's also S minus C.
This is also S minus C.
With the X circle now.
So, how do we do that again? Hold on, let me check. Oh yeah, basically like these two lengths.
Yeah.
Yeah. So you can kind of equate this length with that one, and this length with that one. And so these two lengths added up together is the perimeter. And then yeah, so those two are equal, by the way. So therefore, one of them is the semi-perimeter, right? Because it's one of the tangents. And then you just straight up subtract C from that, and you get this one, and that's equal to this one.
Yeah.
So that's S minus C as well. So now we get, okay. So now we get, this is also equal to that. Nice. So, yeah. So here's the cool thing, right? Now, we consider when we dilate this X circle to this in circle. This top point, the touch point, goes to the top of the in circle. And it does this. Whoops, can't draw. Alright, and we can draw a straight line to indicate, like, this is a dilation. Okay, so what's the cool thing here? Is in this diagram is that actually, so this is all from EGMO.
This is like, actually this is...
Yeah, this is just well known.
Actually, if you just click that tab, like...
Oh wait, right, the three lemmas. Yeah, where is
You
this?
need to find the tab.
Where's the three lemmas?
It's one of these tabs.
You have a lot of tabs, sir. Have you considered closing?
Oh yeah, this one, let's go. Okay. Yes, this one. Alright, here we go. So you can see from this diagram that like, pretty much this happens, right? So you can dilate from the X circle touch point to the top of the in circle.
Yeah.
Diametrically opposite to the in circle touch point. Well, watch what happens when you take the in center and the midpoint of BC, right?
It goes to the other in center.
So when which is...
Oh, you want to draw or do you want to go back to the whiteboard?
Where's the whiteboard? We need to put it on a separate... okay, hold on. I'll just make it separate window. There we go. Okay, so now we can see that this equals this. This is terrible. I need to use new colors. This equals this because they're both radiuses of the in circle. And then this equals this because they're both... We proved that.
Mm-hmm.
Okay, so what happens now?
No.
Yeah. So the lines are parallel, which means that...
I think so, yeah.
Yeah, there's that parallel, which means that this angle is also equal, right?
Yeah. Oh. Can we get some more water and then continue dining on the couch?
Yeah, so that's pretty crazy. Yeah, I think there was a lot of other facts that came from this diagram. Like, I think there was... There might have been something relating to... okay, I'm not sure. I think there was something relating to, like, the tangent, right? It's like, if you draw the tangent from the midpoint, you also get that one. Something. I don't know. It was something along those lines. But yeah. Anyways, you may be asking, why did you show me all of that? Does this solve the problem? No, I actually didn't use it at all. Okay, the only reason I actually went over this was because it was on the I don't know. I thought we should go through. Okay, so I actually didn't use this at all in my solution. But what this did tell me was that I know about this angle, but at least I know some things about it. I'm slightly closer to solving it. But what it did tell me was that the X circle is relevant. This angle is related to the X circle philosophically, right? Which means that I should be focusing on X circles. Because remember before, okay, all the previous times I'd used this thing, I'd never used the X circle part of it. I only used this thing, this part, I, B, D, and C. I'd never used this. So, this was an indication that the X circles, well, they're very... I need to use them. I need to do something with them. Unless I was to, of course, trig bash was like my last... It was all complex bash, I don't know, depending on which one. Wait.
What? Oh, that one? It's mine.
Okay, I'm gonna like... Okay, now I will proceed to delete everything because I didn't actually use that. I didn't actually use it, so I guess it's just not... Just delete it, get rid of it. Alright. So now, armed with the knowledge that I have the X... that I need to use the X circle, I looked back at the point N and everything started making sense. Because BN is the external angle bisector. Which means that they actually lead to the other two X circles. Okay, hold on. Wait, they lead to the other two X centers. Let me just draw them in.
The eccentric triangle.
Because yeah, like if you drew the D and that's make it the external.
But yeah, now I had more information because now like you might think like, oh bro, you just did all that for nothing, but this is motivation for something, and that's like all you need in geometry. You need motivation to do certain things. Like you don't want to just be flailing around randomly, but now I have the knowledge. Yeah, they're related to the other X centers, right? Because B and N. Yay. Okay, let's write EA and EC. Yeah, and at this point I realized I solved it, but anyways. So now I'm going to introduce to you something quite preposterous. So everyone's heard, okay, not everyone, but many people have heard of the in-center X-center lemma. But not many people have heard of the X-center lemma. Haha. I don't even know if it exists, but I invented it. But the point is that, like, X-centers, you know, they're basically like the in-center. All the angles are the same. They're still bisecting the angles. But, like, it's just that the outside of it, because of diagram dependency, they're outside the triangle, so they get excluded from being the true center when that in reality they are just another center. Even in complex fashion, they're just like different signs. So in theory, everything with an in-center and X-center should work between two X-centers, right? Okay, so let's see what happens in the in-center X-center lemma. Right? So in the center X-center lemma, D is the center of BICEA. And D is the midpoint of I and EA.
N's the midpoint of DC and EA.
Yes. N is the center of the circle EACAEC. That's the claim. Let me draw in two more lines. Okay.
N's the center of which circle? EAAC.
Yep. Maybe I should do this in a different color.
Does that go through?
Yeah, maybe I should do this in a...
X-center lemma.
X-center lemma. Something I randomly invented.
We'll rename it the Alex lemma.
I don't know if it already is called the X-center lemma or has a different name, but...
It's the Alex lemma now.
But it exists, so... Yeah. So yeah, basically I claim that this is cyclic and that N is the center of it. Yeah. So... Yeah, but you can see that in theory, we prove the in-center, X-center lemma so easily, so this should just be angle chasing as well, right?
Uh-huh.
Yeah.
I guess let's do it. So I don't know how I did it, but we'll just do it here. Okay. So we kind of want... Okay, so obviously NC equals NA, right? Because N is the...
Yeah.
N is the midpoint of the arc, so these two are gonna be equal. So well, we're all good with that. These two are equal. Boom. Okay, now we just gotta include EA and EAN and ECN. We gotta prove those are equal as well. And then we're gonna be done proving this. So let's do some angle chasing, alright? This would have been nicer with directed angles, but I'm not sure how they work with this, so... Okay, let's firstly do this. Okay, I'm just gonna call this angle B. But I'm gonna conflate the angle with the vertex. Okay, and then I bow tie it to here. And then I'm gonna say this thing is 90 minus but on 2. 90 minus but on 2. Okay, so, yeah. And also, I know that, hold on, let me just check. Yeah, also, I know that, in order to access these C to EA, A to EC, I suppose, I'm going to need to, label them as the angle bisectors, right? So, I'm gonna have to say that this thing, that's, 90 minus A on 2. And that thing's gonna be like 90 minus C on 2, I think. That's how it works. Okay. Let's see. Oh yeah, so the reason why I got these guys is because I can actually bow tie them up. Hold on. I got this guy because I can... Wait, what did I do? Hold on. I forgot what I did. Let me have a look. Okay. So you can bow tie A, angle A up here, I believe. So this is angle A. EANC. That's just BNC, BAs. Okay, so I need to somehow obtain... Let's see what... Yeah. Yeah. So I think what I want now is just I want the angle NAEC. So what did okay. So this is also angle A, I think. So this is so notice this is not angle A, this is angle C. This is C. Because notice how this is the external angle of this cyclic quad over here. This is C. Okay. So I guess I want to prove that this is isosceles. So I think what I did was I tried to find this angle, right? So let's see, what do we need to do? So basically, let's just write out the math, because I was hoping I could just do it on the diagram, but it gets really messy. Let's just do it. Okay, let's write out the math. So I want to find NAEC, I think. Yeah. That's gonna equal BAEC, which we already know, is 90 minus alpha on A on 2. And we want to minus BAN, I guess. Okay, and what is BAN? We know NAC, and we know angle A. So that actually equals 90 minus on 2. Minus, here we want to take NAC, which is 90 minus beta on 2. I mean, 90 minus B on 2. I would say beta, but like... But I think I already used that here, so that's not good. I should not use... minus this angle C, I believe? Wait. Let me see. Yep. Hold on, I'm just gonna check.
Minus angle.
Wait, no, it's only got, yeah, it's minus A, not, okay, yeah. Minus A. Okay, let's do the math. So the 90s cancel out. The A becomes positive A on 2, and the B becomes positive B on 2. Nice. And that equals 90 minus C on 2. Because angle sum.
Okay.
Ooh. So now this is NAEC is 90 minus C on 2, but this is C. Right? So this is also 90 minus C on 2.
Oh.
Yay. Done.
Oh. Cool.
And you can like can do the same thing for the other side.
Very similar.
Yeah.
Right? Because we have it's very similar, except okay, remember we're given AB is greater than BC, so clearly these guys don't know how to deal with diagram dependency. So I'm also gonna have to not know how to deal with it. Yeah, let's do the same thing. So what is, let's just swap the letters. NCEA. Right, NCEA. We know this is A. What is NCEA? Wait, no, why did I write C as subscript? A as subscript. NCEA. So we're gonna literally use the same method. So we're gonna okay, not literally. It's a little bit different. So we're gonna have to take BCEA, right? Because we know. Why did I mark it like that? That's not even true. That's not 90 minus C on 2. This is 90 minus C on 2. That's the angle bisector. So 90 minus C on 2. Angle bisector. And this time, because we're not using directed angles, which is really annoying, I'm gonna have to add this part in. I'm gonna have to add BCN.
Oh.
So this is why I can't just say bisymmetry, unfortunately. This is sad. Okay, so what is BCN though? So BCN equals angle C minus NCA, which is 90 minus beta on 2.
Is it beta or B?
B, it's B. I keep reading as beta because I'm used to beta, but I used beta in the other proofs, so I can't do this.
I guess B is beta.
Yeah, they're literally like B but longer.
Yeah, like it dripped some.
Yeah, okay. So this ends up being C and C on 2 makes C on 2. 90 cancel C on 2 plus B on 2. Yo. Equals 90 minus A on 2. Yo. And then we're done as well because that's A. So this is 90 minus A on 2. Okay. So now we're done. We did it.
Like, so for some reason, like since I've been writing my junior book recently, I feel like the first thing I saw in the green diagram is like, you know, like EIA is linear, right?
Need some water.
Oh, yeah. Should be something in the fridge, yeah.
Where's the water?
At the very bottom.
The very bottom.
You see it? At the back.
At the back? That's milk.
You know, is there water?
Nah.
Did you take the last water, Liam? Oh, what? Liam took the last water.
Oh. I just drink regular water. I thought it's alright.
Right, I'll get some water.
Sorry for taking the last water. Center in center.
X center lemma has been improved.
Yeah. Yeah, my first reaction to the green diagram, right, was like, because do you remember this from Althing? Like the X center, like EAIA is collinear, right?
EAI.
Yeah.
Yeah.
So essentially, like EAAEC is 90 degrees, right? You know what I'm saying? EAEC is 90 degrees. Yeah. Because the angle bisectors meet at 90 degrees, right?
Yeah.
And so then you get EAEC is the diameter.
Yeah, you also just have that EA and EC as collinear.
Oh, what you compare to the other side?
Yeah.
And then.
But yeah, it all makes sense. So yeah, now EA and EC is a diameter with N the center. You know what that means? We just made a midpoint. We just made N a midpoint, and N is also a midpoint.
I was trying to say you could prove that it was in a circle by saying
yeah.
EAA.
I mean, I did this all just to prove N is the center though.
Oh, but didn't you proved N is the center by showing that NCA is isosceles.
Huh? Oh, wait, no, that doesn't. Wait, does that work? Hold on, let me check. Wait, so if this is oh, yeah, I guess you can sort of like say the intersection of a diameter. You know this? Yeah, you know it's a diameter. You can say like the intersection of a diameter with a perpendicular bisector, which is also going to be a diameter. That has to be the center. So yeah, I guess that's faster. Yeah, that's a lot faster than that. But yeah, I guess what he was trying to say is like, draw this line. So EAIA is collinear, and ECIEC is collinear because the angle bisectors. Right, the angle bisectors of A and C. So then, since this is like a right angle, this is a right angle between internal and external bisectors. This is cyclic, but then EAEC is a diameter. Okay, but then we also know that N is on EAEC, and we know that MN is a perpendicular bisector of AC because it's like these two are equal because it's the mid arc. So since the perpendicular bisector of a chord, it has to be a diameter as well. Intersection of two diameters, that's the center. So I guess that's way faster. Yeah. This is like two diameters, like boom and then boom. Yeah. I guess that's a faster proof that N is the center. Alright, but I did all this angle chasing because I knew you could do it. Knew it worked. So
motivation.
Yeah. Okay, so what does this give us? Well, basically what it gives us is that we want to prove originally that CMI equals I and EA, right? But M, which is the angle that the angle's at, the vertex the angle is at, M is a midpoint, but now we also made N a midpoint. Do you see what this means?
Midpoints.
I don't know what to call it. Due to cyclic, this angle equals this angle. This angle equals this angle. These are similar. CAI and EAECI similar. IN is the median of EAECI. IM is the median of CAI. They should be the same.
They're similar medians.
Yeah.
Medians. Medians with an I.
Yeah. That's it.
Oh. Wait. What's happening here? What was the last step with similar? How are they similar?
Yeah. So, hold on. I should mark this angle better. So this angle's that. This angle's that. So we're trying to prove those two are equal. So bicyclic, this angle equals this angle equals this angle. Obviously with the cyclic, right? If you have anything like cyclic, like bow tie, they basically just give you these two similar. Right, so yeah. So therefore these two triangles, they're similar. in the cyclic quad. And IN is the median. IM is the median.
Oh.
CMI,
And it's on the side.
INE, INEA, which is INB. And it's done.
Angles in similar triangles.
So yeah, that's it.
Oh, that is actually a really good problem.
Yeah, it's a pretty cool problem.
I'll remember the X center, the Alex.
X center, X center.
I
I don't know, man. I feel like this is just something that people can discover themselves.
We shall call it from now on the Alex lemma.
It's like, what is it? It's like the X center, in center, X center lemma, and then simplifies the X center, X center.
I feel like we should name it.
You kind of get the 9 degrees from the in center, X center lemma. And the other 9
Oh, the 90 degrees is just because of internal and external angle bisecting.
But that's the
So
same
it's just
reason.
like easy.
Yeah, like, but that's the same reason.
Oh yeah, I mean, I already proved it like that. Yeah,
Yeah, like
same reason.
Yeah, because in center, X center is the same.
Mm.
It's the same 90 degrees.
Yeah, so it's like you get from two cyclic. It's like this one and then this one, and then you get one big cyclic. Boom.
It's like half of the in center, X center lemma, and the other half of the in center.
Yeah.
Give it X center, X center lemma.
Wait, there's two intersecting circles. You know that?
Oh yeah, there's a similarity, spiral.
Oh, spiral similarity. Wait, let me check. How's this like? Oh yeah. I guess. But yeah, that's it. That's the problem. It's pretty crazy.
I feel like we should brainstorm some other geometry.
I solved problems so much better at home because I don't know. Maybe it's because Liam is not here.
Yeah.
Like when I'm with Liam, can't solve problem.
I mean, it is like a different. Because what happens is like
Recording stopped.
it's like you're kind of engaging like a bit of like audio visual instead of just writing and thinking.
Yeah.
So it's a bit different. And also, like, if you ever get stuck on a problem, Liam will be like, "This is the hardest problem ever." And so like it makes you wonder, like, you know, it's like if you had doubts, it could magnify those doubts, you know.
Why listen to me though? I'm not like worth listening to.
But you just kind of naturally take in your surroundings, you know what I mean? It's just natural.
Yeah, this problem's pretty crazy. I feel like it's a lot harder than a D5 should be because you construct so much stuff. It's 2 points, but still a lot.
The write-up should be pretty short though, right?
Yeah, I wrote it. It isn't very long.
Alright, you guys want to look at G6, 7, or 8?
You could do 6 because it's the logical next one.
Yeah. Sometimes I worry because, yeah. Let O be the circumcenter. What's it saying? The triangle ABC. O is the center. D is the point such that DBC is 9 degrees. DBC is 9 degrees. So it's like D is here, right? That's D.
Wait, it might not be on the circle.
Oh, it's not on the circle? Just a point.
It's just a point.
So it could be like
anywhere on that line.
Alright, let's call this point. I kind of want to call it D still. Let's call it P, and then this point's D. Yeah?
D.
The line OD intersects the circumcircle a second time.
OD.
ABD. A second time.
OD and ABD. Okay, that's weird.
This is quite confusing.
This is quite hard to draw. Because the circumcircle of ABD is a little bit big.
Okay.
Oh my god, why do OAD look cool?
Are they cool? Yeah.
It's not look
Maybe move A like to the other side of it.
Other
yeah, maybe
side.
move A to AB is greater than AC.
AB is greater than AC.
Like
Oh.
Yeah,
so it looks less weird.
Hmm.
Oh crap. But then like there's diagram dependency actually, because
Alright, revert to original diagram. Conflicting information, and then OD is that, right?
that's E like right next to
The second time.
why does E look like it's on some something? Bruh.
Right,
Alright,
A.
I'm gonna get one of these random map sets. Oh my god, that one fell apart, so I had to put a pencil in it.
I need to redraw this diagram. TBC.
Bruh, this ain't working.
Never mind.
Oh, no, I need to figure out how to get this working. Okay, hold on, I can twist it like that. Oh, there we go. This is so scuffed. It's like, you twist it and then it gets stuck in there. There we go, look at that. It's sturdy. Alright.
Ugh. What's up with diagrams?
Oh my god. This compass doesn't preserve its radius.
Maybe it's just like you kind of draw the line BD, but like you just draw it so that like whatever circle you can manage to draw that passes through A and B just hits the line, and that's D. Maybe it's better that way than to try to fit the circle like onto 3 points.
Oh yeah.
And now you have OD.
Oh my god.
He OD'd in geometry.
Overdosed on geometry.
What does overdose mean, Liam? I've never heard of such a term.
What are you talking about?
I'm connecting O and D.
Uh-huh.
Yeah. I'm ODing.
Bruh, this compass don't work, it's too loose.
You're ODing on geometry.
What do you think OD means?
It means you're connecting O and D.
Yeah, there you go. I feel like you have some other ulterior thinking.
No, I don't.
Okay, maybe it's one of these compasses will have less. Oh my god, they're all flimsy. Okay, this one's less flimsy. We need like, yeah, we need to screw these a little bit more.
Oh. But Alex, here is my compass. It's less flimsy.
I got this, bro.
Look, this is
I got
substantially
this.
less flimsy.
I got this.
Right. Oh.
The line CE intersects the circumcircle ABD for the second time at F. What? That's gonna be difficult.
A, B, D.
D, A.
And then A.
CE.
Yeah, I guess that's a little bit more.
Is this F? No, sorry. Is this F? What a confusion. Should dA equals dF?
That doesn't look right.
I don't even know where D is now.
That does not look.
dA equals dF.
Yeah, that doesn't look like it's true at all.
What the?
How is dA equal dF, bro?
I feel like I need to draw the circles first.
Yeah.
I will have a better chance with
Geo,
circles.
bro, this guy just gives up and goes to GeoGebra, bro. What a weak ass.
Yeah. Should be in the car next time.
Told you Alon wasn't the weakest.
Okay. Let's revert to drawing the
I'm just gonna use only stuff I find here. Because if I ever forget my stationery, that's what I'm gonna have to put up with.
What? I feel like I'll try this again on another page. Do you guys remember the question?
Yeah.
Kind of. That doesn't look perfect. Okay, whatever.
I will try to draw it.
We'll try to draw it again. What is this? So, D, A. So I'll just like put a random spot and like try to figure out like okay. Yeah. Good enough. Yep. That's that. D.
Why is it so loud in there?
This is B, C, A, and then this is. Yeah, my diagram's looking dramatically different.
I can't tell how this intersection works.
Oh, look.
DF does not look equal to DA.
Wait, how is A involved at all? Wait, is it the circumcircle ABD? What was the circumcircle again?
Yeah. Is there an eraser?
Was it the circumcircle ABD, right? ABD. Oh, so the A is the intersection of the circle.
Okay, DF looks like DA on my diagram, so I guess. Damn, first try, this diagram's not bad. Not bad. Why the hell would they equal? So we need to prove like D is the angle bisector of AF. Let's connect AE. What the? Then what is O with respect to this triangle? Huh? Is it something to do with the angle bisector? I don't know. Sus. Yeah, I think drawing the circle first is definitely the best way.
Yeah, I feel like if you draw the circles first. So let's draw two circles, yeah.
Because you only need to draw that one. Yeah. Okay.
And then the point of intersection is A, right?
Yep.
As
And
long
you
as
just draw whatever BC, and then, well, okay, the other intersection is B. So one's A and one's B, and then just draw C wherever you want, and then you draw the perpendicular line.
So this one's D.
No. Okay, actually, no, that's still valid. Yeah, that's just a different diagram. But people won't care that there's a different diagram. They don't care about diagram dependency. Because no one cares about it.
Yeah, find the diagram that looks the easiest to work with, and then use that to solve the problem.
And then say log
Diagram is shown. Why didn't it?
because no, then you use directed angles. Huh? So why on earth would that work? You know what? I'm gonna turn the diagram like this. And now... No, not like that. No, it's not. What was I... Okay, it was the angle bisector of that. Okay, so now it's looking a little bit interesting.
Oh, finally, I can draw the E without ambiguity. I like this diagram because you can draw C and E without ambiguity. F and E.
What the hell? Wait, why is O looking more and more like the... No, it's not.
This is A. So I'm kind of happy with this diagram.
Where's D?
D is... Yeah.
It's very strange.
That looks... Oh, that looks believable.
Yeah, I guess.
Somewhat.
Yeah, I mean, it's true. Yeah, I got... Yeah, if I look at it with respect to this, it just kind of looks like a random ass circle. I don't know what that angle is. So... Yeah. Yeah, I don't think I have all the information to turn the diagram into with respect to this triangle.
But I feel like in this diagram it's a bit more believable that DA is equal to DF, right?
Yeah.
It's literally in the middle. But in your thing, you also got the angle bisector thing.
It looks like DA equals DF.
Like, but you said you had to prove something was angle bisector. Are you talking about this? Huh? Is that what you were talking about?
Yeah. So why the hell would they be... What do we do about this? Okay, well maybe I should bring back that point of intersection, the antipode of C. C is minus C. Minus C. What happens with minus C? Ooh. Oh, wait a minute. It's kind of weird. It's kind of weird. Minus C.
So we're trying to prove this angle equals this angle.
Hold up. Yeah.
Wait, so
That looked like
AE equals
midpoint, ain't it?
EF.
Okay, but it might not be the midpoint.
What does AE equal EF?
AE equals EF.
Yeah.
AE equal EF, nah.
The angles.
Because why would we trying to prove those two equal? Because we're trying to prove AD equals DF, right?
We're not trying to prove AE equal.
Aren't we trying to prove AD equals DF?
Yeah.
Wait, wait, hold on. Maybe I'm wrong. What are we trying to prove?
AD equals DF.
Yeah, which is the same as proving the angle bisector. Okay, not exact. Okay, it's kind of...
Because AD equals DF is the same as the arc length being equal.
Oh yeah, that's true. Yeah, you're right.
Try to get E.
How's E? These...
This is tough.
90.
Why is there two circles in this diagram? Instead of just one. Damn. It's pretty difficult. Okay, so this is known. D from B is known from the original triangle, but A to D is literally whatever. Like I can choose anything. Yeah. D could even be on the other side of B, for all we know. It could be like down there. Bro. What's the varying angle? So I guess we have like a bunch of unknowns. That's a bunch of unknowns. We have like three angles that matter. Three angles that matter. Okay, but then like when you do the weird thing where you project, that's like I don't know what to do with those situations. Yeah. Okay, so D.
Oh, what? It's like a bow tie here.
What are you bow tying?
There's like a that's like the green dot.
Green dot. Oh, that's a good point, and we know the green dot. We know it's 90 minus. Well, it's something like that.
And mine is like 90 plus.
90 plus. Wait, yeah, it's like 90. What? Wait.
B minus 90.
B minus 90. Yeah. Well, directed angle. You have to prove the other. Okay, so that makes it a lot more manageable because now we're like actually trying to angle chase our way to the end. Instead of doing some weird transform problem or like inspired. Okay, we might still need to make an inspired construction. Let's do it. We're staying within the realm of angles of the triangle, so that's a good thing.
Right. BCF equals green dot.
BCF.
Yeah.
Why?
Wait. No, it doesn't. I know it.
You need a reason to think that. I need to claim something similar to something else.
FBD equals green dot. Or
FB.
No, wait. It equals the other green dot.
Opens green. FBD.
Yeah, open green.
Oh. That's kind of interesting.
FB.
Oh, wait, so you're saying that
DB
is the angle bisector of FBA?
Yep.
Yeah, that's true. You just bow tie the whole thing over there.
Yeah.
It just makes a whole new thing.
Right, and just bow tie one angle, but not the one right next to it.
Bow tie one and then just
Top 10 intelligent.
Just be happy with what we have. Easily satisfied.
Okay, let me draw that.
Oh, wait. Hold on. Alex vibes. So if DB is the internal angle bisector, then CB is the external angle bisector.
Oh.
Inspired by AQ.
Smart. Wow. How does this help?
Oh my gosh, it's literally like it's kind of like in center X center level.
Wait, really? Wait, what's not? What's?
Well, I mean,
Nah, not exactly.
D is like the mid arc of. I guess we could eliminate the E.
What do you do with E? E is too hard to reason with. C, yeah, they're just confused. I'm tripping. Ooh. I feel like this problem is probably within reach.
Wait, how are things defined? Oh, E needs F needs E, so it's a bit weird. But
Yeah. How's the logic work on? Like, we're gonna move D, fine. We're gonna move D. Then, oh crap. So F should just, wait. Oh, wait a minute. So F should just yeet out with D. What the hell? Wait, I feel like we could do something with MMP. Wait, what? No, okay, maybe not. I don't think so. Wait, no, because like, if you think about it, right, if you move D up and down, because D is the point kind of varying here, up and down. If DB is the angle bisector, then F should just stay on FB when you move D. It's like kind of weird. Can you do MMP? What the fuck? Hold on. A little bit stoned. Okay, I'll have to figure that out. Or complex factor. Like, it seems... Yeah. Okay, that's the goal. That's the goal. The goal makes sense now. Yeah, the goal is like eating that. Yeah, and that doesn't rely. Oh, I know that.
Finally finished the diagram.
nice.
That diagram's kind of.
One big diagram plus lots of tiny diagrams.
Like, I draw one proper diagram, and I
Draw
draw
the circles first.
like potato diagrams. Yeah.
We realized that drawing the circles first was probably best. Because if you draw the circles first, then like D is just A is just wherever the other they intersect, and B is wherever they intersect. D is wherever the perpendicular goes, and then you can join O to E, C to B.
Yeah.
Wait, bro, like D is moving, but O is like. Wait. O is doing like this thing.
Yeah, I feel like the idea of extending lines.
How happens if we extend?
Oh yeah, and then the angle of AB is always the same on the circle. It's kind of like, yeah. This is cool.
Yeah, that's pretty weird. Why does that happen?
Hmm.
Like this. It's like boom, boom. Why are those points like it's like deflect? They deflect this. How many stuff's about E? Like this string. Hmm. Okay, maybe I should use the angle theory. Maybe that's more useful. Somehow it's related to C. Oh, man, this is tough. What C? Oh, okay. So CD should be parallel to. Wait, what? What should be? What the fuck? Yeah, that doesn't make sense. I get that. Yeah, that doesn't make sense. Whoops. Hmm. How do how do I reach these edges? Because whoa. This is a weird. Come in.
Okay. That's weird.
We'll just finish off this. I don't know. I kind of like this diagram here. So you have like, just don't draw the second circle, and you draw like, I don't know. It might not be best, but it's kind of interesting. So you just draw like OD to a point that makes the same angle, right? And then you draw the line joining C and E, and then here you have an angle. It's the same as like that. I guess that's kind of easier to draw, because then I don't know, drawing the second circle is hard, but like if you have a compass, you draw 2 circles and then you can draw it. It's pretty good. Yeah.
Why would this always be on one line? That doesn't make sense.
And so then this is F. Yeah, we're trying to show that DF equals DA.
How does a 90-degree condition get involved? Like,
I don't know how the circumstances.
Oh, it's not a bad question. So maybe he can.
I thought one
So-
thing know about the 90 degrees.
I need the
Oh, how about this?
significantly more about that.
How about this? You can join BD to the circle. I call that minus C, and then. I don't know, that kind of looks nice. A lot of things going on. That kind of completes the diagram, I guess.
So you kind of like that kind of weird setup. It's kind of still. It's still.
And it's
a
also
weird
equal to this angle, huh?
setup. Weird is that?
Yeah, we might have to start transitioning into physics. Physics.
Weird.
We're live streaming as well. It's just, but like,
Where's the midpoint? See that?
What happens if
see who's on. Oh, back down to 1 viewer.
One viewer.
WTF?
Yeah, I'm so confused about what happened there. This random guy started saying random stuff, and then you have this guy, OMG wheelchair, is that you? OMG wheelchair, is that you seems to match the amount of.
I don't know. I feel like once you draw the diagram in geometry, you start becoming like, you like the question, and then it becomes an interesting question, and then you try to solve it.
Try to find the right angle. Which angle? There's a bunch of options. What options you could do? Like you could do VAD, but that doesn't do as much of it. Maybe
Let's have a look at.
That gives you E. Maybe labeling 08. Okay, but you get VAD.
So I guess we'll hopefully, depending on how we go, finish more of the relativity,
And what do you do?
and then maybe do something to do with magnetism. You know?
Oh no, not my iPhone.
iPhone.
Alright, do you want to try to do part B? Part B. Part B should have nothing to do with part 1, right? Or actually, wait. It's all in this soil colloid.
Colloid. Part B. Effect.
Wait, so here you have like some notation for expected value. Have you ever heard of expected value?
Well, I have linearity of expectation.
Yeah. Wait, you learn expected value at school? Yeah, stats. Like the sum of the probability times the value. Like for dice, like 1 on 6 times 1 plus 1 on 6 times 2. Yeah. Oh, it tells you here. Here indicates the expectation value.
What's the expectation?
Random numbers X.
Vm equals C and equals X.
That is, if you draw random numbers X infinite times, the mean will be that. So they don't expect you to know what it is. They're trying to explain to you what it is.
There's very much not succeeding.
Now we consider the particle displacement delta x for t equals n delta with an integer n. Determine the expected value of delta xt and the expected value of delta xt squared using c delta and t.
Linearity of expectation. Linearity of expectation. Like xt, t is n. What the hell? What is that?
Okay, results so far imply that particle velocities may be regarded as uncorrelated random quantities.
Oh, they're saying like. Oh, Tn is like it collides like every. Whoa.
Alright, so maybe just a reminder. We had like the V. So from part A, I don't think you really need part A, so don't be intimidated if you haven't seen part A. But like V of t equals V naught e to the minus t minus t naught on tau, right? And we're saying if tau is the denominator is much smaller than the numerator. Huh. What does that mean? So the number gets really big, the power gets really big, but negative. And that should make this thing 0.
Delta x of t. What does that mean? Oh. This is like integrate.
Wait, is this literally like V of t is constant for the interval?
Huh?
Oh, wait. V of t is some kind of random thing. Like Vn is meant to have this property that the expected value is 0. And the expected value of Vn times Vm is kind of like this Dirac delta thing.
What the hell?
Wait, Tn minus.
What is?
Wait, so are they just saying that the particle just goes? What? Okay. So the particle is mostly still, but the particle velocity squared is c.
Actually, did we have notation for the VNs already or not? Is it abusing notation?
Bruh, this is stupid. It just went Vn squared equals c, man. What? It just went Vn squared.
Wait, it
expected
doesn't
value.
have anything about VN, right? So this is completely new variables here. They're like just defining them here.
Maybe use chain rule right now. Okay. The expected delta x. Well, I guess that just requires, because x of 0 is constant.
What's X?
Like the integral of velocity. It's just displacement.
X is this one-dimensional displacement.
Delta x of x. You just need to find the expected value of x of 2. X of 0. So the expected value of v is 0, and the expected value of x. The expected value of v is just the average velocity. Does that not mean that it should be 0 and what? Wait, hold on. Is it just 0 as well? It's just 0. Like the expected value of Vn t equals n. Okay, there's a problem here. They say t equals n with an integer n. Yeah, okay. Now, there's a problem here. There's infinite integers. So what is the expected value? I don't think that's very rigorous. No.
Oh wait, I think it's just
There's a limit on
like
the
like that's not related to this.
I think it
Is it?
nah. But so if t is n that, then it's literally just so t equals one of the tn. So yeah, okay. So the v will literally equal vn, and you're just randomly picking vn. Or at least the integral of v.
I have a feeling that even after I solve this, I won't understand what's going on in this problem. That's my impression. It's like we have a situation where we model it like this, figure out what I just modeled it with. That's like
I don't get it.
You what?
I don't get it.
How do we get to x? For t equals n delta.
Confusion.
So if we're going to express this delta x of t in terms of the vn stuff, then we have a chance of calculating the expected value. That's what it feels like, right? But at the moment we have like expected value of those things are given, and we're trying to find expected values of something.
Yeah, I don't understand this. What they're saying with the expected value of Vn equals 0. Because n can go from 0 to infinity, so it's like you're adding up infinite things. It doesn't really make that much sense.
So how do we
What
get
are
from
they saying?
v to x?
What they're defining as expected values.
Right, so if you got v of,
It
let's say v
doesn't
of
really make sense.
t, yeah? Like the way you get x is meant to be integrating, right? And
You're just integrating from 0 to t.
yeah, so 0 to t. I guess it's actually t capital N, right?
It's like delta x of t equals this.
Delta x. Let me just ignore this subscript for now, and then you have. So this is equal to x of t minus x of 0,
Yeah.
right? So still, it's just still maths.
Yeah. Bro.
Or maybe they're doing it on purpose. It's like, here's the gate at the start of the physics. If you can't pass the maths gate, no.
This is kind of like. No, wait. I don't like this very much. How does this work? Yeah.
Why does physics questions look so much more complex than maths questions, even though they're easier?
They just the only way they add difficulty is just by
much
confusing.
harder. Like
Yeah, because simplifications are like considered like big steps.
Yeah.
it's like there are so many IMO 36s that are easier to express than this, with less.
Because
complicated
mathematicians
notation.
value simplicity.
Like
I'm so confused with what Vn is.
The end.
Like, is it just a constant?
It says a random quantity Vn.
Yeah.
genuinely, you could give someone anti-Pascal triangle, and they'll be able to understand it much easier than they'll be able to ever
What the hell
understand
is
this.
Oh wait, so no, I don't think they've this is not well defined. Is it like a process where you're like every time interval you're drawing out a Vn and then you change your velocity to that? Or is it like and then also what is V? Is it like
Yeah, like it seems we have a V that's defined on like on time, right? And the time kind of goes like
yeah.
I don't know, what's the first
And like
0?
every
So T0, T1, T2.
yeah,
And it seems like it's doing some kind of like
delta. It just goes boop 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 boop. And the
yeah,
expected value of what it
the length
changes
of these
to
are deltas, yeah. Yeah, so David, the exercise is to figure out what the hell this is doing and then solve it. None of us are physicists, really.
This is like a random walk or something. It's like a random walk. What? Oh, wait, I think I kind of get. Okay, so we're given expected value of v at n equals 0. So on average, the velocity is 0. Okay, I'm trying to figure out how to get from on average the velocity is 0 to on average the displacement is 0.
Are we meant to use the velocity we got for part A?
I don't think so. I think we just use the expected value of v n.
Okay.
We'll try to figure out. Yeah, it's like a random walk, I guess. Yeah. Kind of like a random walk.
And is Vn constant for the interval?
Vn. Yeah. I'm pretty sure Vn is fixed.
So then the interval.
Vn is fixed, but it's a random quantity, so it's like a process where like every delta you're just like drawing out of a hat Vn.
Oh, okay.
And usually it's 0.
Alright, I think I know how to calculate the integral then.
Yeah.
Because then it's just the areas of the rectangles, isn't it?
Yeah, but the rectangles are also random heights.
I know, but like you can can express it as in terms of the random
because the heights are. Oh yeah, okay. So you just sum the heights, yeah. And each of the heights have expected value.
So this is like 0.
Yeah, so each of the heights have expected value 0. So by linearity of expectation, the sum of the heights have expected value 0, which means that if you times it by the width of each of the rectangles, then it's just 0.
Nice.
Okay. Right, so I think we're going for a large integer n because they don't want to do infinite, yeah? That's Tn. Yeah, and then we have like all these rectangles, yeah? So the areas of all these rectangles is like, should be like V1 delta, right? Plus V2 delta, plus V3 delta, plus Vn delta. Yeah. Does that make sense? Wait, so you guessed the answer, did you?
I guessed the answer.
So that's equal to delta xt, yeah. Tn, yeah. And so then if you do expected value, yeah. So one thing you know about expected value is that expected value is additive. Wait, do you know what expected value is? So expected value is like the average outcome. For example, if I shoot a 2-pointer at 50% rate, I expect to get 1 point per shot, yeah. Even though it's impossible to get 1 point per shot, yeah. And I guess that's why free throws are better than actually shooting, because you get 2 shots both worth 1 point each. Your expected value is still 1, but you can actually realize it. It's kind of a clever way to sort of stop people from getting unlucky. Because if you just took 1 free throw worth 2 points, it's like people might think, oh, I could just foul them forever. But they don't realize they're going to make the next one. Okay, and then in Maths Olympiad, there's famously this result called linearity of expectation. So if you want to calculate the expected values of a whole bunch of things added up, you just calculate each one and then add them up. Okay. And I guess the main
linearity also means you can scale. If you scale by the delta, yeah.
I should probably record this.
Recording in progress.
Expected value also scales by 2.
Yeah, so it's not just adding, it's also scaling, yeah. But the thing is, like, you might think that you need the random variables to be independent of each other for you to add them as if they didn't interact at all. But it turns out you can just add them anyway, even if they're not independent. So the famous example was like, there was this Maths Counts talk show where they put up this problem and the guy from the US IMO team answered it in like before people could finish reading the question.
Wait, are you talking about Robertali?
Yeah. So like, it was a question. It was like 100 chickens in a circle, 100 chickens in a circle, and they all just randomly peck one of the chickens on the left or right of them. So random means like 50-50 chance. So they like, all like,
Yeah,
okay.
that was the question.
Yeah, and the question was, what is the expected number of unpecked chickens?
Oh, the expected
Yeah, so like so for each chicken, right? They have sort of like a one. What is it? Like they have
1 in
half.
4 chance of not being
Yeah.
pecked. Yeah, and so the expected value is just you sum it all up. It's 1/4 the number of chickens.
Yeah. So I guess the
Yeah.
point is you can work out what the expected value is for each chicken, right?
Yeah.
But you'd think it'd be kind of confusing because how would they interact with the other chickens and stuff, and it might be complicated because if this chicken pecks left, he can't peck right, you know. So that guy has a better chance of not getting pecked. But it turns out if you just figure it out for one of them, you could just actually times it by 100. Yeah. So it's funny, like how there's levels to this, right? It's like if you're at the very bottom level, it's like, oh, what the hell is this question even asking, right? It's like, and then if you're at the very like at the next level, it's like, oh, I just add them up. And then the level above that, it's like,
Wait.
oh, but you can't add them up. They're interacting and stuff. And the level after that, it's like, oh wait, you can add them up, even though they're interacting. Yeah, but then like you could probably like 25, 75. That game show was whacked.
It's like the guy before. It's just like, all right, guys, it's all good. Like whichever one of you wins, like you've all made it. It's all good.
He
Like,
gives them like a talk at the most crucial moment in the contest, like the final question of the finals. He's like, "Hey guys, it's not so. You could fail and it's still good, you know. Like there's not no." And then the guys are probably just like, "I hate him right now. I hate him so much. If I fail, it's because of him."
Also, Luke Robertali dominates so many random maths competitions.
I mean, the whole point of it was to show maths to the common like audience, like the popular audience, just like kind of like how sport gets shown to everyone. But like it didn't really work because it was just so like, because like they were asking they were trying to ask questions that were kind of simple enough we would understand, but like still interesting to solve, or whatever. But like they would literally ask a question, and before the guy's done reading the question, both people have buzzed, and like one of them solved it, and like it's like they just couldn't. So it didn't like. It was spectacular in some sense, but it wasn't the kind of thing people were hoping for. Because like
he's got like the rest of the like mass counts people like you like the person came second. That was an IMO member. Luke Robertali, what 4-time gold medalist, won that mass counts thing twice. Like he's just won.
Wait, was he a 4-time gold medalist?
Yeah, 4-time IMO gold medalist.
4-time. I love that.
Yeah. And he won the MIT integration bee as well.
This guy just does weird.
This guy just wins any mass contest.
Does everything.
I don't know. I feel like if you list a lot of achievements, it makes someone sound more, but you can really just take the maximum. Or like,
The 4-time IMO gold medalist.
Yeah, but like just in case you've even heard of IMO, you've heard of MIT, right? Alright, whatever. So, does this make sense? Yeah. Actually, even though like it's a crazy kind of linear accurate expectation, the proof is like actually trivial. It's just like just expand stuff. But I guess the main thing is to notice in the proof you don't need the independent. Yeah. Yeah, it's actually in the math book I'm writing.
But what about the continuous probability crap? Uh-oh. That's
Okay, so is it just 0?
I think it's just x of t is just 0, and then x of t squared. I think it might. Just...
What? Oh, you square it first, and then you take the x back of that. Be careful of order of operations, people. Don't just think it's 0 squared.
Yeah, so now for the x of t squared, we need to use the VN.
Oh, it's all making sense now.
So the
How do you do the
VN,
squared, people? How do you do the squared?
the VN is really idiotic, that
This is
expression,
0.
and I hate physics. Okay, so it's like, because they're just like saying C of n equals. Okay, you could have just said VN squared equals C, mate. Like, bro. And then, like. Okay, so. Tell me.
So what to do? So yeah, like physics is like figure out what the question is and then answer the question. And figure out what it is that you have done. But that part's not required.
So how would you do that? So if you square this and then you expand it, right? Oh, that's why they wrote it like that, because they don't want the dumb physics kids to die. So if you because like
That was.
okay, so if you square this thing, right? You square this expression and you expand it. There's like these vi squared delta squared terms.
Okay.
So for that we need to use the vn thing.
This is red stands out. So delta x t squared
And that's why they want the
equals. So remember we did this thing before, just like v1. Do you know how to square that? Squared. Ooh,
we don't know.
Oh, there's a delta squared outside of everything now. Yeah. And then there's like v1 plus plus vn delta squared.
That times delta squared. But then the thing is, like, okay, I need to check something first though.
Like it's kind of weird. Like I feel like if you want to be a physicist, like actually a physicist, you should be still doing the maths, like probably the maths Olympiad. You know what I'm saying? Like actually a physicist. But then but the alternative to that is like, if you really want to be a physicist, like if you really you're fully committed to being a physicist, then I think you could do like a physics, like Olympiad. You know what I mean? Like it's kind of like. It's like a specialty almost, right? Whereas like if you kind of just like general education, like learning maths and then specializing in physics is probably the most moderate approach. That makes sense.
Okay, so here's the thing I'm saucy about, right? So they said that. Here's the thing I'm saucy about.
So I guess we can write the rest in sigma notation.
The thing I'm saucy about is this isn't exactly linearity of expectation. So
we can do vi vj. I is less than j. Does that make sense, notation?
Wait. Yeah, because the problem is this isn't really We cannot use the linearity of expectation any longer.
What? Why? What?
Well, no, we can't. It's fine.
What?
Don't worry about it. I'm being a dumbass. Don't be a dumbass like me. Okay. Yeah. Okay, yeah, now you just use the VM thing. Right, so they said literally, they just handed it to you. They said the expected value of V1 squared is just C. And then they're all C. And then they said that I less than J, that's just 0.
Uh-huh. Did you see that? Live solve IFO. See, I could put it on the outside, but it's linear, so I put it on the inside. See,
T.
see that?
Now it's just like I don't know,
Kind of
CN.
highlight this thing they tell you, right?
They don't let you. Oh wait, no, absolutely. No, they say it's T equals N. Then why didn't you just say using C delta and N? Like,
Oh,
okay, whatever. It doesn't matter.
oh yeah.
That would have been the more logical step to take. I don't know.
Confusion. Wait, does that mean we have to like convert out the N into the T?
Yeah.
Wait, so like the
You
final.
you have to say N equals T on delta.
So this is C, right?
It's
And
like
then there's
NCs.
N of them,
N of them.
and then there's a delta squared, right?
And then N.
Okay, but they didn't want N, they wanted T. So we
Therefore,
write T equals, is it N
T
equals T
N,
on delta?
T on delta.
Oh.
So then it's like C T delta.
T.
Yeah. Bro.
Kadata.
So much algebra.
Wait, get this, David. Check this out. This question is worth.
One.
Did you notice? Well, 1.0 points. Okay. And the reason they were 1.0 because that question was with 0.8 points. See, it offends the senses, you know, like it's unreasonable.
What? Why? What happened? This is 0.8
Yeah,
again.
0.8 again.
Eh?
I think it's psychologically intimidating that like you did all this effort and you only got not even a point. And that's why they didn't finish. They all left the exam early.
I swear, whoever wrote this exam just wants to annoy people. Like, 0.9 marks a question. Like, 1.8 marks for a question. Who does that?
Alright, should we try to compare with the answers or...
Okay, that's pretty cool, but like, are they gonna teach this stuff to like the Australian physics kids?
Alright, do you want to do B2?
Are they gonna teach linearity of expectation?
Linearity of expectation.
Will this be taught?
Yeah, like it's
because
kind
this
of...
is an international contest. This is not in the physics syllabus.
Yeah. I feel like so the purpose of this line must not be to explain to you what expected value is for the first time, right? Because then they kind of expect you to be able to add them. But then like maybe like physics people like they need to tell people what something means in a different way to make them realize that's what it is. Like how the book constantly reminds us that we see it in everyday life.
I don't know. Do they just expect you to discover linearity of expectation in the exam? Like,
Yeah.
whoa.
It's like either discover it fully or discover it partially and don't worry about
Okay, but it's really funny, but because even then you don't know what random variable is, so there's no point.
Yeah, and
So it's like,
and the constant thing I think is a bit weird too. Like I think it's only we're kind of guessing that that's what they think. So it kind of makes sense now what's happening, right? It's like, you know what Brownian motion is? It's meant to be like random fluids doing stuff, and the kind of the history is like it got solved mathematically as by modeling a random walk, and so a random walk is kind of like so you can define it for any kind of grid or lattice, but usually like if it's just a number line, right? You can make it like integers, for example, and you start at 0 and it's like 50-50, you go left or right, and then 50-50, you go left or right again.
so it's like those weird dot board things where you drop the ball.
Yeah. So actually, this is like a famous result in that because if you were to do a random walk, so you started from 0, right? So like you have a line and you just kind of start from 0, and you randomly go left or right every time, right? The kind of the famous question was like, what is the expected end, like where do you expect to end up? You know what I mean? Do you expect to just go to the right forever or to the left forever? And I think the result was something like you expect to just end up where you started, isn't it?
I mean,
Like, it kind of
obviously,
wouldn't
right?
make it's kind of
Symmetric.
symmetric. It doesn't make sense to end up too far on the right.
Yeah.
It's just like what the it could have gone either way, but I always end up on the right. Yeah. And of course, you can do it in 2 dimensions and stuff as well. And so in 3 dimensions, it's kind of getting closer to like maybe what this Brownian motion is.
Maybe that's why IPA chose like everyone's die. Because like they don't.
So here it's kind of like that, right? Like you're stepping up, stepping down. Wait, it doesn't tell you what direction the V is, right? Yeah, it has to be up and down for it to expect the value 0, right? So,
I guess this is slightly different because it's like the. Hold on.
but you still end up you don't end up going anywhere. See?
Yeah.
You could have gone somewhere.
Like the standard deviation is still the same.
Yeah. And usually when you calculate the expected value of something, and you calculate the expected value of the square.
Bro, what are they saying?
That's
quantity like, xt.
That's kind of like
squared.
the standard deviation or variance. Like it's not directly it, but you can use these 2 numbers to create the standard deviation.
Why are they saying mean square displacement? Just say standard deviation squared. That's like, yeah, I guess. Like,
oh wait, we're talking about standard deviation next. Yeah, so I think it's kind of important to learn stats, because a lot of the interaction between theory and experiment is really like the key is to understand what stats, to actually understand what your experiments actually told you, and if they actually agree with your theory or not. I don't know. You hear a lot of people like psychologists or like a lot of people who do like science. Like the thing I think all the science people have in common, like if they're good, is they all meant to understand some stats, you know. Yeah.
the characteristic observable with Brownian motion.
And the thing that everyone learns in stats first year is hypothesis testing. Okay.
Delta approaches 0. This we can show C is proportional to delta to the alpha.
B1.
Ooh.
Sample solution. B1.
B1.
This is very...
Yay.
Okay, it's kind of encouraging, right?
Yay. Yay. Nice.
Yeah, at least, yeah, like it would worry me if it was different and then they have this like secret convention that we don't know about, you know, like, it's like, in this situation you always write 2 and then we'll give you the marks. When people write 0, we take away the marks. That didn't happen, okay? It's good. And, okay, this is our, we're officially over 2 points now on iPhone.
So B1, we didn't need to use the independent.
We only need to get the 5 points or 6 points on theoretical. To only need 6 points on experimental to get bronze.
I guess they're saying like. So maybe the independent was just to figure out that it's expected value of 0, or like if n is not n. Like this.
Where do they say independent?
In the question.
Oh really?
But then there was like unnecessary information because they just gave you the result anyway. It said like
parts get harder. Like is question 2 harder than question 1?
It's like, well, you're doing it while you're more tired and frustrated.
True. Because like,
but a little bit encouraged.
If you get all of question 1, you're good enough to get silver.
Yo.
Like.
Well,
yeah, it's kind of like
the practical.
It's like the TOT awards.
Yeah.
Solved question 1.
Wow.
got
they said-
non-zero score.
Yeah, no, because people always say, "Oh, you did well if you solved question 1," but then it's like, but you don't get anything for it. So now you get something. You get a 3D printed token saying you solved question 1.
Didn't you print people tokens with their name on it and just nothing there if they didn't even solve a question?
That was an accident, okay? Because we had the table, and then it was like their name was there, and I was like, "Oh, we just didn't solve anything."
So you just printed an empty token.
A token. Well,
Oh, this one's worth less than part 1, B1.
whoa, that means it's
0.8
easier? Does
points.
that mean it's easier? Oh. Determine the value of alpha and beta. C is...
See,
What?
this is called the mean squared displacement.
Okay.
So if you
C
take
is
the like,
proportional to...
so if you take the different, like if you take the mean, right, and you calculate all the differences from the mean and you square it, and then you take the expected value. That's the definition of like standard deviation, right? So you kind of use that formula and you expand it and you get it in terms of those two things. Right? You learned that in school, right?
How do you determine
Alright.
alpha? That's...
Your school seems pretty good. Because every time I ask people if they learn in school, the answer is usually no. Or like, we're still learning this thing in school, and it's like,
Oh no. Oh, the teacher didn't teach us, but we were supposed to learn.
yeah.
I think that's what happens.
The
in a lot
teacher
of my
hasn't.
classes.
Yeah, the teacher hasn't shown up to class for the last 2 years.
I didn't know that. I should chuck this ball.
Yeah.
All right, the quantity x thingy. All right, think about this for something. Hopefully, this will be our. We'll go back to some textbook stuff after this.
Oh, I should check it out. I just chucked it in the room.
Alright, we can do this quickly, it would be preferred. We could also give up if that's appropriate.
What is that weird squiggly fish symbol?
Proportional.
Ah. Why the hell does physics have so many...
Oh, proportional.
stuffed
I love
symbols?
proportional. Because I felt like I eventually understood proportional.
How did you find alpha and beta?
You know what proportional means?
I don't understand this.
It's like if you double one, you double the other, right? And so literally physics laws, it's all proportional, right? And then you invent a constant to make it equal.
Yeah, it's
So like there's like actually no equations in physics. You just create units, and then sometimes you want to like make the constant disappear. You just create the units so
Just
that the
make the
constant's
unit.
1, and then it's equal, right? It's kind of a scam. So like actually the only things you get in physics are proportionality. You don't get actual equalities, right? It's like force equals ma. Yeah, force is proportional to acceleration.
Mass is just something we invented.
And it's proportional to mass, but we don't really know what mass is. In the proportionality constant, we shall say it's 1 over a Newton.
The quantity x. Show that C. But why is... Okay, how do we find alpha? So we double...
Oh,
Wait, no, that's... No.
this gives me such... Oh, you know how to show experimentally stuff is proportional to, like, delta to the alpha? So what you do is... So basically, like, if you have two things that are proportional, you plot them, right? And you have the line of best fit,
Because linear
and it's
regression.
literally like a straight line, right? And so if it fits really well, then you're like, they're proportional, right? Okay. But what if it's like it's proportional to the square, right? Like you have like the parabola of best fit, but it's not like you can draw that, right? So you have two ways of doing it. Getting lucky, so you plot the square versus the thing and then draw a straight line. So then like it's still a straight. You're only still ever drawing straight lines, but you have to get lucky because you have to guess it's a square, right? But what if it's like 1.891? That's the actual power that is related to. So what you do is you plot the log of both sides. You plot the log of the quantity versus the log of the other quantity.
Wait, that's actually a massive brain.
Yeah, and then you'll always get a straight line, and you can measure the slope. The slope of the straight line tells you the power it's meant to be.
Damn.
Yeah. Yeah, I remember my physics teacher taught me that when I was in year 12. Dr. Hooper.
Well, dude.
Yeah.
Wait, that's actually smart.
Yeah, I think he's one of those guys that was actually like good at physics and stuff.
He's good at science.
Yeah, but he kind of like he's trying like he's that like he's trying to get the students who are good to do these research projects nowadays. But yeah.
How do you define how do you determine the values of alpha and beta in terms of what? Huh? What? In terms of what?
Okay, so now we're back to this question.
What the hell?
That is called the mean square displacement. So it's kind of like they're trying to teach you physics in this Olympiad. It's kind of funny. It's like, and if you get taught and you prove that you did well, they offer you a job at their lab at the end. You can work at CERN. Oh, it's actually crazy how many people like, like to solve a maths problem. People probably like, how would you even do it? And you have a ton of money. What would you even spend it on? You know what I mean? But physics, you could spend money on anything. You know what I mean? They're like, we need to collide particles together. They literally built a whole city, and like with a huge tunnel, and they just started firing particles at each other. And so then you need to like employ all the people to run all the machines. Like drive around the tunnels. Security guards.
Yeah, I guess it's hard to pay for smart people, but it's easier to pay for like infrastructure.
Yeah.
Plus, don't they need to keep it ridiculously cold as well? That seems like they'll have major electricity bills.
How do you do this? What the? We can show CS.
What does this?
They said C is depending on.
So physics is just intentionally made more like ununderstandable by these symbols, so it looks harder to the average person. So the average person thinks this.
Right, so what did we find in the previous part? We found out like delta expected value of delta xt squared is what?
C delta t.
Oh great, beta's 1.
Okay. Let me tell you, I have no comfort whatsoever with these kind of questions. It's only like knowing that I could probably figure it out, but like it's not like they're saying stuff that like makes sense to me. You know what I mean?
Okay, I got 0.4 points. What's alpha though? How do you find that, huh?
It is a characteristic observable of the Brownian motion.
Are we saying that when looking at the limiting?
Which corresponds to the limiting case. Delta goes to 0. What is it? The first, that was like half of this paragraph, and I have no idea what that just said, right? Just like nothing. It was just like in, out.
I think they're trying to say like the model of Brownian motion is when you just make delta small and smooth. Just make it tiny until it's basically continuous.
Oh, wait. C depends on delta, right?
Yeah.
So then when delta goes to 0, it might not be 0.
Yeah, but like beta's 1, right? Surely. Surely it's just 1. Because we literally said...
Oh, so now C depends on delta, and it's asking how does C depend on delta?
Yeah.
C is proportional to delta to the alpha. Oh, what's going on?
What if alpha and beta are just 1? Okay, I know beta's 1. What the fuck?
Determine the values. Oh, okay, that's what it's asking.
What is alpha? Let me try. So if I...
Oh, wait, so you're saying that if C is proportional to delta to the alpha, then beta's 1? Or are you saying that like...
I'm just saying beta's 1.
It's just 1. Wait, isn't...
In economics, they would call it ceteris program. They have different names for things in like economics, math, and...
How do you know it's 1?
Because we said that like the expected value of xt squared is like something. Wait, what did we say it was?
Okay, it's supposed to be this thing, right? It's supposed to be c delta t, right?
Yeah, look, it's proportional. The constant is c delta.
C delta squared and
Look, it's literally c delta t, man.
c delta t.
C delta t is just 1.
T
Beta is 1. It's t to the 1.
No. What? Oh, what?
Like, I don't know. I don't know what it means.
Oh.
I just...
Oh, it's t to the beta. I didn't even read that.
I swear it's just 1, bro. Like, what else would it be?
Well. From this, we can show c is proportional to delta to the alpha and...
Cool. Okay, so c... Yeah, okay, now I'm confused. How does c depend on delta? That's the question. Okay, if the limit case goes... Okay. Yeah, and then alpha is just like... Wait, alpha might just be minus 1. It might just be minus 1.
Really?
Yeah. I don't know.
Why
I have no idea. I actually have no idea.
Oh, so actually it's meant to be just a consequence of the other part.
I think so.
So we don't have to really do anything, provided we got an answer for the first part.
Yeah.
If we didn't get an answer, it'd be kind of weird.
So it's
so they're like, okay, we'll make it 0.8 so not to punish them too much.
Okay, but the problem is, like, this is not rigorous. This is not rigorous, bro.
I don't understand, like,
yeah, the limiting case. So therefore, therefore, if you decrease the delta, the expected value of delta xt squared converges like that. Yeah, that converges. But that doesn't. But that only means like for small values. Yeah, that only converges for small values. So for small values of delta, c is proportional to delta to minus 1. But then like, it shouldn't be true for like big values.
Wait, so delta is independent of t? It's like a...
Huh? Oh no, it's not independent from t. I don't think. Wait, no. Delta. No, delta's just constant. We're holding it constant. It's like
delta's constant.
No. We're able to change delta however we want, and c depends on delta. We're also able to change t however we want, and then delta xt squared depends on all of them.
Yeah, so I think the confusing thing is it says from this we can show these two things. Yeah, which I feel like it means that they showed these two things, and we're meant to assume that they're true. That's kind of like, and then it's like, and now you find out what alpha and beta are.
Well, I claim that you are wrong. You are wrong. Yeah, I don't even know that's okay. This is stupid. Because the problem is like, just because it converges doesn't mean the outside.
So then for us, so like it seems like they use delta goes to 0 to get those two things, right? So not only are we not meant to use delta goes to 0 to get those two things, we're meant to assume that we've gotten those two things, and then do something completely different to try and figure out alpha and beta. Yeah. So this thing is equal to this thing, and it's supposed to equal to like some constant times
delta to the alpha plus 1 plus 2 maybe.
I don't know.
Oh, we keep t in there.
Okay, assuming delta x of t squared converges fast enough, it should be -1. I don't know. Alpha's -1, beta's 1. I'm just in the exam. I'll just write it.
What makes you think alpha's -1?
Using the physics on rigorousness. So I just like the expected value of delta x t squared equals c delta t. So then I just move everything. So c equals that divided by delta t. And then assuming that if I make delta small in the limiting case, delta goes to 0, that the expected value converges, then I can just say, trust me, bro. It's close enough.
What is this?
I don't know what they want me to do though. This is not well defined. Like, I don't think it's even necessarily true that C should be. Yeah.
It's a very confusing question.
Yeah, I don't think the C proportional part makes sense.
But they're like claiming that
Because
we
the
assume
limiting
it, right?
because the limiting case doesn't equal the not limited case. The not limiting case. The limit doesn't equal the terms. Doesn't make sense.
What do you think, David? Should we just be assuming that C is proportional to delta to the alpha?
I have no idea, man.
Well,
Bruh, how does this worth 0.8 points when it doesn't even work?
I guess it does confuse me a little bit, like if delta and t are related, you know? Because t is literally delta on n, so like.
Are we trying to like?
Does knowing the answer to one of them give you the answer to the other one? Like, is it equivalent to solving?
I'm trying to figure out like, do they want me to set C so that the non-limiting case equals the limiting case, like all cases are equal? Or do they want me to not do that? They probably want me to do it because engineer.
So what should the limiting case be? Oh, actually, maybe they do want us to do the limiting case. So they're trying to say, oh, do the like we know if you do the limiting case, you'll get these results. So you do the limiting case and you get these results, but you'll get them with the alpha and the beta. No, yeah. Maybe that's what they want us to do.
Bruh, this is not very rigid.
Wait, so if delta approaches 0, is there an obvious thing that the expected value should be? Is it obvious that the expected value should be 0?
Okay, I'm very sure. Okay, I don't know. I can't be sure with anything in physics, but I'm pretty sure if I'm not a dumbass, beta is definitely 1, but alpha is confusing.
Beta is 1. What if beta is like? Because what if like there's other deltas and then that makes the more t's? You know what I mean?
I think when like they say proportional, they're just like ignoring all other variables.
But like literally, you have like t equals n delta.
Yeah, but like if you use the top one, it doesn't depend on n. So in the limiting, so.
I mean, before we took the expected value, so this is a thing that physics people do a lot. Like, before we took the expected value, we had like something times delta squared, right? And then you take the expected value and get something else.
Right, yeah. Average physicist approximation.
A lot of physics people, like, I feel like they take the limit. They want the limit at the outside, but they just take the limit on the inside. You know what I'm saying?
Oh yeah, like
so it's like this, right?
Delta they're always switching it up. Like they're switching it. Bro.
Equals delta squared times something, right? Like sum of v I squared or something like that, right? Yeah. Okay, and you want to take like an expected value of that, right? And then something about limit as delta goes to 0, right?
I think what limit.
I find that they
on
do
the
this kind of
outside.
stuff a lot. It just ends up on the inside, this limit.
Nah, that's wrong.
They
That
do
doesn't
this.
even make sense. You're limiting an you're limiting. Wait, you're limiting a random variable. That doesn't work. What is that? This is like what the fuck.
Yeah.
From this, what is this that they're referring to? I think. What are they referring to in this? Don't get it. What is this?
So I feel like if c is like proportional to some power of delta, right? Like it can't be proportional to like, you know, like it can't be like, for example, I don't know, like do we expect the limit, in the limit, this thing to be 0? Like if we expect this thing to be 0 in the limit, right? Then like c can't be like 1 on delta cubed or something, right?
I think it's supposed to be some number that's not 0. Unless t is 0.
It approaches a constant. Actually, that actually makes a lot of sense.
Because
Because constant doesn't care about the proportionality, right?
like, I think.
Okay.
that's
I think Alex just solved it. Okay, so basically you have without doing
Without doing sus shit.
yeah. So limit delta goes to 0 of this equals k, right?
Oh my
Yeah.
god. They got
Okay.
the K.
So then k equals limit delta goes to 0 c of delta squared n or whatever, right?
See if delta t, because we want t because n is dumb.
Yeah.
I don't think we want n, we want t.
Are you sure?
Because like
the t has deltas in it. That's what really bothers me. Like the thing that bothers me the most
T has
about this
delta.
question is the fact that t and delta are sort of maybe related.
No, I think the thing is with the limiting. No, because the limiting as delta goes to 0, the t is like constant. Like they want x of t, not x of n.
X of n.
They want x of t.
Oh yeah, but and it depends on delta. So like, I guess the point is
this is so
like,
confusing.
Like
no, like they should have just defined like
let's just say k is not
n
0.
equals t over delta. Maybe.
Let's say k is not 0. Yeah. So if k is 0, I don't know what's going on. But if k is not 0, okay, then basically some power of delta here, right? Yeah, is, you know, when you take the limit, is meant to equal like a constant, right? That makes sense? Right. That's not 0, yeah? And so if delta is like, if alpha is like 1, then delta cubed, right? Delta cubed just goes to 0, right? Yeah. Or if you make it like alpha is -6 and you get like 1 on delta something, right? Then that's gonna go to infinity, right? It's not gonna have a limit k.
Oh.
Yeah. So for this to have a limit k, like the alpha and the 2 have to kind of cancel, right? So it should just be like, you know what I'm saying? There should be like, there shouldn't be like a delta or a 1 on delta in this expression.
Oh yeah, because like if it's like less than 1, it just goes to 0. More than 1, it just goes boom.
Yeah. So it is a characteristic observable of the Brownian motion. What does that even mean?
So
which corresponds to the limiting.
So we managed to assume that C is proportional, and then find the proportional.
Yeah. So then maybe we can suppose alpha is -2. Yeah. But the thing that keeps bugging me is this, whether t depends on delta or not. Yeah. Because
you know, you're given that t equals n delta.
I don't know. The reason I use t is because like t is supposed to be time. It's like basically just the thing. Everything is in terms of. So like, use t instead.
Yeah.
Like it's still confusing because they don't define the limiting case. So if the limiting case was in terms of n, then you'd be right. So like now I don't know.
I'm confused as well. So then, and if c is proportional to delta to the minus 2, right? Then the original thing becomes this original thing becomes, so it's c, which is delta to the alpha, delta, and then t, right?
Yeah, but that's still something times t. So it's like t is n. Okay,
and this
but
is
then-
like
then
minus
it's
2.
Ugh.
So then maybe now beta is 0.
Because there's no t in them.
I'm so confused. Okay, so yeah, but so this is like delta to the alpha plus 1 and times t, right? And delta is proportional to t, right? So this should be t to the alpha plus 2.
Oh.
Yeah, I feel like I'm starting to understand what the hell this question is asking. But it relies on this k business.
K. Has to not be 0.
Yeah.
It shouldn't be 0 for k is not 0. I mean, for t is not 0. Or for n is not 0. Because, like, clearly we got
positive.
Got from the previous part that.
Yeah, like it should be a positive number, right?
Yeah. Because squares are non-negative.
Yeah. Yeah, and then the good thing about k is it's definitely independent of delta because you took the limit of delta.
This is too confusing for me. I don't know what's happening.
Alright, what do you think? Alpha is like minus 2, beta is 0. Does that even make sense?
Bro. Yeah, the problem is they didn't define the limiting case.
Yeah.
They're not defined. I can kind of get where they're coming from. Because, like, when you make a computer simulation, like, you can't simulate continue.
Okay, so my claim is this is correct up to knowing what the hell's going on with the relationship between t and delta. Okay. Because this at least gives you a way to calculate alpha and beta. Yeah, it's just you don't know what you're putting next to it.
What is the chat saying?
Oh, the chat is still when Liam.
This is Liam.
Liam's last message. Oh.
Liam game.
What do you guys reckon?
I'm not sure. It's not well defined.
It looks. Why do they use so many symbols?
I don't know. Confusion.
There's something simple. We gotta figure out physics. They aren't able to create a difficult question. So what they do is they add a bajillion symbols so you can't understand what the question's asking.
Alright, this is quite
Yeah, they also don't define things properly, so it don't make sense.
So the difficulty in physics is not in fact the question, but proving out what you have to do, what the question is.
Bro.
Okay. Did anything I say relate to the answer?
What does the answer say?
Okay, that's B1. As described in the question sheet, which of course takes a finite value for a given t.
Bro. What the hell is the overdamped Langevin equation?
Yeah, so the reasoning is the same.
What the hell is
Right?
the overlang?
What the hell is the overline? Where does it say that?
The overdamped Langevin equation.
Yeah, I mean this guy. It's just the guy's name. Okay, don't be intimidated. Sometimes it's less intimidating when you realize two guys had to collaborate to figure some crap out. That was easy.
What sort of name is overdamped though?
Overdamped.
Overdamped Langevin.
So this is a footnote. Okay.
Overdamped Langevin. So people just get stuff named after themselves when it's done. Yeah.
Oh, okay. So they did take the T. They did take the T separately. Yeah.
So then, like, the T is indeed the thing that is held.
Yeah. So Alex was right. So Alex was right. You have the alpha is -1. So the T and the delta are unrelated as far as this question is concerned.
Yeah, that's the dumb because like in physics, a lot of the time like you don't.
But you see the reasoning, right? It's basically you need this limit to not be infinity or 0. So you need them to cancel out, right? It's just I couldn't figure out what I needed, if that was a delta or a delta squared, because there was a stupid T there with a delta inside it. Okay, and then C. So alpha should be -1, and then yeah, if that's the case, then literally it's equal to T, right? And so the beta is 1.
Bro.
There you go.
Why is this so stoned?
Wow. So Alex would have got 0.8 points.
Wow. 0.8. Very sad.
Maybe I could have got 0.6 points. Maybe.
I feel like the only reason I got it is because like I think of in terms of computer simulation. Like you're trying to make a simulation, but you only have discrete. You only have discrete in computer simulation, so you don't. So you kind of have like. So I guess like the delta is like your time step in the simulation, and then yeah.
Oh.
And so so when you make the delta smaller and smaller, what you want is like for each t, the value should approach something probably non-zero.
Oh, you're keeping T constant.
Yeah.
Oh, so
T constant.
Oh, okay. Now I get it. So like.
So that's why it's 1 and -1.
So what you're doing is you're keeping T constant, right?
Yeah.
And then you take delta goes to 0, but you just make n large to keep the T constant.
So like you want each time like. Yeah. You want at a certain time, if you make the resolution finer, you should get like closer and closer to something. The true value, the limiting case.
Yeah. So
but like the problem is that because your time step might not perfectly fit the t that you chose, because like your time step might not divide your t.
Yeah.
Which means that it's kind of like not rigorous.
Yeah. So you kind of you're changing capital N without telling any. And so then the T is constant. So obviously if T is constant, then you don't need to worry about it. Constant with respect to delta.
Like as big as possible.
With respect to this delta going to 0, because as delta goes 0, capital N goes to infinity. Okay.
This is so unwell done. Because like they didn't even say anything about it. They were just like, trust me, bro, limiting case.
Yep. Okay, relativity. Relativity. Wait, how much did we do in relativity last time? It was 1,116, right? Relativity kind of stems from this electromagnetic wave stuff, which I thought was pretty cool. Because like what you have, wait, I'll just tell you. Like, so you know how I said like if you have like a conductor in a magnetic field, and you like move it, right, it gets a current. Or another way of saying it is like there's an electric field, and so then like charges move and then it becomes a current, right? But you also learn in school that if you have a electric field, right, like a current, yeah, the current has a magnetic field around. You guys learned that, right? You know what I'm talking about?
Yeah.
You just got a wire with current in it, like, and you can put magnets on it and it starts doing stuff, right? And so like, so what's meant to happen is like something. So it's like some atom is like moving around. It's got electrons and stuff, right? And that like there's like a magnetic field that's generated, and in the magnetic field, like something moves to create an electric field, which then creates a magnetic field, which then creates an electric field, and that's what electromagnetic wave. This repeating process of creating electric and magnetic fields.
Huh?
Yeah.
What?
Yeah.
What? So is that how light works?
It's meant to be, yeah.
It's just like.
Yeah, and if you kind of like write down the equations for that, it turns into like this wave equation. And then that's like Maxwell's equation for like, and then the constant is like the speed of light is constant. So there's a wave equation in maths, like a differential equation. So when you have an equation, it's like whatever satisfies that equation is a wave. Yeah. And so like the stuff that they had satisfied that equation. And it's a wave. And it's gotten from the idea of just kind of generating magnetic fields which can generate electric fields which generate magnetic.
So wave is actually a mathematically defined thing.
Yeah.
It's not just a thing people say to sound cool.
Yeah. Well, it probably is, but yeah, like it's a solution to the wave equation. But the thing is, it's not the kind of mathematics I'm used to, because like it's very applied mathematics. Like when I learned maths, like I learned like applied pure maths was like there was like group theory, right? And you have like 3 axioms, and you try to prove all the theorems from the 3 axioms, right? And then in applied maths, it was like partial differential equations, and it was just like a list of ways of solving them without proofs.
What?
It's like how to solve a partial differential equation, and it's just like pretend the solution is this power series and just sub it in and then get all the constants and that's your solution.
Wait, oh yeah. Like how do you know it's...
Wait,
Yeah.
doesn't that sound somewhat like your maths extension question where the solution was it's quadratic.
Assume
Yeah.
it's quadratic and then sub it in.
Applied
Oh,
maths.
it works more.
Yeah, applied maths. Yeah, like or assume
the solution.
Yeah, assume the function can be like, it's a function of 2 variables. Assume the 2 variables that can be decoupled, such as the product of functions of single variables. Just like assume whatever the hell you want.
So it's like their goal is just to find a solution, not the solution.
Yeah.
They just want to find a solution, and then they're like, oh yeah, a solution. Well, physics works, so clearly there's only one solution. So
Yeah.
this must be the solution.
Oh, diffraction.
Physics clearly is deterministic, so this is...
Diffraction. Do you know what diffraction is? Yes. Okay. What is diffraction? Is it like when light goes around corners? Is that what diffraction is?
Do you not know?
I do. Yeah.
I do not know what the function is.
It's like when you put light through like a tiny gap and it just goes boom.
Is that like the Huygens principle? Is that?
I don't know. I heard of this thing where it's like any wave is a superposition of like spherical waves or something.
Yeah, like this Huygens principle thing was like at the wave front, right? It's like every point is like it's like a point source of a new wave.
Oh, so it's like
And so like
oh wait, yeah, I think I've heard of that. Yeah.
So like then when
I was searching up this stuff.
Yeah, so like when the wave goes past like a door or something, right? because the point becomes a new source, it can go around as well.
Oh,
It's just that the door wasn't there, the other parts would just be cancelling with it, and it'll look like it's going in an array. That makes sense. Is that what you know? It's different.
I think this is like the reason why diffraction works.
Yeah, and then diffraction, so like you have like...
It's because like if you put the light through a tiny hole, then that hole becomes a new point source.
And then it becomes a new... So like, it's kind of weird, yeah. Double slit door. I remember this. I remember struggling so much with this kind of stuff. I just didn't understand why people even cared about these experiments.
I still don't know how to replicate double slit experiment. I tried it out when I was a kid, but like, bro, how do you do this?
I think some people are just naturally very practical when it comes to, like, they do the experiment and they interpret the result, and the result means something to them already, right away. It's just like, obviously it means this. It was much more difficult for me. Okay. Wait, so last time we proved that simultaneity was not a thing, right? So in relativity, David, either stuff is absolute or it's relative, okay?
Okay.
So absolute means it doesn't depend on what frame of reference you're in. So like, if you're moving in a train or if you're on the ground. And relative means it does. Okay, so the laws of physics are meant to be absolute. They don't depend on what frame of reference you are, right? But in the Einstein thing, he assumed that the speed of light was an absolute. Okay, usually speed is not absolute, right? Because literally you're moving with respect to watching something move. Why haven't I scrolled down to it yet? Oh, yeah. I remember people were like, it's like every time I sit down the train just comes. So then my conclusion is you should sit down earlier.
That is true.
Simultaneity and time dilation. I really want to see the time dilation one because that was the one that was really cool. So basically, there's two things. See, and obviously, like, so time gets dilated, right? So if the velocity stays constant, right, then the distance must be contracted. And it must be contracted by the same factor that the time is dilated, right? So, because the speed of light is constant, right? So, and the speed depends on distance and time, right? And if the time is dilated, then the distance is going to be contracted.
But what does it mean for the time to be dilated if time is relative?
Yeah, time is relative. So like, time depends on your frame of reference, right? Whereas like originally people thought time was absolute.
What the hell, bro?
The Newton time.
So time is relative.
Time is the time on Newton's clock.
Oh. Like the only constant is just c. And there's nothing else.
Have you learned time dilation before? Oh, that's good. It's in the school syllabus, I think, isn't it? It was when I was in school. Okay, and it was when I wrote this physics book. But I still need to get it published somehow. I tried to put it on Amazon and it rejected it because of I couldn't get it to PDF. It didn't accept PDF, so what's with that?
What?
The time interval between two events depends on how far apart they occur. Yeah, I think this is the standard proof, right?
Oh.
And it always takes me a while to try to get this right, but... So this proof is not only meant to show there is time dilation, it should also tell you what factor it's dilated by. Okay, and it kind of makes it clear why it's that factor, because you have this Pythagoras kind of stuff happening. Yeah?
So what's going on here?
So you have a clock, and the clock is, by design, a light ray clock. Have you seen this one before?
Wait, that's sick.
Yeah, so the clock is supposed to measure time by sending a ray of light to this mirror, a fixed distance away, right? And because you know the speed of light, right? How long it takes for the
Damn, that's sick.
how long
That's
it takes
sick.
for the light to come back.
Oh, that's why it's like 1 with square root 1 minus x or something like that.
Yeah.
Because it's like Pythagoras.
Yeah, so you can like you can define like 1 unit of time to be the time it takes for the light to get there and back. Right? Okay. So that's your clock, right? Oh, I should also remind David and Liam. The fundamental postulates of all this is light is always constant no matter what frame of reference you're in. Okay? The speed of light. And no matter what frame of reference you're in, you can't tell that you're in that frame of reference by just doing things inside it. Okay? So like the laws of physics should be the same inside as it would be if you were in another frame of reference. Yeah? So you have to look outside to realize you're moving with respect to the outside.
So does this functional equation only have one solution?
Oh, what? Which functional equation?
The postulates. Try to answer that, physicist. What's going on here?
Okay. Yeah, so let's figure out how this would work. So you're meant to bring. So I'm not really sure what it's saying, but what I remember it is like you're meant to bring this clock onto your, your spaceship or your train or something, right? And so you bring that clock onto your train. And there's someone else.
Someone else like angles some light. I think they're angling the light so that it travels alongside you.
Huh. Yeah, so if you're with the clock, it looks like this, right? If...
So from your perspective, the light's just bouncing to the wall and back.
Yeah. But if you're moving...
Yeah, so you're always beside the light. Well, at least supposed to be. But how can you be so sure that you can even be beside the light? Of course you can, you're in a frame of reference. So the functional equation is being subbed in. Stuff is being subbed in.
I actually wrote this down somewhere.
That's pretty interesting.
So which one is Sally and which one is Sam? So Sally is on the train. I mean, the general idea is that like, if you bring this kind of clock on your train and it measured the same time, like if it measured a different time or something, you would be able to tell that you're moving. Okay. And so it would have to measure a time in a particular way for you not to be able to tell that you're moving. Okay, Sally's on the train. Measures the time interval delta t naught between events 1 and 2. That clock is shown twice. First for event 1 and then for event 2. Okay, Sam watching.
Derive the equation now.
Sam watching from the station as the events occur.
So, from your perspective, this light bouncing
requires 2 synchronized clocks.
So if you are going this way, and the light go this way, your velocity, this will be 1. The light bouncing towards the wall should be a distance of square root of 1 minus v squared. So therefore, for you, it takes the light is moving at 1, but for them, the light is moving at 1 square root of 1 minus v squared in that direction. It means that. Yeah, okay.
Yeah, so does that make sense? So when the light leaves your thing, right? Like from the moment it leaves, the mirror is kind of moved along with the motion, right? So light starts being emitted, and the mirrors like you're both moving, right?
Is the mirror moved? If the mirror's moved, then we have to deal with the time dilation of the mirror. Like a rose.
I guess the point is like the point at which it hits the mirror, right?
It's still a mirror.
It's like it's the x value is further along than the point at which it emitted it, because the mirror's moved in that time, right?
Are you moving the mirror, or is the mirror just infinite length? I feel like it's easier if it's infinite length, because then you don't have to deal with the time dilation of the mirror. But like you could just say like the mirror appears. It is just there when the light is there to reach it.
Yeah, okay. Maybe you can think of the light as having some sort of horizontal component or something. And so once it's released, like because it's already moving, it's gonna hit something a bit further to the right. Yeah. And then when it bounces, it's got horizontal still, so it's gonna come back down diagonal. Yeah. So whereas this person traveled a distance of 2d, right? Remember the speed is the same, yeah? This person traveled a distance of what? L, 2L, right? In this diagram. What is L in relation to D?
L is big.
L in relation to D.
L is very long. 2L.
So L.
That's proportional to the.
So it's just Pythagoras, right? So you have
LD and then
L squared
Pythagoras
equals D squared plus. Man, I don't like halving things. What? C. No.
Okay.
C delta T squared.
Oh, so this tells you like.
Yeah, over 4.
Okay, that's pretty. Okay, but event 1. Yeah.
So L D what? So D equals L squared minus C squared delta T squared on 4 square root. Oh, sorry, no, that is actually V. It's not C. That's the motion of the train.
How do you get on 4, bro?
This is half. This is half.
L squared equals D squared.
Alright, it should be a V here.
V.
Yeah, so these clocks measure differently depending on where you're looking at. And I just can't keep to remember, but at this point you meant like if Sally didn't notice a difference, if Sally something, she would be able to know that Sally, like she would be able to know that she's moving relative to the outside.
Wait, it's so stoned. Because if Sally did this, wait, who's okay? Sally is on the train, and Sam is doing things.
Yeah.
But then if Sam did the same thing, then
yeah.
Yeah.
It's kind of weird because there's lots of things that like
there's like one guy's time slower than the other guy's time's also slower than First guy, but then you realize no, the time is not actually slow. It's just the events are happening in different positions, and their simultaneity is different.
Yeah, like the one thing that always confused me was like you have this situation, right? And you reach a conclusion and it's a contradiction or something. But like a lot of the things which you would normally think are obviously true, like might not hold in this context. Does that make sense? So just kind of like, are we kind of assuming that Sam and Sally all have agreed simultaneous events and stuff like, or like what it is that we're being assumed. Um, so I think the bottom line is like if Sally had this particular clock, okay, this particular clock should read a different time than the clock that Sam had that's on the ground, right? And if this was some sort of universal time clock that Sam had on the ground, okay, and it differed from Sally's clock, and for some reason like she had access to the universal time, and she also has the time reading on her clock, right? And that she saw it was different, yeah, then she would have to conclude that she's moving, right? Because if she wasn't moving, they should be the same.
So therefore, there is no universe.
And that would violate that principle that she couldn't tell that she was moving. Does that make sense? Yeah, but the assumptions that kind of go into that maybe like are a bit loose in the context of this weird situation.
Wait, I don't understand these terms called time dilation. Like nothing's dilated. It's just how it works.
Yeah, so you get the general gist of the argument, right? So it's like if that light ray clock moves, someone should see a different time reading on the clock. Okay. Then like the reading on the universal clock, you know? Okay. And then hopefully Sally would see the same difference, right? Because it's literally like a clock displaying a time, right? So Sally should see the same display as Sam, yeah? That's actually kind of funny, isn't it?
This is very confusing.
Yeah. Yeah. Yeah, so basically either Sam detects time dilation or Sally knows that she's moving. That's kind of what it feels like right now. Does that make sense? So Sam's like, what the hell, this clock's giving me a different result. It must be because of the motion. Or like Sally's like, no, it's giving, it's because I know I'm moving. Alright, let's have a look.
Okay, I think I get it.
How could anyone get that? I didn't make any sense.
Literally so stone. Like nothing is real anymore.
Alright, so like I think to actually carry these kind of things out, it's really good to keep track of whose frame of reference you're talking about and like what they're seeing and stuff like this. Once you keep track of everything, I think everything becomes more clearly.
Because it's like you think like, oh, but from Sam's perspective, wouldn't it be that? Wait, hold on. Sam is on the ground. Sally's traveling.
Yeah.
From Sally's perspective, it takes less time. So her clock is like faster from Sam's perspective. Okay, so then wouldn't it be that from Sally's perspective, Sam's clock is faster? Wait, no.
Yeah, I mean,
but then you realize, because he's moving, and also the clock is behind. No, Sally's moving, and then the clock is behind her, and so it's like because the clock is behind her, she's seeing into the past.
Yeah, this is like twins paradox thing.
So goofy. No, wait, but the twins paradox requires general relativity. It's like
Okay, so from Sally's frame of reference, the time change was 2d over c. Yeah? Right? So that much time has passed. The two events occur at the same location in Sally's reference frame, and she needs only one clock at that location to measure the time interval. The clock C is shown twice at the beginning and the end of the interval.
Yeah, I feel like we just need an equation to convert from one person's reference frame to another person's reference frame.
Yeah.
Like some function on time.
It's this one.
Wait.
We'll get to this.
But that one only does delta t. Where's the delta?
Okay.
I need f of t.
Okay, that first paragraph is good, yeah?
F of tx.
Sally measures 2d over c as the time. Yeah? Consider now how these two same events are measured by Sam, who is standing on the station platform as the train passes. Because the equipment moves with the train during the travel interval of the light, Sam sees the path of light as shown. For him, the two events occur at different places in his reference frame. So to measure the time, Sam must use two synchronized clocks. According to Einstein's speed of light posture, the light travels at the same speed for Sam as it does for Sally. Now, however, the light travels distance to L. Okay. Yeah, I think this is worth going through. So Sally, Sam, yeah? And by Pythagoras, L is the square root of that, yeah? And we can write this as L equals the square root of that. What? What? We just add a C in there? D is the T naught, yeah? Remember the T naught is this, yeah? So you sub in the T. The D squared is a C T naught on that, yeah? Okay, that's good.
Oh wait, and since we know like oh yeah, so if we get delta t then we also get like we get like the space this contraction or whatever.
Yeah, so if you rewrite this, I guess what they mean by eliminate for L. Yeah, so we used this one already. Use this one to eliminate the L here. Yeah.
Bro, why didn't they just like divide
So C delta T on L L on 2 equals L, right?
Like
From this. And so C squared delta T squared on 4 equals V squared delta T squared on 4 plus C squared delta T naught squared on 4. Yeah? Then you cancel all the 4's. And you want to solve for delta T. So then you get delta T squared equals C squared delta T naught squared over C squared minus V squared, right? And then you divide by C squared, and you get delta T naught squared. David, you're watching this? You're gonna need this in year 12, buddy. Not for the HSC, but there's gonna be someone traveling back from the future to meet you at that moment, to tell you something key. And for you not to be totally perplexed, you must understand this. Okay, 1 minus v squared on c squared. Yeah. Yes. And then so that squared equals that, then you square root it, you get this thing here. Yeah. Okay, so delta t is the time that
Why do they say
Sam
less
measured.
than-
Huh?
Bro, I agree.
And delta t naught is the time that Sally measured, right? And the times are different by a factor of this. This is the time dilation factor. So length contraction is going to be just it's in the numerator, and it's the same factor. Okay. Yeah. So Sam measuring the time. So Sam felt it took longer for the light to come back, right? Because it went hypotenuse. Sally thought it went pretty quick.
Sam's like boing.
Okay. So they kind of explain it like this. So it's meant to be the same two events. Hmm. Is it really that simple? To measure the same two events. The events are like the events of a clock, like the inner workings of a clock. They're the events they're looking at. I think I've always understood it differently because, yeah, yeah, like if there was a universal time, then this time that Sam measured, like you could bring that with you on a device, like the universal timekeeping device, and that would show Sally that like Sally essentially should have access to Sam's measurement of that time interval because like Sam's just using just like this universal clock, right? And so Sally's using this weird clock and is noticing that it's different from the universal clock, right? And both clocks are with her in this ship, right? So then from that she can tell that she's moving, which is like violates the postulate. That's how I understood it. Because I'm kind of confused when they say the two events are the same. They're looking at the same two events. Like,
Yeah, because the problem with relativity is like you have you have some factors in the rule. It's like the first factor is like the dilation crap,
yeah,
and then the second factor is like receiving the events in the first place at
Yeah.
light speed. So it's like there's two factors which make it confusing.
yeah.
But like
And the
this-
distances,
the
like,
special relativity, they're like they remove the light traveling to you, information traveling to you factors. It's like
yeah.
uh,
And it feels like also like sometimes like if you're learning about time dilation and you don't yet know about distance contraction, then like we don't notice all the stuff we're assuming about the distances in this argument, and we just accept them. But then if you come back with distance dilation or contraction in mind, it's just like, are these things still correct? You know what I mean? It's like is Sam looking at
yeah.
the
'Cause, like,
distance
yeah.
a dilate? Like if Sam was looking at a dilated distance and like then he would measure and he measures the same time. You know, it's like
Yeah, because like this is assuming that if you're traveling in a certain direction, distance doesn't dilate in perpendicular directions.
yeah,
Which is like, is that true?
yeah. So it's also true that the distance only dilates in the direction of travel, I guess.
Yeah, well, like you have to assume
It doesn't
that for
dilate
this.
in that direction. Yeah.
So why is that true? Why shouldn't the distance dilate?
So it's kind of so like whether or not you can like think about it completely to the conclusion, it's still interesting to think about these things logically, right? Because there's not really that many things. There's like not that many variables. So that's what makes thinking fun. Is when there's not too many variables, but you can kind of think deeply about the variables that are there. So we have the time, we have this light traveling, and we have some sort of very simple setup, right? Yeah, so I think the way I've always understood it was that, you know, Sally should have access to Sam's clock in some sense if there was a universal time, you know? And so all the measurements are actually just made by Sally in some sense.
And then you have to prove it's like consistent. Like if there's 3 people, and then one guy's measuring, it's like, and then the one guy's measuring the other 2 guys, and then you have to see like if the other 2 guys are measuring each other, is that consistent with the first guy?
Yeah. Yeah, but here it just says the same 2 events measured different times. Yeah, at the very least, I think this argument shows something is up. Okay, and at the very most, it tells you that exactly this amount of time dilation is up. Right, so that's very specific.
The proper time.
Hmm.
So the proper time between 2 events is in the
Yeah, these kind of
the
terminologies
reference framework.
can make things even more confusing. Like, if you don't understand it, and then someone throws proper time at you, you'll be like. But if you do understand it, and someone throws, it's just like one more thing.
Does proper time make it easier to symmetrically define?
Yeah, so like time dilation, length contraction, mass dilation, it's all by this factor. So it's dilated if you divide it, it's contracted if you times. Okay.
Damn, beta.
Beta.
Yeah, why aren't our units just the speed of light, bro? Honestly.
Yeah, so I think that the thing that bails physicists out is like they never really have to understand it like perfectly, because what they can always do is they can just always ask God for the answer. Like it's like, well, if what this is true, we should be able to test it in an experiment, right? And I guess maybe this is like why people don't like string theory or something. They can't find experiments to test the difference between having string theory and not having string theory. But like, so like they sent like a so maybe this was the 2 tests. So they sent they sent some clocks around the world, like going in like a plane or something, right?
Atomic clock.
Yeah.
So weird.
So atomic clocks, you know how atomic clocks work? So like it's meant to be like the half-life of a substance. You know what half-life means? It's like the time it takes for half of it to go. It's meant to be constant. It doesn't matter how much you have, right? So if you know that, then you measure how much is left is how much time has passed. Yeah. It's kind of how they do like carbon dating and stuff. Yeah, so they got that kind of thing. And I guess the reason you want something like that is because like you need a lot of like you're traveling very small speed compared to light, right? So even if there is time dilation like that, like v over c is like less than a millionth of a, like, so like you need like fractions of a second like to detect any time dilation if at all. So then that's why you need this kind of atomic clocks to be really accurate, and you detect it in like, I don't know, like the 8th decimal place or something. I always remember like I thought it was really cool in high school to remember like this funny definition of a second. It was like the second was like the time it takes for like 9 billion something 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 periods of cesium radiation.
Oh yeah.
Yeah. And then it's like, and then in year 12 they're like, no, a second is the time it takes for light to travel 1 over the speed of light. I'm like,
Oh, that's
no.
so circular.
No.
What the hell is that logic?
Yeah. It's some cesium thing,
The
right?
speed of light is defined using the second, and the second is defined using the speed of light.
Yeah, and I guess we're kind of trusting their results here, right?
That is like...
So the actual measured value matched the result within experimental error.
Oh, yeah, so I believe it exactly 6 today.
How did they
Oh,
even
okay.
actual
Yeah.
measure
Alright.
value?
It's good seeing you, Liam.
Good seeing you too.
I'm wondering whether we should have Sunday class on this Sunday or the next Sunday. What do you think? Leaning towards next Sunday.
Thank you, sir.
Alright, have a good one, Liam. So isn't it crazy? Like it's literally like 63 microseconds worth of time dilation. 63 millionths
Damn. So they just
of a
like,
second. I feel like you could make a mistake and just kind of like, what if you just didn't start it on time or something?
oh no.
So within experimental error, what does that mean?
It's
Yeah.
just like what error?
Yeah. But that's kind of how trusting we are, right? No one's ever, I bet you no one like, I've never really looked into like,
Yeah, because it's too much effort. Like you're just like, yeah.
maybe only the true physicists would actually look into the actual experiment. Like we kind of just trusted that happened, right?
Right, thank you, sir.
Oh, see you, Liam.
See you.
We'll see you on Monday.
See you on Monday.
Macroscopic clocks. Richard Keating carried out what must have been a grueling experiment. They flew 4 portable atomic clocks twice around the world on commercial airlines, once in each direction. The purpose was to test Einstein's theory of relativity with macroscopic clocks, as we have just seen. Yeah, so it's kind of like if you didn't understand the logic of that weird argument, it's like you can always just fly a clock around the world. Okay. As we have just seen, the time dilation predictions of Einstein's theories have been confirmed on a macroscopic scale. What does that mean? There is great confidence in a confirmation made with an actual clock. An actual clock. What does that even mean?
A true clock.
Only because of the very high precision of modern atomic clocks. Verify the predictions of the theory within 10%. Einstein's
10%.
general theory of relativity, which predicts that the rate at which time passes on a clock is influenced by gravity. Oh, the general theory says that the clock's even influenced by gravity. Wow. Okay.
Oh yeah, because they're like getting accelerated upwards.
Okay, a few years later, physicists at the University of Maryland flew an atomic clock around and around over Chesapeake Bay for flights lasting 15 hours and succeeded in checking the time dilation prediction to better than 1%. Today, when atomic clocks are transported from one place to another, for calibration or other purposes, time dilation caused by their motion is always taken into account. That's kind of funny. It's like your clocks were just getting more wrong and wrong. Can I do a sample problem?
Oh my god. The quick toilet. Sounds pretty cancer.
Sometimes we need to...
Oh yeah, so basically like here you could, if you had any two events, you could just like convert it to the principal time.
Your starship passes Earth with a relative speed of 0.9999 c. Yeah, so notice, see, what's the extra zero there, huh? Because the extra zero is like for the error, you know, the physics error. See, because if you say 100%, it could actually mean like 99.6%.
Those
Up to error,
significant figures.
Right.
Oh yeah, so they're basically saying it's not the speed of light.
Yeah.
By adding this.
You stop at lookout post LP13. Oh, it's so annoying. I guess LP stands for lookout post. Turn and then travel back to Earth with the same relative speed. The trip back takes another 10 years. Oh. How long does a round trip take according to measurements made on Earth? You know how to do that?
Yeah.
Yeah. Okay. Well done. I think she realizes the key to physics. Don't you just sub it in? That's literally like band 6. Band 6.
Subbed it into equation.
Yeah, like literally they could replace if you didn't need the actual marks, you just need the bands. You could just be like how do you do this physics problem? And then people would say, don't you just sub it in? It's like band 6. This is band 6. Alright, good. Just
You
sub
should
it.
have to cut out all the crap.
I guess one thing you want to know is like you should get more than 20 years, right? Yeah. It's being dilated. Yeah. So whereas we only care about how to do it, you might actually care about the actual answer. What? 448 years?
What?
What the?
That's crazy.
So that's like a physics moment right there. So you thought you got it wrong because it's 20 years turned into 448 years. So all your relatives are dead, right?
Damn.
Yeah. But from your relatives' point of view, it is you who is no.
No, that's not.
No, it's not true.
Because your favorite reference changed, so it's like theirs didn't. So now it's confusing.
Yeah, so this is part of like a twin paradox, I guess.
Yeah.
It's like, why is it the person on the spaceship that's still alive? Why isn't it the other people that are alive?
Yeah, the thing is, it's not symmetric because
like you have like one.
The two events that are happening, which is you going and your returns, they're like the principal. I don't know. What do they call it?
Proper events. I don't know.
The proper time is measured from their point of view, but not from your point of view.
So I think the twin paradox is like you have twins and one of them goes and one of them stays.
Yeah, it's like.
And then whack happens. Okay. Oh, time really got away from us again. Okay.
Who is to say that twins are?
Oh. I dare not start something else.
Recording stopped.
Alright, what's the over and under on how many hours this stream? Huh?
So, man's confused.